Today we will continue with the thermodynamics. Okay, that all kinds of things I think have discussed by the man. Okay, let's discuss about the thermodynamics. So firstly, question is asking inside your mind is that what is thermodynamics and where it will be used. So I'm explaining few things regarding to this. Be active and getting more energy. Okay, so what is thermodynamics? Thermodynamics studies how heat works and energy transfer into one other two in bulk matter. It is microscopic, deals with measurable quantities like pressure, volume, temperature, not individual molecules. It laws apply to energies, refrigerator, biological system starts universally. And fourth thing, four cornerstones, zero, first, second, and third law. The zero defines temperature, the first energy conversion, and the second sets the direction of natural changes. By the end of this chapter, you will be able to decide in this process how much heat becomes useful for work. So mainly thermodynamics, it's a branch of physics in which we are studying about the heat, work done, and energy. And we can also deals with that how energy can be converted into the other system with the help of work done. Sometimes we are providing the energy to the system. After that, this energy can be can be converted into the work and sometimes internal energy of the system also. So that kinds of thing we will deal with the help of thermodynamics of the physics branch. Okay. So mainly in this chapter, mainly we are dealing with the, you can say, pressure, volume of the container, temperature, energy, that kinds of thing we will discuss. And also thermodynamics have three types of law, which is first law, zeroth law of thermodynamics mainly states to you that the temperature, if two body having in the temperature equilibrium, okay, and if it we have a three body, and if three body have a temperature equilibrium, which is Ta equals to Tb and Tb equals to Tc, then we can say Ta temperature of A that will be equals to Tc. That was the zeroth law, which defines to you temperature. Okay, we will discuss about it in the, very deeply after that. And the first law of thermodynamics mainly states to you whenever you are giving energy to the particular system, so this energy will directly converted into the work done by the system, then plus change in internal energy of the system. So that kinds of statement which is very useful in the thermodynamics, you can say, branch. Okay, because with the help of first statement, all of these kinds of things, whatever you are saying in inside your environment, these all things like vehicle, steam engine, and you can say your microwave or all kinds of things mainly works with the, you can say, depends mainly works on the based upon first principle of thermodynamics, which is energy conversion principle. And by the end of chapter, we can also deal with some beautiful processes like isothermal, isochoric, and isobaric. That kinds of process we will understand regarding to it. Okay. So firstly, let's start about the what is system, what is surrounding, and what is boundary. So system mainly is it is the part of universe under study. Gas inside a cylinder, liquid in a beaker. Surrounding means everything outside the system, and boundary means the real or imaginary surface separating the system. So system mainly is that you are considering a particular thing on which you are studying on that particular particular identity. So this entity on which you are studying particular calculation, you are studying on the particular calculation, that kinds of thing you can assume as a system. And rest of the thing except the system, that was your surrounding. And the thin layer, or you can say it can be imaginary, it can be, you can say, physical layer that divides the system into the surrounding, that is called the boundary, or you can say wall. For an example, let's say I am giving us some example like that. Like this is the container having gas pressure is P and temperature is T, then final pressure of the gas when temperature becomes T0. So all of these kinds of study you are considering on the gas. So according to your calculation, gas is the system, and rest of the thing which are surrounded by the gas and particle container, that is called the surrounding. And the containers wall, which are showing in your system, that is separates for your system gas into the surrounding. These walls are called boundary. So these kinds of things we have discussed. Okay, so that was system, that is surrounding, and that is boundary. I think I have to reduce the pen thickness. Okay, now is it good? Okay, now third thing which are sharing to you, three classical type of system based upon their boundaries alone. So firstly, open systems, second closed system, third isolated system. Open system exchange both matters and energy. Boiling open pot. Closed system exchange energy only no matters, sealed kettle. And isolated exchange neither. Ideal thermos flask. For example, we have two types of things which we can consider. For example, look at this example. In this gas and container example, if if a matter of gas, you can say gas molecules, can be moved to the surrounding and their energy can be transferred to the surrounding from the wall. So that kinds of, you can say, system, I can say that is open system, because energy and matter both can be transferred to the surrounding. And if matter cannot be transferred but energy can be transferred, then that is called closed system. Okay. So for example, sealed kettle and boiling open pot. Boiling open pot is the, you can say, open system example. Enclosed sealed kettle means energy can, sealed kettle means you are a kettle in which you are filled with the tea. Okay, and tea having some temperature. So you already knows about that. Heat can be transferred from higher temperature to lower temperature. So surrounding temperature is lower, tea's temperature is hot. That means heat energy can be transferred to the hot body to cold body. That means heat energy can be transferred from the kettle. So energy can be transferred after that kettle's temperature reduced, but tea still remain in the, you can say, kettle. That means this system is called closed system, in which matter cannot be transferred but energy can be transferred. Third one is isolated system. Exchange neither. Ideal thermos flask. Isolated system means nothing, energy cannot be transferred and matter will also be cannot transfer. That kind of system is called, you can say, thermal flask, or you can say isolated system. So thermal flask you can slightly consider as an isolated system, because in the thermal flask we can consider that temperature of the matter will not be changed. Heat energy cannot be transferred from the boundary. Got it? So these three kinds of system surrounding boundary I have explained the definition, and three types of system I have explained you: open, closed, and isolated. Got it? Here are some simple diagram regarding to is matter and mass both can be transferred. Closed system, mass cannot be transferred but heat can be transferred, and isolated system means heat and matter both cannot be transferred. Let's talk about the thermodynamic equilibrium. What is thermodynamic equilibrium? So thermodynamic equilibrium mainly states a system in thermodynamic equilibrium when pressure, volume, and temperature don't change with time, no microscopic flow of matter of energy. For example, I have a particular container, okay, and it contains some matter. Got it? This system is called thermodynamic equilibrium system when mass of the matter will not change, pressure inside the, you can say, container will not change, temperature of the container will not change with respect to timing, and third thing, energy of the system will not be transferred to the other. So if of a particular system of a container, if their matter quantity, that means mass of the quantity, pressure inside the container, temperature of the container, energy transfer from the boundary, if both of these things are nothing to happen with respect to time, then we can say that this particular system is in thermodynamic equilibrium. Okay, and we can say two systems are in thermal equilibrium when they have the same temperature. Thermal equilibrium means two systems, let's say a system having some, you can say, ice, and second system having, you can say, water. If ice temperature directly equal to the water temperature, then we can say that both ice and water having thermal equilibrium. Thermal equilibrium slightly you can refer to you that both temperature of the both body will be same. Got it? That is the thermal equilibrium. Let's talk about the adiabatic wall, and let's talk about the diathermic wall. Adiabatic wall mainly refers to you that heat cannot be transferred from the adiabatic wall. Okay, but both you can say both systems are separated by this adiabatic wall, so that heat cannot be transferred with them. You can take an example with that. For an example, if you have a water container, and let's say I am just apply a you can say thermal insulator wall. Let's say thermal insulator wall you can assume as a, you can say, wooden wall on which heat energy cannot be transferred. And if I drop out hot water and if I drop out a cold water with a second partition, then you can see that no energy will be transferred from the wall, because wooden is the thermal insulator. No heat energy can be transferred from the wood. So, and in this case, wooden wall is your adiabatic wall. Okay. So you can see that insulating prevents heat exchange. Bodies on either side may have different temperature. Got it? So we can adiabatic wall. You can just assume we are applying a thermal insulator wall between two bodies, so that temperature of the both body will not be changed. Okay. So that is called adiabatic wall, and that kind of process we will deal in the thermodynamics. Okay. Fourth thing is a diathermic wall. Diathermic wall, you can see conducting allow heat exchange. Both sides finally reach the same temperature. It is the opposite condition of the adiabatic wall. If I apply, you can say iron wall. So iron is the conduction. Iron can conduct the heat also, conduct of heat and current also. So that we can say that heat energy can be transferred from the hot body to cold body. And after thermal equilibrium, that means both body will have same temperature. So with the help of diathermic wall, energy can be transferred from the diathermic wall, so that final temperature of the both bodies will become equal, because both bodies will get thermal in equilibrium. So that is called diathermic wall. Let's talk about the zeroth law of thermodynamics. That is also same thing. If I tell you, if three bodies are in thermal equilibrium, okay, so we can see that temperature of the first body will equal to temperature of the second body. And if I told you temperature of the second body, that is equal to temperature of the third body, then according to zeroth law of thermodynamics of temperature, we can say that temperature of the first body will directly equal to the temperature of the third body. Got it? So that is the zeroth law of thermodynamics, mainly which directly showcase to you that how 1 to 3 body will get into the thermal equilibrium. Got it? So mainly statement is if two systems A and B are each in thermal equilibrium, I have already told you, with a liquid C, then A and B are in same thermal equilibrium with each other. That kind of thing I have already told you. If I talk about TA is equals to TB and TB equals to TC, then I already directly say temperature of A that directly equal to temperature of C. Got it? Now, significance gives a logical basis of defining temperature all bodies in mutual thermal equilibrium. That is also simply logical explanation that it can also define your temperature of any types of different body, and it can also define your temperature of any body also. Okay. A thermometer is nothing but in the third system. This is why a single number temperature can be described the thermal state of the body. That is the single kinds of thing we can say. If a body having higher temperature, then we can say that heat energy in this body is too high. Okay. If a body loses their temperature, that means heat energy it's decreased from this body. That kinds of thing we can identify with the help of zeroth law of thermodynamics. Okay. Let's talk about the heat, temperature, and internal energy. Heat is what? Heat is the energy. Heat is the energy. Energy is what? It is the such type of energy so that any particle or it is any system, whenever providing the heat energy, they changes its temperature. How temperature is changed? Because every molecules inside the, you can say, container or you can say system, after getting the heat energy, every molecules getting, you can say, kinetic energy, or you can say every molecules are vibrating with our particular mean position. So due to mean position vibration, they have lots of energy, or this energy will be loose as the, you can say, due to temperature change. So heat energy mainly is such kinds of energy so that every body can changes its temperature. And why temperature is changes? Because every molecules inside the body will have, you can say, vibratory motion, and after getting the heat energy, their vibration becomes too fast. Okay, so that is called heat. Temperature, I again told you that temperature, it is a measure how hot and cold body decides the direction of the flow of heat. That is the again simple thing is that temperature, how temperature feels to us, how body is hot and cold. But main things, temperature in the technical form, it defines to you that how every particle having energy, how much energy they having in the vibratory motion. Okay, that can be defined as a temperature. If a body having higher temperature, that means every molecules inside the body having higher vibratory motion, higher kinetic energy, they are oscillating at the very fast. Okay, and their time period frequency, it is very high. Okay, So that is called the temperature definition, by which we can say it mainly refers to either how hot and cold of any body, and it is decide also to you that how heat energy can be transferred in the bodies. Okay. Let's talk about the heat energy in transit. Because temperature difference, heat exists only by flowing. Again, simple thing, heat is the energy which can be transferred from higher temperature to lower temperature. Higher temperature to lower temperature. Similar kinds of thing we can say that if any body loses its energy, that means its temperature get reduced. Its temperature get reduced, that means heat energy has reduced from this body. And if body increases its temperature, that means uh, heat energy flowing inside the body. So that is also giving you the temp. With the help of temperature, we can assume that what is the direction of heat. Okay. Let's talk about the internal energy. Internal energy, the total kinetic energy, the potential energy of the molecules of the system. That is again same thing which I already told you, that whenever you are providing the heat energy to the particular system, then system every molecule is getting some energy. That energy that is called kinetic energy, potential energy, and you can say vibrating energy. These kinds of energy conversion of heat energy inside the molecules, this energy is called internal energy. So if you provide, you can say any energy to the system, that means system firstly work with the particular part of energy, and rest of the energy will be converting, yeah, you can say converting into the internal energy of the system. So U is the state function, depends on the present state, pressure, volume, and temperature, not on how system reach it. So mainly internal energy is the state function. It depends upon the initial state and final state of the particular system. It doesn't mean that how this final state reach. For an example, if I give you a particular thing like that, it is a work done, it is a temperature. Okay, it is a heat and it is a temperature. Let's say initially temperature of the body, it is TF. T initial, okay, and after at some time temperature becomes final temperature, and let's say this process has to be done by three process like this, these three paths. So mainly internal energy refers to this, it is totally depending upon your initial and final state. That means initial, you can say initial internal energy and final internal energy, the delta U change in internal energy will be same during all the paths. Okay. So mainly change in internal energy mainly does not depend upon the path. It's totally depend upon the states. What is the initial temperature? What is the final temperature? After separating of the some particular formula with that particular formula, you can easily find delta U. It doesn't mean that how path you have followed to reach the final temperature. Okay, so that we can say to that internal energy is the state function. That is not a path function. Then what is the path function? Path function is the work done. How you reach the particular state of the body. So the path is matter for the you whenever you are finding the work done. So work done is the path function. Energy, internal energy is the state function. So again, next thing which I am describing to you, for an ideal gas, U depends only the temperature. Again, same thing for ideal gas, U mainly depends upon the temperature. So delta U, you will be right F by 2 and RT. So you can see that delta U mainly depends upon the change in temperature. F is the degree of freedom and the number of moles. R is the universal gas constant. Got it? So that concept we will discuss in the later whenever we are studying about the heat energy in the separate way. Now talks about the heat and work, two modes of energy transfer. So whenever you are providing a heat energy to the particular system, then heat energy directly converting to the work, and vice versa statement is also correct. Whenever you are doing some work done, then your work done sometimes convert into the, you can say, energy. For an example, whenever you can say, whenever you are driving a vehicle, okay, so in the vehicle you are filling the petrol, and petrol is the combustion fuel. So after combustion inside the, you can say, after combustion inside the, you can say, your petrol fuel pump, your energy directly transferred to your engine, and engine has started, and after starting of this engine, your motor vehicle directly move with certain velocity. That means your energy of combustion, that means you can say chemical energy or heat energy during combustion will be helpful to providing the work done to the system so that your vehicle can move with a certain velocity. That means I am telling to you that heat can be converted into the work done, and similar opposite result will also be true. Work can be converted into the heat energy also. For work can be converted into the heat energy. You can assume like that. If I talk about the electric heater, then you can say that you are providing energy as an electrical form. So any battery who have potential, let's say V, then they are you can say providing energy that will be equal to I square R T. Got it? So I square R T is the energy transferred by the battery to the heater, and this heater can be give you the heat energy inside the, you can say, cold winter season. Okay, so this energy transfer of the work done, battery pro give you the work done, or you can say energy that is equal to I square RT. This electrical work done that directly convert into the your heat energy. So this energy transfer from the work done to heat and heat to work done can be done with the help of thermodynamics process. Now we will deal with the how this work done converted into the internal energy. What is the direct formula so that you can find the work done internal energy, and you can easily identify that what is the relation between heat energy to work done and internal energy. Got it? So first of thing, in energy enters or leaves a system in two different way. First heat and second work done. Energy can be transferred with the two way. First due to heat, and second due to work done. You can say share the energy. You can transfer the energy. So heat transfer due to temperature difference. Okay, heat energy can be transferred due to temperature difference. Whenever you are providing the heat energy to the particular body, temperature also change. And also work done transfer due to mechanical force acting. So work done can be done as about mechanical force to the particular body, then work done can be happen. This concept we have discussed in the last lecture. Okay, so through a displacement, I already told you both Q and W are path function. Their values depend on the specific process followed, but their difference Q minus W is a delta U, that is the path function. That is path independent function. I already told you that Q and W both are path function. It's merely depend upon and how process will reach to the final state. So path is also matter for this Q and W. Q is the heat energy, W is the work done. But after subtraction of the delta Q minus W, that will be give you the delta U, that is internal energy. This internal energy is always stay in the, you can say, that is the state function. It is independent of the path function. Okay, so look at this example. Here is a graph. Delta U is the same for all path, state function, Q and W, path function. I already told you this kinds of condition. Let's say from at point A, pressure and volume is P1 and V1, and at point B, pressure becomes P2, volume becomes V2. So during the all to this part 1 and 2, work done and you can say energy transfer, heat energy, both are depending upon 1 and 2, but change in internal energy mainly depends upon initial stage to final state. Got it? So delta U will be same for path 1 and delta U will be same for path 2 also. Got it? So here are some sign convention. That means whenever you are providing the energy to the system, then heat given to the system, that will be, you will consider as a positive. When energy released by the system, that energy you can consider as a negative. That is the sign convention which you have to understand whenever you are solving the particular numerical. Got it? So I'm writing in front of you. You are providing energy providing to the system, and let's say you transfer Q energy to the system. So that's Q you will be written as a positive. When energy transfer to the system. Got it? But when energy taken from the system, when system releases energy, I am writing like this. Okay, when system releases energy releases, then you can say energy you will consider as a negative. Okay, so there's this two sign convention you have to understand whenever you are solving particular numerical. Again, first law of thermodynamics, I already told you that first law of thermodynamics mainly refers to that how heat energy provided to the system, or you can say how heat energy getting to the system, how it will be converted with parameters. That means whenever you are providing the heat energy to the system, then this heat energy will be divided into two parts. Firstly, this energy divided into two parts. That means system firstly do some work done with the help of this heat energy, and some energy will be stored in the internal energy. You can consider like that if you provide so joule energy to the system, that means you can consider that on the basis of efficiency of the system, 80 joule work done will be done by the system and 20 joule energy will be stored as an internal energy. So that is the meaning of thermodynamics. Thermodynamics first law. So thermodynamics first law mainly based upon energy conversion. Heat provided to the system will directly convert it into the work done by the system plus internal energy stored by the system. So that is the simplest formula to the, you can say, that is the simplest formula of the, you can say, first law of thermodynamics. Delta Q will equal to delta U plus delta W. Meaning heat added to the system usually partially to change its heat energy and partly to be worked on the surrounding. That kind of thing I have already told you. Sign convention I already told you. If heat absorbed, that heat absorbed means system getting energy from yours. That means heat you can consider as a positive value. And if delta Q is negative, that means heat is released. This famous example of this, you can say sign convention, you can say exothermic reaction, which is part of, you can say, heat release. Heat release. Okay. And endothermic reaction in the chemistry, you can say heat we are providing. So in this both case, energy in the release in the heat exothermic reaction and energy is absorbed in the endothermic reaction. Got it? Few example, that means you can consider that whenever you are, you can say, whenever you are, you can say burning something, then you can say that some energy you can be see as a light form. That means energy has released with the form of light. For example, whenever you are on a particular, you can say light bulb. Okay, so electrical energy directly convert into the light energy. Okay, photo energy. That means so photo energy released. That means this photo energy you will consider as a minus Q. And if you are providing the energy to the system, like for example, you are applying electrical energy to the system, then this energy you will consider as a negative. Got it? And work done by the system, I already told you that whenever you are whenever you give the energy to the particular system, let's say you are providing some energy, external heat energy to the particular system. That means engine is working. Engine is working to do a particular task. That means some energy has transferred to the work done and some energy has been stored to the internal energy. Okay, so work done by the system you will consider as a positive. Work done on the system, whenever you are doing a work done on the system, then you can be considered as a negative value. Okay, explain why heating a gas either raises its temperature, delta U makes it expand, delta W, or both. So delta Q will be equal to delta U plus W. Here are some practice questions so that you can answer the particular. You will get some better understanding regarding to first law of thermodynamics. So a gas absorbs 500 joule of heat and does 200 joule of work done. Find the change in internal energy. So main word is the very important. When gas is the system and gas absorb energy, which is 500 joule, that means delta Q you will consider as a 500 joule with the positive value. If question is written as a gas released 500 joule energy, on that case you will be right delta Q will equal to minus 500 joule. Understood by everyone? So gas is a system and it absorbs energy. That means I am writing 500 joule. Okay, heat already given and does 200 joule of work done. So work done by the system you will also consider as a positive. That means 200 joule of work done. So what is the change in internal energy? Apply first law of thermodynamics. That means delta U plus W. Apply, you can say, given heat energy given to the system, that will be converted to the delta U plus W. So delta Q you will be right is already given 500 joule. That means delta U have to find, and W is the work done, which is the 200 joule. So delta U you will get 300 joule internal energy stored by the gas. So option A is the correct answer. Got it? Second thing which you have to understand, a gas expand isothermally. A gas expand isothermally means temperature of the system. Isothermal means temperature of the system will always constant. Temperature of the system always constant. Got it? Remember this thing which I told you. Okay. So isothermally and does 40 joule of work done. Find the absorbed of the heat absorbed by the gas. So in earlier at the starting of the chapter, I told you that heat energy is the state function. First thing which I told you, and I already told you that it's totally depend upon the initial and energy state to final state of the, you can say, of the body. Two things I have already told you. And third thing which I told you, the internal energy mainly depends upon the temperature. If temperature changes, internal energy changes. If temperature constant, change in internal energy constant. So if internal energy does not change, that means delta U will be zero. Because if internal energy does not change, that means initial internal energy that will be equals to final internal energy in the isothermal process, because temperature is constant. I already told you. So if temperature is constant, that means internal energy of the both case, final and initial will be same. If final and initial will be same, that means delta U will be zero. If delta U will be zero, then you can apply the first law of thermodynamics, in which 40 joule of work done, a gas expand, 40 joule of work done has done. 40 joule of work done has done by the gas. That means delta W you will consider as a positive value. That means 400 joule. And find the heat absorbed by the heat absorbed by the gas. That means delta Q will be positive. So delta Q will be delta U plus W according to first law of thermodynamics. So delta U is zero. That means delta Q will be equal to the work done by the gas. Got it? So delta Q will be heat and absorbed by the gas. That means that will be 40 joule. So option C is the correct answer. Got it? Now again, few things which I explained to you. What is work done by the gas? So work done by the gas mainly refers to as PdV. How it can be happen? For an example, you can say that here is the piston, like C, and here is the container, and it is the piston. Okay, and you are applying the external force F external. Okay, work done is what? Work done is the force multiplied by displacement. You can consider as if this work done by the, you can say, if initial volume of the system, that is V1, and final volume after displacing of after displaced this piston by the delta X by the external work done, that is delta X, then final volume becomes V2. Okay, so what is the work done? Work done we will be right. Work done will equals to F external multiply by delta X. Got it? F external you can be right as W will equals to P external multiply by area of cross sectional of this piston, P external multiply by A multiply by delta S. So A multiplied by delta X is what? That is the change in volume. So W work done by the, you can say, gas work done on the system, that will be referred as P external multiplied by delta V. Got it? And if volume is changes slightly, if volume is changing slightly, that means you can consider the dV volume has changed. So you will be right, small work done dW will equals to integration of P external multiply by dV. So work done you will be get P external multiply by dV. And if we have certain value of volume change, then you will be right P external multiply by delta V. So these kinds of things we have discussed in the work done by the gas. So work done by the gas on the system, whenever you are applying external force, work done on the gas, you will be considered as a positive, and work done by the gas by, you can say, expansion, you will be considered as a negative. Got it? So a gas confined in the cylinder pushes the piston area outward by dx, elementary work done dW by F dot dx, and P dot A multiplied by ds, that also give you PdV, which I have already explained to you. So total work done will be integration of PdV. Graphically, W equals to the area under by the PV curve. Okay, that kind of thing is all we'll also discussed. Whenever you are whenever you have a PV curve like this, then area under the PV curve will give you the work done by the system. Okay, so here is the piston cylinder heat transfer to the work done. That is kinds of thing which I have already explained you by the help of piston example. And here is the few example of, you can say, work done by the system whenever you have a PV curve. That means you will apply P area under by PV curve, that will equals to work done by the system. Okay, let's talk about the heat capacity, specific heat, and molar heat capacity. So heat capacity is what? Heat capacity can be written as S equals to delta Q by delta T. Heat needed to resist the temperatures T by 1 Kelvin. So heat required to the particular body so that temperature can be converted, that means temperature can be increased by the 1 Kelvin. That kinds of energy is called heat capacity of the body. So you can see the relation between delta Q and heat energy, and delta Q and S and change in temperature relation will be delta Q is equal to S delta T. That is heat capacity, which is written like this. Okay, specific heat capacity, that means uh, per unit mass. Okay, specific heat capacity, that means heat capacity of per unit mass, that is called specific heat capacity. Got it? For example, if you have a 10 kg, you can say ice. Okay, 10 kg ice. If its heat capacity, you can say as a 10 joule per Kelvin. Okay, so what is the specific heat capacity of this body? So you will be right heat capacity of a unit mass. That means 10 divided by 10 will give you the 1 joule per Kelvin. That means at 1 kg mass will have 1 joule per Kelvin heat capacity. Let's talk about molar heat capacity. Again, it is showing to you that heat required to the system so that 1 mole of the substance can changes its temperature up to 1 unit. That kinds of thing we can say molar heat capacity. So it can also write as delta Q will equals to NC delta T. So N is the number of moles. Sorry, it will be right NCN, molar heat capacity. Okay, so it can be written like this. Got it? So water has specific heat capacity 4186 joule per kilo Kelvin. That means what is this? This is the specific heat capacity of the water. Okay, one of the highest. Explain why it is used as a coolant. Okay, difference is per kilogram. Okay, and C is per mole. Both describe the same physics. Main thing is that specific heat capacity can be written as small s, which mainly refers to that heat capacity per unit mass, and molar heat capacity can be written as capital C. That mainly refers to that how much energy needed so that 1 mole of the substance can be raise its temperature up to 1 Kelvin. Got it? So that is molar heat capacity. Okay. So both are same. Here's the direct formula. It is the direct formula. Okay. Let's talk about Cp and Cv in the mere relation. So mainly Cp is what? Cp is the specific heat capacity at constant pressure. Whenever you have a, you can say particular system, and system having, you can say constant pressure. That system process is, we can also call isobaric process. When system undergoes in the isobaric process in which pressure is the constant, then on the time specific heat capacity in the constant pressure of the system, that is called Cp. Okay, and Cv, that is same kind of thing when it is the molar heat capacity at a constant volume, you can say. So that is the both thing which I am already told you, that both are molar heat capacity but different process. Molar heat capacity, different process. Both are molar heat capacity but in different process. If process is, you can say isobaric, that means pressure is constant, then you can say that that is Cp, which is again molar heat capacity at constant pressure. And again, if process is isochoric, that means volume equals to constant. If volume is equals to constant, then specific molar heat capacity becomes Cv. And what is mere relation? Mere relation mainly defines to you that what is the relation between Cp and Cv. Okay, so mere relation mainly directly showing to you that Cp minus Cv will equals to R. R is the universal gas constant. Got it? For energy case, you will be right R value it's 8.314, and for, you can say, whenever you are doing calculation about the pressure, then you will be right 0.08 value, okay, of R. So both value of R changing on the basis of your calculation. Whenever you are doing calculation about the energy, then you will be use 8.314. And whenever you are doing calculation regarding to, you can say, pressure and temperature, then you will use 0.08. Okay. Okay. And Cp minus Cv, it is the molar heat capacity of constant pressure and molar heat capacity at constant value, and their relation will be Cp minus Cv equals to R. Okay. So these kinds of things I have already explained. Okay. Most of the single thing is that Cp is always greater than equals to Cv. That means why? Because according to this formula, Cp will equals to Cv plus R. So if Cv has 1, then Cp will equals to 1 plus R. That means Cv is less than Cp. That is thing I have already told you. For ideal gas, near relation will be Cp minus Cv equals to R, and ratio gamma equals to Cp upon Cv. That is the adiabatic constant, which I already explained in adiabatic process. So in the adiabatic process, what is the process? Adiabatic process is such type of process in which heat cannot be transferred to the boundary. Heat cannot be transferred to the boundary, which I have already explained you. We are applying an insulating wall between the two substance so that no energy will be transferred to the body. So this process is called adiabatic process. In adiabatic process, we are using gamma. And gamma is the adiabatic constant whose value is Cp upon Cv. That means it is the ratio of specific heat capacity, molar heat capacity. It is the ratio of molar heat capacity of constant volume upon constant pressure. That is the gamma. Okay. And we have also separate relation in the adiabatic process, which means pressure multiplied by volumes power gamma will always constant. So that is the few things which you have to understand whenever you are studying about the adiabatic process. Got it? So I have told you the brief idea regarding to adiabatic process. Let's talk about thermodynamic states. So thermodynamic states variable describe system equilibrium state, pressure, volume, temperature, internal energy, and U means number of moles. And they are independent of the history, only the present state matter. Intensive. What is intensive? Do not depend on the size of the system. Pressure, temperature, density, and specific heat. And extensive property depends on the amount of matter, volume, internal energy, mass, number of moles. So we have two types of property of the material, or you can say we have two types of intensive, you can say physical quantity. Intensive physical quantity, which mainly does not depend upon the matter. How actually you can say a substance are present on the particular container. Intensive property does not depend upon them, because if I talk about, you can say, if I have a 1 gram of ice whose temperature is 0 degree, and again if I again tell you I have 20 gram of ice, then again his temperature is again 0 degree. So temperature does not depend upon the amount of the matter. Okay, so this types of property we can see as an intensive property. So like pressure, temperature, density, specific heat, all of these kinds of you can say physical quantity are intensive property. And what about extensive property? Extensive property is the amount of matter which is you can see which mainly depends upon the amount of matter, like volume, mass. These all kinds of things are depending upon the amount of matter. Dividing an extensive property, extensive variable by extensive one, V by N, that is a molar volume. Okay, that is the again definition of, you can say, molar volume. You can say volume of per mole, volume per unit mole, that is called V by N. So V by N, N is the number of moles of a particular gas, and V is the volume of the gas. Volume of gas. Got it? So this thing you have to understand whenever you are doing about the molar volume. That is the quantity which are described in front of you. Equation of state. So in the famous equation in, you can say, gas state we are using, when you have ideal gas, then it will always satisfy this equation, PV equals to nRT. Okay, this is the ideal gas equation, which is very useful to finding the temperature, you can say volume, pressure of any gas. Okay, PV equals to nRT. This is ideal gas equation. Okay, so whenever you are finding temperature, pressure, volume, then R value will be right 0.0821. Okay, that is the constant. This is the universal gas constant. Universal gas constant. Got it? Now let's talk about the equation of state, that is PV equals to nRT. And equation state relates the relation between variables only to pressure, volume, and temperature. I think one more variable should be added, that is number of moles are independent. So mainly equation of ideal gas equation mainly refers to the relation between pressure, volume, and temperature and number of moles of the gas. Okay, for an ideal gas you will be right, for ideal gas PV equals to mu RT. Again N is written as mu, that meaning is same number of moles, and R you will be right 8.314 mole per Kelvin, and universal gas constant. So R you will be right in the thermodynamic process because we are dealing with the energy, and you will be right R value will be 8.314. But mainly for the gas calculation to finding the pressure, temperature, and volume, you will be right. The R value is 0.0821. Okay. So real gas follow more complex equation that will be, but ideal gas law work well at low. Real gas does not, you can say, obey so many ideal gas rules. For example, we cannot consider that every gas molecule does not have any volume. Okay, so at a real gas having some volume. Okay, and second thing which can be dealt with, that the molecular interaction force between the all volumes, total molecular interaction will be zero. But in the reality, molecular interaction force between gas molecules will not be, we can say, zero, or you can say constant. So that kind of thing which directly refers to that differentiate between real gases and ideal gases. That's why in the real gases phenomena, gases equation too complex. But in ideal gas case, PV equals to nRT is very simple just to identify temperature, volume, and pressure of the any container. Okay. From PV equals to nRT, we can derive our standard process of equation. Let's, for example, isothermal process. Okay. Here are some process which we can be defined in the, you can say, with the help of ideal gas equation. For example, isothermal process, I already told you that when temperature of the system is constant. Isobaric process, when pressure of the system is constant. Adiabatic process, okay, isochoric process. Isochoric process is such type of process when volume of the system is always constant. In adiabatic process in which I have already told you that heat exchange from the surrounding to system will always constant. Got it? Will heat exchange to the surrounding system is zero. And cyclic process, cyclic means whenever a thermodynamic process we will call as a cyclic process when it comes to the come back to its initial state. Okay, that is called cyclic process. Got it? Now let's talk about the conditions. What kinds of conditions we are applying? So in the isothermal process, temperature is constant. Delta U will be constant. Why? Because temperature, delta is mainly depends upon the temperature. That's why delta U will be also constant. Work done, you will be right. nRT log V2 by V1. That is the simple formula. We can also derive it, but it could be called too complex in front of you, which could be understandable for your viewers. So I think you should consider that formula whenever you are applying work done. So work done, you will write nRT log V2 by V1. Okay. So that is your work done by the gas in the isothermal process. And delta Q you will write as a delta W because delta Q will equal to delta U plus W. Okay, and delta U 0 for isothermal process, then delta W will equal to delta Q. Got it? Same kind of thing we can consider when pressure is constant. Then delta U will be NCV delta T, and you will be right delta W equals to P times of delta V, and work done you will write P times of delta V, and delta Q you will be right NCP delta T. Got it? That is the heat transfer through the energy. Got it? Okay. Isochoric process, volume is constant. Delta U will be NCV delta T, and work done by the gas in the isochoric process will be zero. Why? Because work done is mainly depends upon P times of dV. If dV is zero, which means the change in temperature, change in volume is zero, then work done by the gas in isochoric process will be zero because volume is constant. Volume is constant, with that means change in volume will be zero. So that kinds of we can consider in this type of following process. You can consider this kinds of formula so that you can easily solve your any numerical. Let's talk about the quasi-static process. What is quasi-static process? A quasi-static process proceeds infinitely slowly that system is in equilibrium at every stage. Mainly, it's mainly refers to that whenever you have a gas in a particular container, okay, and you have two choice to compress this container. To compress this, you can say piston, or you can say to compress this gas. First manner so that you can compress this gas, just put a you can say piston and just apply a impulse suddenly, so that gas initially compressed at very come time interval. So, and second thing which you can apply whenever you are just compressing the gas very slowly. You are compressing the gas very slowly. So this very slowly process to do something with a particular system, that is called quasi-static process. So according to this quantitative process proceed infinitely slowly. That means you are very slowly move your piston to compress this gas. I am doing some process in which I am doing very slowly move piston to compress this gas, so that we can see that slowly that system is in equilibrium at every stage. So we can consider that when piston is moving very slowly, that means at every stage system is in equilibrium. Got it? So at every instant, pressure, volume, and temperature are well defined. The process can be drawn as a line on a PV curve. Real processes are never truly quasi-static, but many can be approximately by one. So that is again few things which I already told you, that in reality, nobody process is quasi-static, but we can close to the we can do some external work done so that we can perform quasi-static process. For example, if I am compressing the gas very slowly, uh, I agree with you that the volume of this gas is changing very slowly, but this kinds of condition is nearest to your quasi-static process. But in reality, we cannot perform quasi-static process with 100% ideal way. Got it? So every process is not quasi-static. We can go close to the quasi-static process. Importance: state variable remain meaningful throughout. Work done equals to integration of PdV. It is valid only for quasi-static process. I have already told you. Forms the basic of reversible process. Okay. So PdV, why we are writing only quantitative process? Because we are changing volume with a very less time interval. Smaller amount of volume will be changed. That's why we are writing work done with the integral form, P times of dV. Got it? Let's talk about the reversible and irreversible process. Reversible process can be reversed exactly so that both system and surrounding return to this original states. What is reversible process? Reversible process, you can such kinds of process on which we can reverse to this initial state. Okay. So for example, when I apply, you can say force on the, you can say gas, so that the gas can be, you can say compressed. But when gas expand by certain, you can say by applying increasing temperature, by increasing pressure, gas certainly expand its volume, then you can say I am come back to the initial volume. So that kinds of process I can say that is irreversible process. Okay. So here is the example: quasi-static path and not dissipating effect, friction, viscosity, inelastic collision, that kinds of thing. So in reversible process, we can say that that is the quasi-static path, so that we can say it is reversible process. And during the reversible process, we can neglect few things like friction, viscosity, inelastic collision, etc. What is irreversible process? Most real process involves dissipation, rapid expansion, or non-equilibrium states. What is irreversible process? That is the opposite nature of the, you can say, reversible process. Such kinds of things which cannot be come back to this initial state. A process in which system cannot be come back to its initial states by doing everything. That kinds of process is called irreversible process. Got it? For example, if you have a particular glass of water, okay, and when you provide heat energy to them, then water will directly vaporize to the surrounding. But in this case, you can see that exact amount of water you can be directly converting to the, you can say, water again, from vapor to water. That kinds of thing you can say nearly to the impossible. Yes. So that kinds of process we can say irreversible process. Example of irreversible process: free expansion, heat flow across large delta T, plastic deformation, that is called also irreversible process. Reversible process are ideal. They set the limit of what is achievable. Reversible process of for an ideal gas mainly states to you that you have already understand regarding the elasticity also. So up to elastic limit, material can get to the regain its original tendency. So that is also called a reversible process. So for an ideal condition, reversible process mainly told you that up to which limit you are doing some particular type of operation, so that you can regain to its initial configuration. So that is mainly refers to that up to limit. That reversible process give you the particular limit, so that you can identify that with the help of this reversible process, I can set a particular limit so that I can come back to its initial states. So that is the few things regarding the reversible and irreversible process which you have to understand. Let's talk about the second law of thermodynamics. So second law of thermodynamics mainly states to you that, can I say one statement? If I'm providing a heat, work done heat can be converted into delta U plus W. Okay. So with the help of this statement, can I say a few things regarding to this? For example, I have a hot coffee. Okay. And according to this first law of thermodynamics, this loses its heat energy to the surrounding. Okay. And with the help of this, you can say hot coffee energy heat is provided to the surrounding. Some energy provided to the work done on the, you can say, molecules of the gas molecules. That's why they are getting some energy, that is called internal energy, and some energy to the passage by the work done. So can I say that by getting all of this energy and stored to the again to the, you can say, hot coffee, so that coffee's temperature will again increase. So according to first law of thermodynamics, it can be possible, because if energy release, then I can again store the energy and come back again give to the energy to the system. Then initial condition I can be reached. So first of thermodynamics can refers to this process, but in reality, this kind of thing will never happen. In reality, this kind of thing will never happen, because if any body loses its energy by a certain amount from by the heat, then by collecting this heat and come store in the, you can say, body, and body will get again increase its temperature. It will never happen in your real life. So main thing is that first law of thermodynamics will not showcase to you that process will be occur or not. It can also showcase to you that how process will be done. Okay, it will not clarify to you that this process will be done or not in the real life. So mainly second law of thermodynamics mainly refers to you that this particular type of process will be occur or not. Okay, so what is the key statement regarding to this? First law of thermodynamics, energy conserved, but does not say which direction process runs it. Enter the second law. Okay, this is again second thing you just told you by the first law of thermodynamics. What if I give you a two process in which I am collecting the energy from the surrounding and give to the heat, give to the, you can say, particular system. That means body's temperature increases and this energy transferred with the work done and some internal energy. So this process, I told you first process, and second process which I am told you that according to this process I can apply first law of thermodynamics. But if I talk about the second process in which I told you that heat released by the hot coffee to the surrounding and this energy transferred with the work done to the work done on the moving of the molecules, and some energy has transferred as an internal energy. So in the both process, same kinds of heat energy, same kinds of thermodynamic equation I can apply. So if I can apply same kinds of thermodynamics energy, and someone told to me that here's the thermodynamic equation, which process has done? Which process has done? So with the help of the same single equation, I cannot identify that what is this equation it says. Is it for this process? It is for second process. I can't understand regarding to this first law of thermodynamics. Okay. So to resolving this kinds of problem, we need our second law of thermodynamics. Okay. So first, Kelvin-Planck statement. It is impossible to construct a device that operating a cycle convert heat completely into the work done. Yeah, that is the very important thing which you have to know about the Kelvin statement. So Kelvin statement mainly refers to that whenever you are providing heat energy, so it is totally impossible to 100% heat energy converting to the work done. Okay, it is nearly impossible. Why? Because sometimes system loses its energy with the help of friction, by losing energy by in the other form, and some energy will be stored as internal energy. That's why total heat energy will not be converted into the work done. So that is the Kelvin statement. And what is Celsius statement? It is impossible for heat to flow spontaneously from colder body to hotter body. That is the second thing which I have already told you with the help of example. Colder body, that means is the surrounding. Hot body is the your coffee. So we can't say that heat can be transferred from colder body to hot body. Celsius statement mainly say heat can be transferred from hot body to cold body, because hot body can release their heat energy. Okay. So colder body already have colder body does not release their heat energy. It can be getting heat energy. Okay. So Celsius statement mainly refers to that the direction of heat energy. Colder body will not transfer heat energy to the hot body. Got it? So that is the second process. But according to first law of thermodynamics, this kind of thing can be happen. But in reality, it does not happen. So mainly second law of thermodynamics mainly states to you what kinds of thing will happen, what kinds of thing will not happen. The two statements are equivalent consequence. neta of heat engine is always less than 1%. Neta is what? Neta is the efficiency. Efficiency is what? Whenever it's you can say you can consider it's like a real life example. For example, for yours, you are a particular system and I am a source of energy. I am explaining something to you. So is it possible that my 100% explanation you are getting inside your mind? Nothing. You can get 90% of my explanation. You can get 90% of my knowledge. You can get 85% of knowledge, but nothing to 100%. So what is this 100%, 85% of my knowledge you can use? That means I am explaining about your brain efficiency. So what is efficiency said? Efficiency mainly said how much energy you will be used whenever some source providing to yours. So efficiency is, you can say, work done by the system, work done by the system divided by work done provided by the system, provided on the system. Okay, work done provided on the system multiplied by 100. That is your efficiency formula. It can be differ depends upon your process. For example, if I giving you 100% of knowledge, so I am giving you 100% of knowledge, but you can use only 80% of knowledge. So that is your efficiency multiplied by 100. So your efficiency is 80%. So it mainly defines to you that how much energy you are using with respect to my energy transfer. Okay, that is your efficiency. Got it? You can be find in, you can be find in the every question. So main thing, the second law of thermodynamics mainly states to you that every body does not have 100% efficiency. That means if I getting a food and food gave me 500 joules of energy, then my 500 joules of energy will not be done by the work done. Some energy will be used by teaching to yourself. Some energy will be used by walking something. Some energy will be used by solving something. Some energy will be used by, you can say, sleeping at a particular time. So this energy will be used in the separated way. So we can say that complete energy will not be transferred in the work done. Okay, so that is the Kelvin statement which I told you. Okay, defines the natural direction of all processes which ice melt in the warm room, but not the reverse. Again, told you same thing, that when ice loses its temperature and melt in the warm room, then can I say that after giving the energy to the water, yeah, after losing the energy to the water, then ice will directly convert. Then that water will be again converted to the ice cube. It will not. It will never happen. Okay. So mainly this second law of thermodynamics refers to this, how when process will be occur and then when process will not occur. Got it? Let's talk about the heat engine. Basic working principle. What is heat engine? So heat engine converts heat into useful work using a cyclic process. Components: heat receiver, that is T1, engine working substance, and cold receiver. In one cycle, absorb Q1 from hot, rejects Q2 to cold, delivers Q1 minus Q2 for work. So that is the heat engine. What is heat engine? Heat engine is, you can say, it is a particular type of engine which is getting some energy from the particular source and losing some energy to the other source, and remaining energy will be done as a work done. That is the basic working of heat engine. Okay. So heat engine getting some energy. Let's say according to the statement, we have two source of energy. First energy source providing some heat energy to the heat engine, and second cold receiver which is getting some energy from the heat engine. So that's why let's say Q1 energy transfer to the heat engine, and Q2 energy transfer to the, you can say, other body by the heat engine. But that means energy lost by the, you can say, Q2 energy transferred by the heat engine to the other system, and Q1 energy transferred to the heat engine. So net remaining energy will be work done by the, you can say, heat engine. That will be W will equals to Q2 minus Q1. Let's talk about the real life example regarding to this. For example, whenever you are moving by the vehicle is moving with velocity v. Then you can say that with the help of petrol, you are getting 100 joules of energy, so then you can easily move with the 5 kilometer to a particular destination, okay, with 100 joule of energy. But it is your assumption that if engine working very well, if engine having 100% efficiency, that means with the help of 500 joules of energy, I can easily go to the 500-kilometer distance. But main thing is that nobody engine having 100% efficiency. That means it will lose their energy with a certain kinds of process. Okay, so if petrol, if engine getting 100 joules of energy, that means Q1 is 100 joules, and but 200 joules energy will be reduced by the friction, by the, you can say, motor heat energy, or you can say by the 200 joules of energy by losing with the, you can say other process. Okay, so with the other kinds of the 200 energy has used. So actually 800 joules are energy will be used for your working. Working is what? To reach to first destination to second destination. So if according to your statement, if 100 joules energy, 1000 joules energy is directly sufficient for a 5-kilometer distance, but actually you are using 800 joules energy to reach your destination, then we can say that your 5-kilometer destination will not be covered. You just cover only 4.5 kilometers. That means no engines having 100% efficiency, we cannot convert 100% energy into the, you can say, work done. So heat energy, it's heat engine also working like this, like your motor engine. Got it? So 100 joules energy you are getting from your petrol, 200 joules of energy you are losing by friction, heat energy and lighting energy also, and 800 joule work done you are using for your moving destination. So work done is what? Q2 minus Q1. That means I got 800. Got it? And how can you find the, you can say, efficiency of your heat engine? So efficiency you will be right neta. What is the work done by the heat engine? So heat engine work done, that is 800 joule. And what is the energy gets by the heat gets to the heat engine? That was 1000 joule multiplied by 100. So that means you will get 80% efficiency. So with the help of this example, what is the actual formula regarding to this? So actual formula is that work done by the heat engine. So firstly, you will be right total energy provided by the source. So total energy provided by the source, you will be right as a petrol provided, my total energy provided by the source, that was petrol. So I have written 1000 joule. Okay, total energy provided by the source. Okay, let's that was Q1. Total energy provided by the source is Q1, and if Q2 energy released by from the Q1, that means remaining energy will be used as a work done. That means you will write Q1 minus Q2 and multiply by 100. So that is the efficiency of a heat engine, like this formula. So you can write efficiency will be Q1 minus Q2 upon Q1. That is the efficiency. And after solving this equation, you will be right. Neta will be 1 minus Q2 by Q1. Okay. And after multiply by 100, you will get efficiency in percentage. Got it? So that is the working principle of heat engine. Let's talk about the Carnot engine. What is Carnot engine? Carnot engine mainly refers to that ideal reversible engine operating between two receivers at T1 hot and T2 cold, working substance ideal gas in the piston cylinder. So what is Carnot engine? Carnot engine, it is a such type of engine on which we can use better amount of energy into the work done. Mainly you can say that Carnot engine having maximum efficiency. Carnot engine having maximum efficiency, but not up to 100%. Carnot engine having maximum efficiency, it have a neta max, but not close to the 100%. Okay, it will always reduce by 100%. It could be become 90%. It could be become 95% with the help of some process. So Carnot engine is what? Carnot engine is the such types of engine which can have maximum efficiency. And how this efficiency we can get? So we have four type of process so that we can find Carnot cycle. So Carnot cycle is what? Carnot cycle is the type of cycle in which it is the combinations of process so that we can get maximum efficiency of a particular engine. So if any engine with the help of Carnot cycle getting some maximum efficiency, that engine is called Carnot engine. So here is the combination of these processes so that we can we can say that that's the Carnot engine. That's why we can get maximum efficiency. So look at this diagram. Process 1 to 2, that is isothermal expression at T1. So process 1 to 2, that is isothermal. That means from 1 to 2, temperature is constant. Okay. And 2 to 3, adiabatic expansion. 2 to 3, adiabatic expansion. That means PV to power gamma will equals to constant. Okay, that is adiabatic process. And again, 3 to 4, that is again isothermal process. 3 to 4, that is isothermal process. For example, at the initial temperature is T naught. 1 to 2 is isothermal, that means temperature becomes T naught. And due to adiabatic process, temperature becomes, you can say, T3. And from T3 to T4, temperature becomes again T3. Okay, because 3 to 4 is again isothermal compression. Okay. And 4 to 1 again adiabatic compression. 4 to 1 again adiabatic. So temperature will again comes to the T naught. So that kinds of thing which you are doing in the particular Carnot engine cycle. If you are combined, if you do in the particular engine, and if you perform your particular task with the help of this type of process, then with the help of Carnot cycle property, you will get your maximum efficiency of a particular engine. So if any engine who follows this Carnot cycle, that engine is called Carnot engine. Got it? So let's talk about again Carnot engine efficiency. So Carnot engine efficiency will be written as neta equals to T1 minus T2 divided by T1. Got it? That is the efficiency. So for Carnot engine, neta will equals to 1 minus Q2 by Q1. Okay. Again, efficiency you can be written as Q2 by Q1, which I have already told you. Q1 and Q2 mainly depends upon the temperature, because Q equals to MC delta T. That means Q is depending upon the temperature. So I will be write 1 minus T2 by T1. That is the efficiency of the Carnot engine with terms of temperature. Depends only the two receiver temperature, not on the working substance. Carnot theorem. No engines working between T1 and T2 can have an efficiency greater than Carnot engine. Again, same thing. Carnot engine is a such type of engine which have maximum efficiency. So in the real life, nobody, any engine are present who have an efficiency greater than Carnot engine. Okay, it can be close to the Carnot engine, but never comes to the greater than Carnot engine efficiency. That is the Carnot theorem. So neta comes to the 1 if T2 takes to the 0, that is impossible. Got it? So big nature. 0th defines temperature. First, provide conversion of energy. Second, sets direction and limits of efficiency. Okay. So these kinds of things we have discussed in the second law of thermodynamics. Let's solve some practice problem regarding to thermodynamics, so that we can end this lecture of the first topic. Okay. The heat engine absorbed 100 joules energy. Heat rejects 60 joule of energy. Find the efficiency. Again, same thing. Heat absorbed by the system, that will be positive, and you can consider as 100 joule energy has providing by the to the engine, and it loses 600 joule of energy. That is Q1 equals to 600 joule. The net change in energy, that will be that net changing of energy will be used as a work done. So work done, you will be right Q2 minus Q1, that is 400 joule. And I want to find efficiency in the percentage. So I will write 400 joule divided by energy provided by the system. That is 1000 joule multiplied by 100. So 10 to 10 will be cancelled. 10 to 10 cancelled. Efficiency will get 40%. Anyone who have any doubt, he and she can ask me. Anyone who have any doubt regarding to this question? Sir, unit of heat energy. Okay. Unit of heat energy is the joule. Okay. Because energy has a unit joule, then heat is also energy. So heat energy is also heat energy. So you can say unit is also joule. Okay. Anyone who have any doubt regarding to this question, he and she can ask me. Let's solve the second question. In a cyclic process, if work done by the gas is 300 joule, then what is the heat absorbed? Okay, again, in the cyclic process, what is cyclic process? Like this. So particle come back to this initial position. Let's say at initially temperature is T1 and volume is V1, pressure is P1. And in the cyclic process, when particle comes again to the initial position, that means temperature will not change. If temperature is equal to constant, that means delta U will be 0. If delta U is 0, that means heat provided to the system, that will be equal to work done. So if work done is 300 joule, then heat absorbed by the system will again equal to W, that will be equal to 300 joule. Okay, any doubt? So sometimes can we reply, sir, it could be minus 300 also. Obviously, it can be minus 300 joule. But when heat taken to the, when we are providing heat, when heat taken to the system, when we are getting the heat energy to the system, then at that time we will consider minus 300 joule. But according to this question, it is also mentioned that heat absorbed by the system, that will be, we can consider as a positive value. Got it? Okay, let's talk about the next question. A gas undergoes an isochoric process. Isochoric process is what? Volume is constant. If volume is constant, then heat absorbed 200 joule heat, then find the work done. Again, volume is constant, then work done will be P times of delta V. Volume is constant, that means delta V will equal to 0. If delta V equals to 0, then work done will be 0. So it doesn't matter that how energy absorbed and released. If isochoric process is done in a particular system, that means volume is constant. If volume is constant, then work done will be 0. Got it? Let's solve the next question. A gas expands at constant pressure and volume increases. Which of the following is true? Again, question is challenging. Gas expands at a constant pressure. Constant pressure means pressure is constant. That means it is isobaric process. If isobaric process, can I apply PV equals to nRT? So if I apply PV equals to nRT, if pressure is constant, that means volume is directly proportional to temperature. So okay. So if I volume increase, that means temperature will also increase. So which of the following option will be correct? Temperature decreases, temperature increases. Option B will be correct. So that is the end of your first chapter, which I explained to you. It is the thermodynamics. Anyone who have any doubt regarding to the thermodynamic processes, any question, he and she can ask me. After that, we can continue with our next chapter with it, rotational motion. Any doubt regarding to this question? Any doubt regarding to this chapter? Anyone who have any doubt regarding to this chapter, he and she can ask me in the chat box so that I can identify. Any doubt? I can wait only 1 minute. Kindly consider your everything which I explained to you in previous questions. If any questions, if you have any doubt, you can ask me. Can you show the last question? Okay, just wait. Here is the last question. Okay, do you have any doubt? Any doubt from this question? Rahan? Okay. So nobody has any doubt regarding this chapter. Can I continue with the next chapter, which is rotational motion? Can I continue next chapter, which is rotational motion? Kindly reply in the chat so that we can continue with our next chapter, which is rotational motion. Nobody is replying. Okay. So I got a reply. Yes, sir, you can continue rotational motion. So let's continue with our next chapter, which is rotational motion. Okay. I have to again open the PDF. That is. So it is also very simple chapter. System of a particle and rotation of the body. So first, rigid body and types of motion. Okay. Center of mass. Okay. No problem. So firstly, we are starting with our next chapter, which is system of particle and rotational motion. System of particle means we are dealing with the center of mass, and we can find the location of its center of mass, and also we will do some few things regarding to center of mass problem. And the rotational problem, we will deal with some certain type of problem like moment of inertia calculation, and we can take understanding regarding to torque and angular momentum, angular acceleration, that kind of thing we will discuss in the rotational motion. So firstly, these kinds of things we have discussed, we will discuss. Okay. So firstly, what is translational motion? Translational motion is such type of motion in which all of the particles velocity are having in the same parallel lines. For example, I'm writing something. For an example, looks like that. I have a pen like this. If every particle of the pen having velocity v, 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 and having velocity v. If every particle having velocity v with same parallel lines, then that type of motion is called, you can say, translational motion. Got it? For example, look at this pen. If I move this pen like this is translational motion. If I move my pen like this is also translational motion, because every direction of every particle's velocity will be parallel to each other. And if I, again, it is moving like this is also translational motion. And if I rotate like this, and if I move my pen like this is also translational motion. So what we have understood, the motion, the velocities of every particle during the motion having same parallel lines entire motion. This process, this motion is called translational motion. And what about rotational motion? When particles velocities vector are not parallel to each other during the, you can say, time period, then that motion is called rotational motion. For example, like this is rotational motion, because every particle having velocity with a different, you can say, lines, and lines having some angles. That's why all particles, you can say, motion does not have parallel lines. Okay, so this is called rotational motion. Okay, and second thing which we can understood, that during the rotational motion, every particles cover equal angle at equal time interval. That means if every particles covers equal angle in equal time interval, that means every particle having same angular velocity. But if I talk about the translate, you can say translational, not translate. Okay, if I talk about the linear velocity, so every particle having different linear velocity, but every particle having same angular velocity, because linear velocity mainly depends upon the radius from the center of the axis of rotation. So every particle situated in the different kinds of radius. So every particle is having different, you can say, tangential velocity. Got it? And that is again rolling motion. What is rolling motion? Velocity of center of mass is equal to the r omega. R omega means velocity of every charge, every particle on the, you can say, circumference of the any body. If their tangential velocities are equal to the center of mass velocity, then we can say that that type of motion will be called rolling motion. Okay, I will discuss about it further. So firstly, let's talk about the center mass. What is center mass? A mass weighted average point of a system of a particle. The whole system behaves translationally as if mass were concentrated at the single point. That is the very important thing which I told you. Okay, what is center mass? Center mass is the single point of mass on which we can consider total mass concentrated. Total mass of the body can be concentrated in the single mass particle. And if I apply a particular force, then this single mass particle will be having some motion, like translatory motion. So this type of motion, this type of particle on which we are considering all force will be acting on this particle. This particle, or you can say this point, is called center of mass. And how can you find center of mass of a particular body? So we have two to three types of formula. First, if you have a coordinate system, then if you want to find x coordinate of the, you can say, center of mass, then you will be write m1 x1 plus m2 x2 up to m1 xn divided by m1 plus m2 plus mn. And if we have system of n particle, then you will write sigma of m ri. That means if you have a position vector of particle, let's say m1 having position vector r1, m2 having position vector r2, m3 having position vector r3, then according to center of mass definition, if you have a position vector, then location of position vector center of mass, you will be write m1 r1 vector plus m2 r2 vector and up to mn rn vector divided by m1 plus m2 plus m3. So this is your system of n particle whenever you have a position vector of them, you can define position vector of the center of mass also. And if you have a continuous body like rod in which mass is continuously you can say increasing or decreasing, that kinds of body center of mass you can apply as a integration of dm upon total m. Okay, this is your location of center of mass. Got it? So by continuous body. Again, symmetric bodies, for uniform bodies with symmetric center of mass are lies in the geometrical center. Rod, ring, disc, all of them having center of mass at the center. Center of mass may even lie outside the body, a ring and horseshoe. That means mainly there is a statement saying to you that if you have a symmetrical body, that means this span is symmetrical or not. This span is not symmetrical because this particular part having higher mass, this particular part having lower mass. That means center of mass will not be present at the geometrical center. But if I talk about my writing pad, it is a total rectangular shape and it is total symmetrical about every axis. That means its center of mass will be lie at the geometrical center. Got it? So main thing is that if you have a symmetrical bodies, even it is continuous, then their center of mass will be lie at the center of the particular, you can say, body. Okay, at the geometrical center. And if you have a, you can say, unsymmetrical body, then center of mass you will be calculated with the help of this formula, integration of dm upon capital M. Got it? So, and next thing which I have to explain to you that center of mass can be lie inside the body, on the body, and outside the body also. It depending upon your calculation. Got it? So let's solve some particular problem. 4 bodies of masses 2 kg, 3 kg, 5 kg, and 8 kg are placed at the 4 corners of a square of side 2 meter. The position of the center of mass will be. So I know square is the symmetrical body, but it doesn't mean that it have center mass at the center. Because why? Because their points are lie on the corner of the sphere. Sphere is not a particular mass of the body. If this square is if this square having particular mass, then we can say the center of mass of this body will be in the center. But mass of the, you can say, these 4 masses are arranged in the corner of the square. That's why we will use formula. Okay, that is 8 kg. Okay, how can we solve this problem? How can we solve? How can we find the location of the center mass? So let's consider from any point, consider one point as a, you can say, origin. Got it? So I am considering 8 kg is at origin. Okay, so write down the all coordinates of this, you can say, masses. So this, for example, if side is 2 meter, okay, so can I say that coordinate of this third point will be 2, 2? Coordinate of the 5 kg mass will be 2, 0. Coordinate of the second particle will be 0, 2. So let's write xcm. You will be write m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 upon m1 plus m2 plus m3 plus m4. Got it? So xcm you will find m1 is what? M1 is 8 kg multiplied by x1, that is 0. M2 again 2 multiplied by 0, that is again 0. 3 multiplied by 2, that means 6, plus 5 multiplied by 2, that means 10, divided by m1 plus m2 plus m3. So 8 plus 3 plus 5, that is 8, and 8 plus 8, 16, 16 plus 8, 16 plus 8, that is 18. So you will write 18. Is it right? 5 and 5 plus 5, 10, 10, okay, 18. So again you will be right 16 upon 18, that will come to 4 upon 9. So is it any option which gives you the 4 upon 9? That means our origin place we are considered in a different place. So I think question should be give some response like that. Consider origin, because it is totally location of center of mass is totally depend upon our, you can say, reference point, on which part we are considering as a reference point. So if I got 4 upon 9, that is also correct answer. That means from 8 kg mass, center of mass location will be lie at a 4/9 as a, you can say, x coordinate. Okay, from 8 kg mass. But it could be, it won't answer from the, you can say, like from this one, from this one, from this one. So question is also to be mentioned that find the location of center of mass from 2 kg. That concept we can identify with the correct explanation. Okay, so we are consider origin at, you can say, 8 kg. Okay, if we are considering origin at 8 kg, that means location of this 8 kg mass will be 0, 0, and all of this calculation of center mass will be done with respect to 8 kg. Okay, so 4/9 will be 4/9 will be x coordinate of the center of mass with respect to 8 kg. Got it? So it has some problem. It should be mentioned on which part you have to calculate center of mass. Okay. Again, let's find the y coordinate of center mass. So I will be write directly m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 divided by m1 plus m2 plus m3 plus m4. So addition of all masses will be 18. So I will write directly m1 y1. So m1 y1 will again 0. m2 y2. m2 is what? 2 kg multiplied by 2, that is 4. Plus m3 by 3. 5 multiplied by 2, that is 10. And again, is it 5 or 3? I think is it 3? Sorry. This is 3. So 3 multiplied by 2. 3 multiplied by 2, you will be right 6. Got it? And 5 multiplied by 0. That is again 0. So you will get 10/18. 10/18. That will comes to the 10/18. That will comes to the 5/9. So center of mass will be lie from the 8 kg mass will be 5/9. Got it? Is this calculation is right? 2 multiplied by 2, okay. 3 multiplied by 2, and y coordinate of the system will also 0. So I will write 5 multiplied by 0, that is 0. So 4 plus 6, okay. 10/18, that is 5/9. So center of mass of the, you can say, body from the 8 kg mass will be 4/9 and 5/9. So it is totally depend upon your reference point. If I consider this point, then answer could be different, because so location of center of mass from this point will be different. Okay, so question should be mentioned about the on which reference point I am finding the location of center of mass. Let's talk about the motion of the center of mass. So center of mass, we can also consider the center of mass is that type of mass, or we can say that type of point in which we are considering net external force on the body will directly consider on the center of mass. So that's why we are considering the F external will directly equal to mass of the body multiplied by acceleration of the center of mass, because we are considering all forces we are applying in the center on the center of mass. That's why center of acceleration of the body will apply due to center of mass acceleration. Got it? Okay. Now we have some key idea. The center of mass moves exactly as a single particle of mass and acted upon the external force would be moved. I already told you regarding this, we are considering a single point on which all external force apply on this point. So that's the center of mass acceleration we can be defined as F external net will equal to m times of ACM. Why internal forces are cancelled? Newton's third law. Internal forces pair are equal and opposite, so the added to 0 for the whole system. So internal forces we are why cancelled, because during the external action reaction pair, internal forces are cancelled out to each other. Classical example, a projectile explode mid-air, fragments scatter, but the center of mass continues on the original projectile trajectory. Again, same thing which I have already explained you, that when I project a projectile with angle theta, then at the highest point, this projectile breaks into the two parts like this and this. But these two parts can be found in the separate distance, but the center of mass location will always lie on the horizontal range. Got it? So that consideration is very useful whenever you are solving that type of problem. Okay, so motion of this again, one of best example I told you that whenever center of mass having velocity v naught and moving to the downward direction, and suddenly it breaks into the two parts like this, then again this two parts explosion has done by the internal forces. So due to internal forces, external force is 0. That means momentum of the center of mass will always constant. If momentum of center of mass is always constant, that means center of mass location will not be changed, and still its velocity v naught until explosion has occurred. Got it? These two types of things you have to know whenever you are assuming about the center of mass phenomena. Got it? Okay, let's solve a particular problem. A system of two particular masses m and 2m are moving in the velocity v and minus v respectively. The velocity of the central mass of the system will be, again, velocity of central mass, if you can find xcm, will be m1 x1 and plus m2 x2 and dot 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 m1 plus m2 plus fc. So if you differentiate this particular equation with respect to t, so you will write d xcm upon dt will equal to dx1 by dt, dmx2 by dt, and so on. So you will write this is the velocity of central mass will equal to m1 v1 plus m2 v2 and dot 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 mn vn upon m1 plus m2 plus m3. That means it's directly showcasing to you that velocity of central mass will equal to addition of all momentum of the following particle. So VCM you will write m1 v1, that is m into v, and minus v multiplied by 2m. So you will write minus 2m multiplied by v divided by m1 plus m2, that means m plus 2m, that will comes to the 3m. So m will be cancelled out. V of central mass will be right minus v by 3, and this is your answer. Got it? So you can find velocity of the central mass, linear momentum of the system of particle. So this kinds of thing I have already explained in the previous chapter in the laws of motion. Linear momentum. Momentum is what? Momentum is the you can say product of the mass into axle mass into velocity of the particle. This thing will mainly directly showcasing to you that how particle will behaves whenever it is undergoing in the motion. Got it? So this kinds of thing we have already discussed in the last lecture with the previous laws of motion. We have already told that if f external is 0, then we can say the momentum of the body is always constant. So let's solve the particular problem with the help of this example. A wheel of radius 0.5 meter rotates with angular velocity 10 radian per second. The linear momentum of mass of 2 kg on its rim is, I think this question is based upon the, you can say, angular momentum conservation type question. Okay, so let's solve this problem. Okay, a wheel is rotates 0.5 meter radius, rotates with angular velocity like this. Okay, the linear momentum of a point of mass 2 kg on its rim is the main question is that this is wheel and its angular velocity is given 2 radian per second. Omega I have already given, and its radius is already given as 0.5 meter. Okay, and the particle which is lies on the rim whose mass is 2 kg. Then what is the linear momentum of this point? So linear momentum of this point you can be write as m into v, which is asking. So m is already given. What is the velocity you will be right? So velocity you will be right. You can see that if a particle lies on this, you can say rim, then every angular velocity of the particle which is lying on the, you can say, rim, it have same angular velocity. So it have same angular velocity like 10 radian per second, and it is lying on the boundary of the, you can say, boundary of the wheel on the rim. That means its radius, its distance from the center will be 0.5. So its linear velocity you can be written as v equals to omega multiplied by r. So linear velocity comes out to be 10 multiplied by radius will be 0.5. Linear velocity will be 5 meter per second. Then momentum will be 2 multiplied by 5, that will equal to 10. Got it? So which one option is correct? Option B is the correct answer. Any doubt regarding to this? Any doubt regarding to this question? He and she can ask me. Anyone who have any doubt? He and she can ask me. After that, we can continue with our next topic. Nobody has any doubt? Nobody has any doubt? Okay. So let's continue with our, okay, pace up the speed up. Okay. So let's continue our next topic, which is vector and cross product. That is very simple. Cross product is what? Cross product is the A vector cross B vector will come to the C vector. Cross product is, you can say, whenever you are applying a cross product phenomena, then cross product answer will give you the perpendicular vector with two vector. Okay, if A vector is lying like this, B vector is lying like this, and if both of them having angle theta, then cross product answer will be also another vector which is always perpendicular to C vector is perpendicular to B vector, and C vector is also perpendicular to A vector. That kind of thing you have to know. And mod of A vector cross B vector, which is cross product, you can say magnitude, you will be right mod of A vector, mod of B vector multiplied by sine theta. And mod of A vector is what? Magnitude of A. Mod of B vector is magnitude of B. Unit vector relation, we can also see that I, J, K, that is K cap, J cross K is I cap, K cross I, that is also J cap. Let's talk about the angular velocity and relation with the linear velocity. So angular velocity, you can see that the angle made by the particular, when any particle is having angular motion, and the angle made by the particle at a per unit time, that is called angular velocity. For example, if a particle moving like this and it is also covering some angle, so the covering this angle at a particular time, that is called theta by t, that is called angular velocity. How much angle it covers at a particular unit time, that is called angular velocity. So we can also write d theta by dt, that is angular velocity. And angular acceleration, again the rate of change of angular velocity, that is called angular acceleration. Unit is radian per second square and its unit is radian per second. Got it? This is also called angular acceleration alpha. Again say linear velocity of a particle. So that is the relation between linear velocity and angular velocity. Linear velocity equals to r cross omega. Okay, and linear velocity is like this. V vector equals to omega vector cross r vector. Got it? And here is the magnitude. V equals to omega r, and as a vector form, you can write V equals to omega vector cross r vector. The angular velocity of a body is given as 60 minus 3. The angular acceleration will be. So angular acceleration, I have already told you that angular acceleration alpha will equals to rate of change of angular velocity, and angular velocity is varying with respect to time. Then you will be right d omega by dt. So alpha you will get 6 radian per second. After differentiate this equation 6 minus 0. So 6 will be correct answer. Let's talk about the torque and angular momentum. Torque is just like you can say a minimum amount of force applied to a particular about a particular axis, so that any particular body can rotate by some angle. That force is called, you can say, torque. Got it? So torque is what? Torque is also called moment of force. The turning effect of a force about a point of axis, that is called torque. For example, if this is a pen and it is a fixed axis on which it can be rotated. So if I apply force so that this pen can be rotated, this turning effect of force, that is called torque. And torque is a vector quantity which can be defined as torque equals to r vector cross f vector. And how can we find the direction? Direction you can find, place the finger according to direction of the, you can say, r, and move your finger according to direction of the current. That thumb will be point out to the direction of the torque. And let's talk about the angular momentum. So angular momentum is simple. Angular momentum is the cross product of linear momentum with r vector. That is called angular momentum. Okay. So angular momentum is r vector cross p vector. And it is also magnitude was written as r mod of p multiplied by sine theta. So rotational Newton's second law, that will be equal to, you can say, the rate of change of angular momentum, that will be equal to torque external. So if torque external is 0, then we can say that according to Newton's second law in rotational motion, torque external if 0, then net angular momentum of the body will always constant. Okay. So here is the basic thing which I explained you. Let's talk about a particular question. A force of 10 Newton is applied perpendicular to the rod, length 2 meter, about a pivot point at one end. The torque produced will be. So mainly whenever you are doing calculation the torque, okay, so you just imagine, first thing is that torque you can be right, F will equal to force multiplied by r perpendicular. That means force multiplied by perpendicular distance. Got it? So question is already mentioned that rod length is 2 meter and force is applying on the rod like this, that is 10 Newton. And look at this diagram. This length is always perpendicular to 2 meter. That means torque you will be right, torque will equal to 10 multiplied by 2, that is 20 Newton meter. Got it? So that is your answer. Let's solve another question. Equilibrium of a rigid body. So if any body will be, we can say that transitional equilibrium whenever force across every direction will equals to 0. And we can say that the net force on the body about all direction, then that body we can say that in the translational equilibrium. And what about rotational equilibrium? If any body which having net force will equals to 0, then that equilibrium is called rotational equilibrium. Got it? Okay, let's talk about the moment of inertia. So moment of inertia I have already explained in the translational motion of the laws of motion, which is mainly states that it is the resist tendency of any substance, or you can say any object, so that it can't be changed its position. Same kinds of thing we can consider as a moment of inertia, which directly refers to that it is the resist property of a body, so that it can't be rotated, or you can say it can't be changed its position by the rotation. That is called moment of inertia. So moment of inertia mainly depends upon the mass distribution of the body, how mass has distributed in the particular body. And second thing, about the axis of rotation, on which particular direction you want to rotate the particular object. So that kinds of thing is mainly depends whenever you are doing the calculation of moment of inertia. So rotational analogy, mass, it measures the body resistance to change in its rotational state about the axis. I have already told you. Here are some basic formula of moment of inertia. If you have a system of particle, then moment of inertia to all particle will be right as I1 plus I2 plus I3 plus I4 dot In. Okay, and I1, I2, I3 is what? I1 and I2 is our individual moment of inertia of their individual point. And a single particle moment of inertia can be written as I equals to mr square. And for the continuous body, I equals to integration of r square multiplied by dm. Got it? Now again, few things are given in front of you. Mass, moment of inertia depends upon the mass of the body. Distribution of mass with respect to the chosen of the axis. Choice of axis, same body, different axis. Okay, and unit kg per meter square. Two theorem which we are using in moment of inertia. First is parallel axis theorem. Second, perpendicular axis theorem. Parallel axis theorem mainly refers to that whenever you have two parallel lines, and whenever you are doing a calculation of a moment of inertia of this particular rod, then moment of inertia about the second axis you will be right as moment of inertia about center of mass plus m times of distance between the two parallel lines. So you will be right ICM plus md square. Got it? And perpendicular axis theorem mainly refers to that when three bodies are in mutually perpendicular to each other, then IZ will equal to always Ix plus Iy, which means moment of inertia along x-axis plus moment of inertia along y-axis. That will give you the moment of inertia along the z-axis. Got it? Let's take over the question. A uniform rod of length 2 meters and mass 3 kg is hinged at the one end. A force of 9 Newton is applied perpendicular to the rod of its free end. Find the angular acceleration of the rod. Again, same thing. Torque, net torque will equal to moment of inertia multiplied by angular acceleration. Just like force equals to ma. So moment of inertia apply also you can say having same role like mass. So moment of inertia I like mass and angular acceleration like linear acceleration. So tau net will equal to I into alpha. Now question is given a uniform rod of mass length 2 meters, mass is 3 kg, hinge at a point A. Okay, like this, hinge at a point A. Okay, and mass is 3 kg is given. Okay, and whose length is 2 meters is already given. Force of 9 Newton is applied perpendicular to the rod to its free end. To the free ends, 9 Newton force is applied. Okay, to the perpendicular end. And find the angular acceleration of the rod. Okay, so what is the net force applying on the body? So firstly, mg is also acting on the downward direction, and 9 Newton force is also acting towards the same direction. So the net torque will be torque due to mg, that will be mg multiplied by 1. All forces acting on the rod we can consider as from the center of mass. So mg multiplied by 1 plus 9 multiplied by 2 net torque, that will be equal to you can say that will be equal to moment of inertia multiplied by alpha. Moment of inertia you will be considered as a ml square by 3. So you will write mass of the rod, that means 3. L is 2, that is ml square, and 4 by 3 multiplied by alpha. Let's solve this equation. You will get 3 multiplied by 10, that is 30. So 30 plus 18, that will becomes to the 48. will equal to 3 multiplied by 4 multiplied by 3, that is equal to alpha. 3 to 3 will be cancelled, 4 1 is 4, 4, and that will equal to 12. So alpha you will get 12 radian per second square. Radian per second square. I think this option may be wrong because they did not consider about mg, because mass of the rod will also act a torque on the rod. Okay, so if I neglect this torque, then I will get 18 will equal to 3 multiplied by 4 by 3, which is equal to alpha. 3 to 3 will be cancelled, and 9 by 2 you will be get, and you will get 4.5 radian per second square. But I think this question is very wrong. Answer is wrong. Why? Because we can't neglect about the mass of the, you can say, body, because torque will be act due to mass of the body as well as this 9 Newton force also. So acceleration will be calculated due to net force applied on the body, that will be equal to I into alpha. So net force will be act due to gravitational force plus due to external force, which is already given. So correct answer will be 12 radian per second square. Got it? So these options are wrong. You can neglect this one. Okay. Let's talk about the rotational kinematics of uniform acceleration. So if you have a uniform acceleration, so you can find motion equation according to translational motion. V equals to u plus at, and v square equals to u square plus 2as, and s equals to ut plus half at square. Similar kinds of thing we can do in the rotational motion, in which if alpha, which is angular velocity, is constant, then we can also apply motion equation for this rotational motion also. So omega is the final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is the time, and theta is the angular displacement. So these three kinds of things we can relate with our motion equation. So these three kinds of motion equation you can be used with the rotational motion also. Let's talk about the rotational dynamics. So rotational dynamics, I have already told you that tau net on the particular body will directly equal to moment of inertia multiplied by angular acceleration of the body. So that is the, you can say, tau, you can say rotational dynamics. So force we can consider as a torque in the rotational motion, mass can be considered as the moment of inertia of the body, and alpha can be considered as a, you can say, angular acceleration of the body. And linear acceleration and angular acceleration relation you can be write as a equals to alpha. This is the relation between linear acceleration with angular acceleration. Got it? Let's think about few things regarding to this question. The momentum inertia of the body is given by 1.2 kilogram per meter square. Initially, the body is at rest. In order to produce a rotational kinetic energy, 1500 joule, and angular acceleration is 25 radian per second must be applied about the axis. Okay, so what this question is asking? The momentum inertia of the body, okay, is given. Initially, the body is at rest. In order to produce rotational kinetic energy is 1500 joule, and angular acceleration is 25 radian must be applied about that axis. The duration, okay. So mainly question is asking about time period. Okay, so if we want to find kinetic energy, rotational kinetic energy should be 1500 joule. Then if I want to find this kinds of result, then how much time required whenever moment of inertia of the body like this, angular acceleration like this, body initially at rest, then how much time period will require to reach this type of energy of rotational kinetic energy. Okay, so rotational kinetic energy can be written as half I omega square. What is that? Is rotational kinetic energy. So firstly, initially is at rest, that means omega naught is 0. Time I have to find, and I have already given, that is 1.2 kg per meter square. And what about, I have to find alpha, I have already given 25. So can I write normal motion equation of rotational motion omega, it will equal to omega naught plus alpha t? Can I write like this? Obviously I can write. So omega I can write alpha, I have already given 25 and multiply by t, but I don't have value of t. So I can put directly value of omega in this equation. So I have written 1 by 2. I have already given 1.2, and omega square, that means be 625 t square, 25 square, that will be equal to 1500, which is already given. Let's find the value of t. You will be get, that is 6, and you will be get 25, and it will be resolved as 15 multiplied by 4. Okay, and that is this comes 24. 15 multiplied by 4, that becomes 60. 60 ones are 60, 6 ones are 6, 6 twos are 60. And you will get 25 multiplied by t square will equals to 100, and t you will be get 100 upon 25, and t you will be get t square you will be get 4, and t you will be get 2 seconds, which is your answer. Got it? So option B is the correct answer. So you just use your motion equation in the rotational motion and then find your calculation. Let's solve our new next question. A flywheel of radius 2 meter and mass 8 kg rotates an angular speed 4 radian per second about an axis perpendicular to its center. The kinetic energy of the rotation. So, and again, kinetic energy of the rotation will be right half I omega square. A flywheel of radius I have already given. This is 2 meter. Mass of the body will be 8 kg. Rotates an angular velocity omega has already given radian. Omega naught is given 4 radian per second. Okay. About an axis perpendicular to its center. The kinetic energy of the rotation. So main thing flywheel means it has I think you can say ring type. Okay. So for ring type you can assume moment of inertia will be m into r square. Okay. So if m into r square it is the moment of inertia, then you can be right 8 multiplied by 4, that is 32 will be I. So if 32 will be I, omega naught is already given. So you will write 1 by 2, I will equal to 32. Multiply by omega is what? Omega is already given, that is 4 multiplied by 4. So answer you will get 2 ones are 2, 2 twos are 4. So 8 multiplied by 32. 8 multiplied by 32 will give you 16, 1, 25. 256 is the correct answer. Okay, so option C will be correct. Let's solve next question. The angular momentum. Again, same thing which I have already explained you. Angular momentum for a rotational body we can write as I into omega. Okay, so if any body is rotating with a particular axis, that angular momentum of the body you will write moment of inertia multiplied by omega. Got it? So if a torque external of a particular body is constant, that means we can say that I omega will equal to constant. The basic example of this angular momentum conservation is ice skater. Pulls arm inverted, I decreases, omega increases, spin faster. Similar, driven in air, tucks bodies tightly, smaller, I faster spin, then opens to slow down for clean entry. Stretches arm out, larger, dancer or gymnast. Stretches arm out, larger, I slower rotation for controlled finished. Okay. Here are some example of rotational, you can say angular momentum. A particle of mass small m is projected with velocity v with an angle theta with the horizontal from the ground. The angular momentum about the point of projection at the highest point of trajectory. Again, same thing at the highest point of projectile motion, horizontal velocity will be mv cos theta. So about the highest point, here is the radius of so that you can find L equals to mv r. Okay, so r is what? R is the highest point from the ground. So highest is what? H max, and H max you can easily find out when any projectile motion, any projectile projected with angle theta with the velocity v, then you can find H max. You will write u square sine square theta. U square sine square theta upon 2g. So put the value of r inside this expression. M value is already given, b cos theta is already given. So let's multiply this. So you will be right. You will get m multiplied by b cos theta multiplied by u square sine square theta upon 2g. So u is what? Again u it is also b. Okay, so you will be right. What is this? At the highest point of trajectory, you will be right. I think u square sine square theta upon 2g. It should be cube. It should be cube. Okay. Every answer must be have cube. Okay. Okay. Let's multiply this. So you will get. Can I write like this? M v cube sine square theta cos theta multiplied by 2g. So how can I write like this? So most of the I think all options are not matching like this. Again, kindly you can consider the question. A particle of mass kept small m is projected vertically with angle theta with the horizontal from the ground. The angular momentum of the point of projection. About point of projection. Okay, so about point of position, again the perpendicular L equals to R vector cross P. So we can consider R multiplied by P multiplied by cos theta. Sorry, R multiplied by P into sin theta. That is also same with, that is the vertical distance. R cos theta and R sin theta, that is also R sin theta. So R sin theta is what? That is the H max. H max I have already written. U square sin square theta upon 2G. Then L vector cross V. Then option correct answer should be like this: M V cube sin square theta cos theta upon 2G. And V cube sin square theta cos theta upon 2G. I think that option should be correct. Okay. So option D should be like this. Okay. It has some option problem. Let's solve next question. A disk of mass capital M, radius capital R is rotating about angular velocity omega about its center. A particle of mass small m moving with velocity will tangentially stick to the ring. The new angular velocity will be, again same question. Initial angular momentum you will be right as the final angular momentum, because net torque on the system will equals to 0. That's why you can conserve angular momentum. So I initial you can be right as I final. So a disk of mass capital M, radius capital R is rotating with angular velocity omega about its center. So initially angular momentum will be disk about the center of mass. You will be right mr square by 2 I multiplied by omega. That will equals to a particle of mass small m moving speed with v tangentially sticks to the rim. That means after some time a particle lies at the rim at distance smaller and its tangential velocity is v. And after reaching this particle small m, angular velocity becomes omega dash. And what is the value of omega dash? I have to find. Again, final angular momentum you will be right for the disk. You will be right mr square by 2 multiplied by omega dash plus angular momentum due to this point. So you will be right v equals to omega into r. So can I write v will equals to can I write I want to answer in terms of v also. So I can be right small m multiplied by r multiplied by v, because r is perpendicular to p. So I can be right L for small particle will be mrv. So let's solve mr square by 2 multiplied by omega minus mr into v and multiply by mr square by 2 multiply by omega dash. Okay. So let's solve this particular problem completely. So you can be right. If a disk, so you can say a moment of inertia about the center of the disk will be mr square by 2. Okay. Then why should it written like this? It has considered like a ring, not like this. Option is also correct, I think. Okay, because disk is rotating about its center. So about the center, this moment of inertia will be mr square by 2. So let's solve this problem. You will be right. mr square omega minus 2 times of m into r into v and divided by 2 will equal to mr square by 2 multiplied by omega dash. So 2 to 2 will be cancelled out. Omega dash you will be get mr square omega, okay, not square, minus 2 times of small m into r into v divided by m into r square. That is your final angular velocity. So what is the correct answer regarding to this? I think no answer has found. Mr square omega minus plus mrv. Why is it open? Because a particle of mass small m, initial momentum will be with a single ring. Okay, and final angular momentum will be changed. Final angular velocity will be changed. Omega dash. And why it has written like this? V equals to omega r, that omega, I write omega dash equals to v by r. So if I write omega dash equals to v by r, not omega dash, already v is given. So v can I write omega dash into r. So m into r square multiplied by omega dash. Okay. So omega dash can be written as mr square by 2 plus m into r square. Okay. That is the clear thing. Okay, let's solve this problem. So you will get answer omega dash will equals to m r square omega minus 2 small m r into v divided by m into r square plus 2 times of small m into r square. That is your final angular velocity. So it is matching like first option. Only two is difference because moment of inertia of the ring on the center of the axis will be mr square by 2. That's why second option can be matching to the first option. It's just having problem regarding to calculation of moment of inertia. Got it? So in this question, you just apply initial angular momentum that will be equals to final angular momentum. Okay, let's talk about the next question. Now the question says a particle of mass 2 kg moves in the circle of radius 1 meter with speed 3 meter. The angular momentum of the center is. You can solve by yourself. You can easily solve this. Apply angular momentum concept. Okay. All formula at glance. Here are all formulas so that you can revise. I have already explained you how can you apply this all formula regarding to rotational motion. Okay. So again, conservation of law, the chapter course, and in the linear momentum, if f external is 0, linear momentum is constant. If tau external is 0, then angular momentum will be constant. Let's solve one more problem. A particle of mass small m with velocity v at position vector r from the origin. If the angle between the r and v is theta, then find the ratio of angular momentum up to the linear momentum to the origin. Okay, that question is I have to solve with yourself. So a particle velocity having v position vector r from the origin, like this. Okay, that is r and velocity v. If the angle between r and v, is theta, angle between r and v is theta. Okay. Of the ratio of the angular momentum to the linear momentum about the origin. So linear momentum will be m into v, and angular momentum can be written as p multiplied by perpendicular distance from the origin, that is x. So if this angle is theta, that this angle is 90 minus theta. If this angle is 90 minus, that is angle is r, that is angle is again theta. So that is r cos theta and this is r sin theta. So x equals to r sin theta. So angular momentum you will be right p multiplied by perpendicular distance. So angular momentum will be p multiplied by r sin theta. So ratio of angular momentum to the linear momentum you will be right. L by p will be m v r sin theta upon m into v. mv to mv will cancel out. Ratio will be r sin theta. That is your answer. So this is a simple concept which whatever you have to apply. Angular momentum will equal to linear momentum multiplied by perpendicular distance. Got it? And perpendicular distance I have assumed as x. Now, by the geometry, I have find x equals to r cos r sin theta. Got it? Here is the revision criteria of your this chapter. Consider by yourself. And this is your mistakes which you can do. Center of mass must be lie in the side. That is not. Center of mass can be lie at everyone. Treating a cross b equals to a dot b, not like this. A cross b is totally different than dot product. Okay. Applying F equals to ma to rotating body directly, nothing. You have to apply torque equals to I into alpha. Thinking moment of inertia is property of mass only, nothing. Moment of inertia is depending on the axis and mass distribution too. Okay. Using kinematic equation for a alpha, no. Using kinematic equation like this proper manner, omega not alpha t. Okay. And tau and r are vector quantities like torque and you can say angular momentum are vector quantity and their direction can be found by right hand thumb rule. Forgetting direction, this is your mistake. Again, one short recap, chapter in straight line. Okay, that is also same thing which I have already told you. Tau equals to I into alpha, L equals to I into omega, and center of mass acceleration will be F external. Let's solve one more last question. The angular momentum of what is given by L equals to I into omega. If momentum inertia is constant and angular velocity is double, then the angular momentum becomes. So L equals to I into omega. So I1 omega 1 will equals to you can be right if moment of inertia of the constant and angular velocity doubles, then angular momentum will be. So If angular velocity omega dash will equals to 2 times of omega, then L will equals to I times of 2 times omega. The angular momentum becomes double. So this is your answer. So first rotational motion chapter has completed. If you have any doubt, he and she can ask me how can we solve that type of problem. When will the break time, sir? Start, sir. Okay, I will ask with someone. Then I will tell to you that when break will be start. Okay. So first thing, reply to my first question. Instant of break. Is it understandable rotational motion for yours? Can you solve problem regarding to this rotational motion inside your examination? You just apply few things only. L will be constant whenever torque external is 0. Tau equals to I into alpha. Torque equals to alpha you will apply when net torque you have given and you have to find. Got it? Then you can apply motion equation for the, you can say, rotational motion also. Then you can apply this kinds of thing. Okay. Now we will discuss about new class 12 chapter, which is, you can say, moving charge and magnetism, and you can say electrostatics. We will discuss about, you can say, electrostatics also. Okay. So do you want break? Any substance which is used, yeah, or you can say it is the fundamental property of any substance by which we can study about the electrostatics related in the physics branch. Okay. So mainly electric charge, with the help of electric charge we can understand the electrostatic force between two charged particles. If two identical charged particles will repel to each other, two charged particles will attract to each other. The force of attraction between these two charged particles, it is called electrostatic force. This electrostatic force mainly depends upon the distance between the charges and also magnitude of their charges also. This electrostatic force magnitude wise I can be write F will equal to K Q1 Q2 upon R square. So we have this few things regarding to this. We have let's say okay, we have a silk and glass rod. Same material attract electrons more than others. Okay, electric charge of constant. Silk, glass rod, it has positive value, it has negative value. As the glass rod is rubbed against silk, electrons are pulled off the glass onto the silk. That means these kinds of statement are showcasing to you that how any body can be charged. So whenever you are rubbed with a glass rod with the, you can say, silk, then you can say rod, silk gets positively charged and rod gets negatively charged. That means one charge can be transferred to the other body. So that means you can say both body can be charged when you are rubbing to each other. Got it? So that is electric charge. Usually matter is charge neutral because the number of electrons and protons are equal, but their silk has an excess of electron and the rod at depth flip. That means usually any material which are looking in front of you, these all material are electrical neutral because the number of electron inside the charge, which means number of negative charge inside this particular substance, that will be neutralized by same amount of positively charged. So number of negatively charged and number of positively charged both are equal present in the substance. That's which this substance is electrically neutral. But whenever you are rubbing with one body to another body, that means some charges are transferred to the other body. That means one body getting positively charged means number of electrons has transferred to the other body. That means positively charged value increases. And the other body which gets negatively charged, that means number of negative charge has increased in the other body. That means this body gets negatively charged and one body got positively charged. Okay. So electric charge is the fundamental quantity. Again, I'm explaining to you. Electric charge is the physical property of a matter. Charges can negative or positive depends upon number of protons and number of electrons present inside the substance. In a matter, positive charge are stuck in place as the nuclear matter, the negatively charged when extra electrons are added and positively charged when electrons are removed. These same kinds of thing we have already explained you. And again, same charge will repel to each other, opposite charge will attract to each other. Now electric charge. How electric charge, when electric any charge moves to the another body, there are, you can say, every charged particle inside the substance are bounded with you can say with some bonds. Okay, so amount of energy so that electrical charge can be free out from the bond you can say valence band to, you can say conduction band. Conduction band is what? Where electron can easily free to move at everywhere. And valence band means electron has bounded. It is the reason in the graph of energy on which electron has banded with the atoms so that electron cannot be moved freely. But when I provide energy so that electron can be transferred from the valence band energy shell to the conduction band energy cell, these bands are only energy difference. Okay, these are only energy difference. That means if I want to move electron to the conduction band, valence band to conduction band, then I require 10 electrovolt energy. So if I provide 10 electrovolt energy by rubbing, by touching, yeah, any kinds of other thing, so then electric charge can easily transfer to the conduction band and electron can easily move to the other body. That means electron can anybody can be charged. So these kinds of thing mainly depends upon your band theory, which I is writing in front of you. Electron mainly placed in the valence band, and after that, rubbing with someone moves to the conduction band. Got it? The energy difference between them, that is called narrow gap or band gap. Got it? Let's talk about electric force. Electric force, I already told you. Electric force, that is the electrostatic force between two charged particles whenever they are attracting and repelling to each other. This electrical force I have already explained to this magnitude will be K Q1 Q2 upon R square. R is the constant, K is the constant, K's value is the 1.1 upon 4 pi epsilon naught. Okay, epsilon is the electric permittivity in the free space, which is already written, and here is the value of this 8.86 into 10 to the power minus 12 coulomb square per meter, coulomb square per Newton meter square. And K's value, whose 1.4 pi epsilon naught values will be 9 into 10 to the power 9 Newton meter square per coulomb. Here is the unit, and here is the unit of epsilon naught. Got it? Here is some basic question regarding to this. Three charges are placed in one corner of equilibrium triangle, then find the force of Newton with each other. So this is the case same similar like the gravitation. When M1, M2, and M3 are placed in the with certain distance, then how can you find net electrostatic force on a particular mass? So same gravitational force you have applied, you have solved same kinds of problem in the gravitation. So I hope you will be able to do this type of problem with electrostatics also. Just apply F will equals to K Q1 Q2 upon R square. So net force will be F due to like this charge, due to like that, and net charge will be vector sum of these two charge forces. Okay. Let's solve the second question. A charge Q is placed at the corner of the square of the side A. Four charges are placed at the corner of the you can say corner of the square. The net force acting on the central charge. Again, same question I am asking to you. Q charge is placed at the center, and the same charges are placed at the corner of the center. And what is the distance between charges? Let's say side is A. So this length will be A. This angle is 45 degree, and this angle, this length is A by 2. So this length will again cos 45 degree will equal to A by 2 upon this R. So R length you will be get A by 1 upon root 2 will equals to A by 2 multiplied by R. So you will get small r equals to A by root 2. So smaller you will get A by root 2. Then force due to this one charge will be KQ square upon R square by root 2. That means R square upon root 2 square, that means 2. So that will be equals to 2. So 2 KQ square upon 2 kg square upon R square. That is the force between this one charges. Again, same force will be applied from this. Same force will be applied like this. Same force will be applied like this. If this force, these all forces are attraction in nature, then all forces play are opposite direction in each other. That means net force on the charge or the central charge will be 0. If placed a charge be placed at the 4 equal charges are placed located at the corner, the net force. Okay, if these 4 charges, this force mainly depends upon the nature of the charges. If these are positive charge and central charge is negative, then we can say the net force will be 0. But if these charges are all of them are positive, then repulsion between them like this, and repulsion between like this, and again repulsion between like this from the second one, and repulsion by the second one corner charge will be along the opposite direction. So attraction and repulsion both are acting in the opposite direction. That means net force will be 0. Whatever charge magnitude are given in front of yours. Okay. Let's solve the next problem. Two identical sphere each carrying charge q are separated by distance r. They are brought to contact and then separated again by the distance. Know the force between them becomes. So main thing is that if two sphere having charge q1, capital Q, and second one charge is having plus capital Q, if both are connected to each other, that means charge will be distributed by their average q1 q dash by q by 2. Okay. Now, what is the force between them right now? So if two spheres are separated with each other like this, and if their distance are smaller, then force between them k plus q small q upon r square. And if charge becomes like this, then force becomes k capital Q small q whole square by 4 upon r square. Okay, let's solve this equation. You will get kq square plus k capital Q square, then k capital Q small q upon r square. Got it? Two identical spheres. Okay, each sphere carrying charge q. That means that is also q. That is also q. So again, initially q, and after q plus q divided by 2. That means again the charge is q. Again the charge is q. And after touching of them, charge will becomes force of attraction will becomes kq square upon r square. Again, force become kq square upon r square. That means force will be same at the both condition. Okay, let's talk about the electric field. What is the electric field? Electric field is there. It is the area, or you can say it is the environment of nearby the charge, so that any other charge can feel the electrostatic force with the by the second one charges. So that field is called electrical field. The direction of electric field is always, you can see, if you have a positive charge, then that direction of electric field will be away from the charge, and if you have a negative charge, then direction of electric field will be towards the charge. Got it? So if any other charge which is placed nearest to the positive charge, then it will feel electrical force. So due to this formula on which at a certain distance other charge is feeling some force, this field is called electric field. So according to Coulomb's law, if a unit positive charge q naught, call it test charge, is brought near a charge q, then placed in space, the charge q naught will experience a force whose value force depends upon the distance between the two charges. That is also true. If the charge q naught is moved away from the q, the force of decrease at the distance, and the force would be particularly reduced to 0. The changes q naught then out the influence of charge q, that is called electrical field. So electric field, the region of the space surrounding by the charge q in which exert a force on charge q naught, is known as electrical field. The charge q this came same kind of thing I have already explained you. Thus, the electric field of a charge is defined as the electric field is a region around a charge in which it exerts electrostatic force on the other charge. This kind of thing I have already explained. These are the direction of the electrical field I have already explained. Positive charge particle electric field intensity will be away from the charge. Negative charge particle electric field intensity will be towards the charge. Okay, electric field intensity. Let's talk about the electric field intensity. Every charge particle having electric field, and this electric field always lies away from the charge, like this. Positive charge having electric field intensity like this, and negative charge particle having electric field intensity like this. For a given example, I can show you that these are electric field lines. If any charge particle which is placed in between electric field lines, then it will force of attraction and repulsion on the basis of their electric field strength of given charge. The strength of an electric field at any point in the space is known as electric field intensity, which I have already explained you. In order to find the value of electric field intensity at a point on the field charge particle, we place as a test charge on the figure, so that point, if F is the force acting on the charge test charge q naught, the SI unit of the electric field intensity is E is N multi N Coulomb inverse. Okay, N for Newton per Coulomb, or you can say Newton Coulomb inverse. So here is the two charges, which is positive and negative. Both are having own electrical field. Negative charges electrical field towards the negative charge, opposite, and positive charges having electric field you can say away from the charge. Got it? We have question number 1. Two charges plus q and plus 9q are placed at a distance 40 centimeter apart. Find the position of the line joining them where the net electrical field is 0. Okay, we have a question on which we have to find you can say charge. We have to find a charge, two charges. Okay, find the position on the line joining. Okay, we have another charge which is, we have two charges in which first one is 9q and second one is plus q. We have to put a third one charges so that this third one charge will be will have an you can say electrical equilibrium. So if a positive charge I placed near to the this charge will apply repulsion force towards this, and this charge will also repel to each other. So if repulsion due to 9q charge will directly equals to repulsion due to plus q charge, then we can say that this middle charge will be in equilibrium, electrical equilibrium. So for example, if these charges are apart from the 40 centimeters, so can I say that if I measure a distance x from the plus q, then it will apply a force k q square upon x square, and remaining distance will be from 9q will be 40 minus x. Then force of repulsion due to 9q charge will be k 9q multiplied by plus q divided by 40 minus x whole square. Okay, now solve this equation. K to k will be cancel out, q square will be again cancel out. 1 upon x will equals to plus minus 3 upon 40 minus x. So firstly you will consider as a plus 3, then you will get 40 minus x will equals to 3x. X you will get 10 meter from the, you can say, small q charge. And if you consider negative value, then you will be right 40 will equals to minus 4x. 40 will equals to minus 4x. Then you will be right, sorry, 40 will equals to minus 2x. X equals to minus 20. So minus 20 means second one charge will be placed at this distance from the 20 centimeter from the first one charge. So which one option is correct? Between the charges closer to q1, that is also possible. Between the charges closer to 9q, no. Outside the nearer to q, that is also correct. Outside the nearest of the q, that is 20 centimeter, repulsion will be like this. No, but still repulsion will not be happen, because why? Both forces are acting in the same direction, so repulsion will not be occur when charge placed at the 20 centimeter. So that is not correct. Outside the nearest charge q, that is not also correct. Correct answer is between the charges closer to the plus q. So according to this answer, we have got location will be, location is 10 centimeter, middle closer to the plus q charge. Let's solve this question by yourself. It is your homework. This is also for your homework. Okay. Let's talk about the electric field lines. What is electric field line? Electric field lines are such type of lines on which they are forming a region of the electric field on which any another charged particle can feel a electrical force. Okay, that is called electric field lines. The direction of electric field line intensity in an electrical field can also be represented by the drawing this line. So electric field line, when positive charge is placed nearest to the negative charge, then electric field lines will always transfer to the positive to the negative. Okay, that is the direction of electric field lines, like this. This is the electric field lines direction. Got it? Always starts from the positive to negative. Here is the perfect diagram regarding to this. So two electric field lines will never intersect to each other. And what if I tell you if two positively charged to nearest to each other, then we can say that at plus q and plus q. These field lines are always away from the positive charge. So they will be moved like this. And this field lines will also moves like this. Okay. So they will never intersect to each other, and they will never make a closed loop. Okay, like this. So this is the second phenomena which I told you. So electric field of two electrodes. So we have two electrodes, which is positive electrode, this is negative electrode. Electrode means is that electrode is the metallic plate which having charges. It could be positive, it could be negative, and whenever we are placing this electrode with parallel to each other, then it will create electrical field from positive to negative direction. And this combination, whenever electrode having some area distance between them is small d, this combination is called capacitor. Okay, and this capacitor having, you can say this capacitor have a property so that it can hold, it can hold, or you can say it can store a electric charge. Got it? So this is the capacitors. Okay. when when two plates are separate to each other with separate with distance d which are parallel to each other, then electric field will be applied from the positive electrode to negative electrode. So this combination is called, you can say, capacitor. Electric field in electric field in current carrying conductor. So here is the electric field due to current carrying conductor. You always know that inside a conductor, if I have a conductor, so this conductor having lots of free electron. So if I talk about conductor, this free electron are totally placed on the surface. So we can say that if no electron present in the inside the conductor, that means electric potential due to conductor inside the conductor will be zero. Got it? So here are the some conductor example on which we can say that how electricity can flow. So this is the common thing. Let's talk about the electrical potential. What is electrical potential? Electrical potential, it is the amount of work done. Amount of work done to carry a charge from infinity to fixed point. That work done is called electrical potential, and that work done is what? That is external work done. So we can also define as the electrical potential. Let's say potential energy we can write in the electrostatics K Q1 Q2 upon smaller. So if I write potential energy due to single charge particle as a Q1 by R, which means potential energy due to single charge particle for a unit charge, that is called electrical potential. But it's not a very true definition regarding to this. Mainly the true definition of electrical potential is that whenever we are carrying a charge from infinity to particular point, the amount of work done to perform this task is called electrical potential. And we are assuming infinity potential will be zero. That's why potential at P will be KQ by R. So, right, here is the definition which I have already explained you. Let's talk about the electrical potential. The capacity of the charged body to work determines the electrical potential on it. The measure of the electrical potential is the work done by the charge to body from to the 1 coulomb. Okay. Let's calculate the electrical potential. Electric potential unit, since the work done is measured in the joule on charge, the electrical potential unit is also joule per coulomb. Okay, joule per coulomb. Okay, and unit is also we can assume as a volts. Okay, this is the electrical potential unit. So electrical potential, as we know, Coulomb's law. So two charges plus Q and minus Q are separated by distance moduli. The electrical potential at the midpoint is plus Q and minus Q. Okay, what is the electrical potential at the midpoint? So due to at point 1, due to plus charge, potential will be plus KQ by let's say their distance will be you can say D. So this distance is D by 2, this distance is D by electrical potential will be KQ by D by 2. And electrical potential due to this charge minus KQ by D by 2. Then net electrical potential will be potential due to first charge, due to potential due to second charge, net potential will be addition of both. So net potential will becomes 0. So option A will be correct answer. Electrical potential difference. Let's talk about the electrical potential difference. So electrical potential difference is mainly defined to you that whenever you have a two fixed particular point and electric field direction, and we have applied action in electric field. So electrical potential difference mainly defines to do it is the amount of work done to move a single charge particle from initial first point to other point against the electrical field. This definition is called, this phenomena is called electrical potential difference between 2 points. Electrical potential difference is the amount of work done carrying a unit charge from one point to another point in an electrical field. This is called electrical potential. When a charge is released in an electrical field, it moves from a point of the higher potential, say A, to point a lower potential B. Got it? So whenever we are moving along the direction of electric current, let's say, whenever we are moving in the direction of electrical field, let's say this is point B, this is point A. So we can assume that VA, VB minus VA whenever charge is moving from A to B along the direction of electric field. So whenever charge is moving from opposite direction of electrical field, so you will be right VA minus VB. Okay, that is electrical potential, amount of work done. So that is the definition which I have already explained you. Electrical potential difference, I have already explained you, like if the potential of point A is VA and potential of point B will be VB, the energy at least this point will be QVB and QVA respectively. The change in potential energy of the charge when it moves from point A to point B will be equal to QVA minus QVB. This energy is utilized is doing some work done, useful work, and this work done is called electrical potential difference. Electrical potential difference. So energy you can also define as a U equals to charge multiplied by potential at any point. So energy at any point of potential energy in the electrical energy, you can be assume that Q multiplied by Vp. Got it? So let's solve a particular problem. A parallel plate capacitor, which I have already explained, with the dielectric constant K. If the battery is disconnected and the dielectric is removed, the potential difference will be. So main thing, we have some. Initially, we have parallel plate capacitor whose plate having, you can say, charges plus Q and minus Q. So you can see that electrical field direction will be positive to negative. So we can see that if a plate having, you can say, separation will be small d, then capacitance you can be write as K epsilon naught A by D. So if I fill the dielectric medium in this capacitance, okay, so capacitance will be increased as C dash will equal to K times of epsilon naught A by D. Now look at this question. What is question is saying? A parallel plate capacitor is filled with dielectric constant K. Okay, if the battery is disconnected and dielectric is removed, the potential difference will be. So if dielectric is removed, then capacitance will comes to the epsilon naught A by D. And then potential difference, initial potential difference, I can be write Q will equal to C multiplied by V. So Q is same, net charge will be same. So Q will be potential across A to B will equal to Q by C. And if C dash equals to this, you can say K times of C initial, C final. So C final, I can write C initial by K. So I can easily say if C initial is like this, epsilon naught A by, if C final is like this, epsilon naught A by D, let's say this is C final. So initially capacitance is K epsilon naught A by D. A by D. That means it is the C dash which initially capacitance will equal to K times of C final when dielectric has removed. So can I write C final instead of like this, K times of C. Okay, initially capacitance is epsilon K epsilon naught A by D, K epsilon naught A by D, and after removing this, capacitance becomes C dash will equal to epsilon naught A by D. So initial potential will be dependency upon Q by KC1, and after that potential becomes Q by C. That means potential has increased. So potential has increased whenever we have removed dielectric material from the in between, you can say, put a capacitor. So electrostatic potential and capacitance, I have already explained you that. What is capacitance? Like gravitational electrostatic force is conservative. For conservative force, work done depends on the position. That kinds of thing I have already explained in the work energy theorem. So we can skip it. Let's talk about conservative nature. I have already told you that kinds of force which does not depend upon the path, that forces are called conservative force, and that forces which are depending upon their path, that type of forces are called non-conservative force. Okay, so these are the few things regarding to the conservative force I have already explained. So for the closed loop, conservative force will be 0. Hence, work done against the force is the potential energy. Okay, that kind of thing I have already explained in the work energy theorem. So potential energy and potential energy difference and work done. So work done, I have already told you that from infinity to point B, external work done by the charged particle will be defined as the potential at a point P. So if I multiply this potential by the charged particle, that is I have called, this is your potential energy. So work done in bringing a test charge from infinity to point P, this is called potential energy difference. Bringing test charge Q from the infinity to point P against the field of source Q, external work done in increase in potential energy of the system. taking u infinity equals to 0. So external work done will be infinity to be dividing the test charge q gives the potential. So Vp equals to work done by the charge particle, work done by the external force from infinity to point P upon q of a single charge particle. That is called potential at a point P. Let's talk about electrostatic potential. I have already explained you it is the work done, which I already told you infinity to any point. This kinds of thing already you can say repetition in front of your PPT. Okay. So it is also scalar quantity units. You can also assume by reading this PPT. And this is the dimension formula of your potential. Only differences potential are physically meaningful 0 by conventional at infinity. Potential difference you can be write VA minus VB equals to W times of W from B to Q, B to A upon Q, which means a single charge unit to work done by the work done on the single charge unit to reach from point A to point B. That is called potential difference across A to B. Potential due to point charge, I have already explained you. Potential due to change point charge, let's say at a point B, you have to find potential. So potential you will find Vp will equal to, if this point P have a distance smaller than Vp, you will write Kq by small r. This is the potential due to single charge particle. The source charge plus Q fixed at the origin bring unit positive test charge from infinity to distance smaller. This all of kinds of thing I have already calculated in front of yours. So overall charge you will get K capital Q upon small r. K can be written as 1 upon 4 pi epsilon naught capital Q by small r. Got it? And here is the question which you have to solve by yourself. If you have in case of any doubt in the next class, you can ask me. Okay. Let's graph between V versus R for a point charge. So you can see that potential of a single charge particle at any point P, it is inversely proportional to small r. So V at P is inversely proportional to small r. That means its graph will be potential will be decreased with respect to distance. For a positive charge, potential will be decreased. For negative charge, potential will be increased. So this graph will showing same kinds of thing in front of you. For negative charge, potential increases. For positive charge, potential decreases. So this is the graph which is showing in front of you, which is the variation of the potential with the distance. Got it? Now, comparison of potential with electrical field. So electrical field mainly decrease with the distance when increase with the 1 upon r square expression, but potential will always decrease with according to 1 upon r. That means electric field will faster decreases with the distance as compared to potential. That is the variation of electrical field and you can say potential. So yellow graph showing the potential because it is decreases very slowly, but electrical field it decreases very fast. Okay, so this is the electrical field E directly proportional to 1 upon r square, and this is potential V is directly proportional to 1 upon r. So electrical field is faster decreases with distance because it is depending upon 1 upon r square expression. Now potential due to electrical dipole, how will you calculate? Potential due to electrical dipole, how will you calculate? This is your geometry. So electrical dipole you can also consider like this. If same magnitude of charge with equal nature are presented with a separate distance L, this combination is called electrical dipole. And electrical dipole direction we can also know that direction of electrical dipole will be negative to positive. Got it? That is the direction of electrical magnetic dipole direction. Electrical dipole direction. Okay. So you need to find out electric potential due to electrical dipole. How will you find? So firstly, it has find it. This is let's say at a point P, you have to find electrical dipole at point P. Let's say this distance is smaller and this distance is again r1 and this angle is theta. How can you find electrical potential due to dipole? So due to dipole, you can find electrical dipole. Dipole two equal and opposite charges. I have already explained. Dipole moment Q multiplied by 2a, which I have already explained. Okay, dipole moment you can be right. Charges of Q multiplied by their separation. This is L. This is dipole moment. This is P vector. Okay, and R1 is the distance from Q, and R2 is the distance from plus Q, and capital R is the from center, from their centers distance. Total potential energy, total potential at point P will equal to 1 upon 4 pi epsilon naught due to Q1 1 upon 4 pi epsilon due to Q2. For R is very less than A, so potential due to dipole you will be get P equals to K P cos theta upon R square. Okay, this is the potential difference. You can say this is the potential due to dipole. This derivation is too long. If I explained you in separate way, that it could be not understandable for yours. Okay, so you can just assume that is the direct formula, so that you can find potential due to any dipole. You will be write Kp cos theta upon R square. Here is the simple question which is in front of you. A dipole is placed in a uniform electrical field. Which statement is true? Potential energy is minimum at theta equals to 0 degree. Torque is maximum. Potential energy is theta, which equals to 0 degree, and torque is 0. So in an electrical field case, torque can be defined as P times of P vector cross E vector. Okay, so you can write P E sine theta. Theta is what? Angle between electrical field and dipole. So potential energy is torque is maximum at angle equals to 0 degree. So I think torque is not maximum, torque is 0. Okay, potential energy is maximum at 0 degree. So if any charged particle placed in the you can say electrical field, then potential energy can be written as Kp. Wait a minute. P dot E cos theta. Okay, that is the potential energy due to charged particle when it is placed in the electrical field. So if theta is 0, potential energy is 0. If theta is 90, if theta is 0, potential energy is maximum. If theta is 90, potential energy is minimum. That will be equals to 0. So option A is the correct answer. Got it? Let's talk about the second question. You have to do by yourself. It is totally depends upon your theory. So if you clear your theory from my lectures, that it can be resolved by yourself. Okay. So dipole potential, axial and equatorial points. How can you find dipole due to potential due to dipole at axial and equatorial points? Equatorial points means that is axial. When two charges are placed with separate distance L, then you have to find potential at a point P with axial distance. How can you find it? Okay, so for an example, this is plus Q, this is minus Q. Their separation, you can say L, and at a point P at distance small r, you have to find potential. So at point P, you have to find potential. You can write potential due to negative charge. So Vp you will be right minus KQ by R, and you will be and potential due to you can say positive charge, that will be KQ by R plus L. Got it? Vp you will be right after solving this equation, R multiplied by R plus L, R to R will cancel out, you will get minus KQ minus KQR minus KQL, and R plus L again will be cancelled, then you will be write plus KQR. So KQR will be cancelled out. Potential at P you will get minus KQL upon R multiplied by R plus L. So you will be right. Potential at Q into L can be written as a dipole moment. So potential at P you will write minus Kp upon R plus L. So this is your potential calculation at point P at the axial point. And similar kinds of thing you can apply when equatorial position. When theta equatorial line theta equals to 90 degree like this. Then whenever you are finding the potential will be 0 due to both. Okay. So here is the potential calculation of a due to dipole. Let's talk about the potential due to system of a charge. So this is the system of a charge. Potential you can be right. Potential due to charge Q3, potential due to charge Q2, and potential due to charge Q1. Potential you will be right KQ by R, and R is the distance of the P from the any charge, and you can put charge with the sign. So you will be right Vp will equals to V due to Q1 plus V due to Q2 plus V due to Q3. Okay, and after putting this expression, you can find potential due to all charges. So these kinds of things explain you like this. Okay, so let's consider this question. A dipole is rotated from 90 degree to 1 degree in a uniform electric field, work done by the electric field also. So work done by the electric field P dot E work done by the P into E sin theta. Okay, so work done will be, you will get P into E sin theta, and just put the value theta 1 to theta 2. So theta 1 is 90 and theta 2 is, you can say, 0 degree. So you will write P into E. Theta 1 is the, theta 2 is 90. So P into E is which means 1, and minus sin 0, which is 0. So work done you will get P into E. So work done will be P into E. Option B will be correct answer. Got it? Now superposition principle, which is directly saying to you, when if you have multiple charges, then potential, like you have multiple charges like Q1, Q2, Q3, Q4, Q5, Q6, and Q7, and potential due to all charges at point P. At point P, potential will equals to potential due to all charges V1 plus V2 plus V3 plus V4. That is called the superposition principle, which means potential at any point P will not disturbed by the another charge particle. Okay, you can be written like simple algebraic sum V1 plus V2 plus V3 plus V4 dot 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 Vn. So mainly superposition principle mainly states to you that each charge in system produces its own potential at point P at point P independent of the others. Okay, total potential will equals to algebraic sum of individual potential, which I have already explained you. Because V vector is scalar, no direction component will be needed. Also, V is the function of R is known, the electrical field obtained by the taking the negative accident, or again very efficient for complicated charge distribution. So mainly if you have a multiple charge distribution process and if you want to find potential at a point P, then you will be write potential due to all charges Kq1 by R, Kq2 by R, Kq3 by R, and totally algebraic sum of their potential. So you will get potential at the point P. So let's solve one more thing. Electrical potential is a scalar quantity. Two bodies produces potential V1 and V2 at a point. The correct resultant potential will be V1 minus V2. Vector sum of V1 plus V2, algebraic sum of V1 plus V2, product of V1, algebraic sum of V1 plus V2, because electric potential are the scalar quantity and plus and minus sign will depends upon their charging nature. If both charges having opposite nature, then you can be minus. If both charges having positive nature, that means you will be simply add. So overall, you can say algebraic sum is the correct way to find the potential at any point. Okay, so point C, option C is the correct answer. Let's talk about the equipotential surface. Equipotential surface is a such type of surface nearest to the any charge Q on which potential due to this charge will always constant. If I talk about this example, then you can see that this is positive charge Q, electric field lines having like this. Okay. So what if I tell you at any point like this, like this, like this, like this on the particular surface, on the particular circle, all of these points having same distance from the capital Q. All of these points having same distance from this charge, so that can I say potential can be written as KQ by R. If distance is same across every point, then we can say that in this particular circle, potential is same, potential is constant. But if I talk about this circle, potential is different from this first one circle, but at every point of this circle, potential is same because distance from this capital Q charge will always constant. So equipotential surface mainly refers to that it is the surface nearest to the any charge Q where potential at every point on the surface will always assume as a constant. Okay, so these are the equipotential surface definition. Here are some key points which I already give you. So some key points regarding the equipotential surface which I can give you that this is plus Q charge, potential at this is equipotential surface. Okay, so if I tell you if potential at point A will equal to potential at point B, if BA equals to VB, then can I say that work done by the external force to reach at point A to point B will be potential difference. So if potential difference is 0, that means work done external will also 0. Okay, so this is this point which I explained to you. In equipotential, there no work done is done when test charge moving from along B to A to B because potential across 2 points will be 0. Electrical field is perpendicular to the normal of equipotential surface, which is already showing in front of the question diagram. It points from higher potential to lower potential is the which means electric field direction mainly refers to higher potential to lower potential. Okay, two distinct equipotential surface never intersect to each other. These are the rule of equipotential surface. Two equipotential surface will never intersect to each other. If a region of strong electric field equipotential are close together in the weak electric field, okay, these kinds of things which I have explained to you. So here are equipotential surface of a different charge particle like this. So if plus q and minus q charge particle are placed in front of nearest to the in front with a separate distance small d, so equipotential surfaces are looking like this. Okay, so at this point, potential will always constant to each other. Got it? So here is the equipotential surface due to dipole, equipotential surface due to uniform electrical field. That is the equipotential surface due to uniform electrical field, and equipotential surface due to charge point. Got it? And here is the question which you have to solve by yourself. Let's talk about the relation between electrical field and equipotential surface. So electrical field can be written as E factor equals to minus dV by dr r cap. Okay, so mainly I can say that dV will equal to minus E dot dr. So potential difference across 2 points will be relatable as E dot dr product. Okay, so this is the relation between electrical field and potential. Moving from again V minus dV through a small displacement against E. dV can be written as minus E dot dl. E is the electric field, dl is the small displacement vector, which I have already told you. Component of E along the any direction, dV by dl along the direction. Okay, E always point from higher potential to the lower potential, and magnitude of E will equal to minus the magnitude of dV by dr between two close equipotential surface. Got it? So here is the simple relation between electric field and electrical potential. So it can be written as E equals to minus dV by dr. Let's solve this equation with the help of, let's solve this question with the help of this expression. Electrical potential at a point is given where V equals to 50 multiplied by 2. Is it multiply? What is given? 50x, okay, 50x square. 50 multiplied by 2 volts. The electric field at x equals to 2. I think I can't understand what is given. Okay, I think potential electric potential, it is given as 50x square. Okay, it is given like this. You have to find electric field at when x equals to 2 meter. So you can also not know that E dot dl equals to dV. So if you want to find the electrical field, then you will be write dV by dl. So according to this case, you can consider equipotential potential is depending along the x. So you will write dvx upon dx, then you will find electric field along x direction. So electric field along x direction, you have to differentiate a potential equation with respect to x. This is the potential equation with the which is varying with respect to x. You will be write differentiate. You will be write 100x. So x equals to 2 meter. Electric field you will be get 100 multiplied by 2. That will become 200 Newton per coulomb. So this is your electrical field. Again, potential energy of the system. Potential energy of the system. It is also like you can say electrical potential. If you want to find potential energy, then potential energy can be written as K Q1 Q2 upon small r. So if you have two multiple charges, then you have to making a pairing. So for this charge Q1, Q2, Q3, you will be write potential energy total will equal to potential energy due to first and third charge, potential energy due to first and second charge, plus potential energy due to first and second, okay, third and second charge. Okay, so this addition will give you the potential energy of the system. Got it? So these are the few things which I have already explained you. And potential energy can be written as K Q1 Q2 upon separation between the charges. Let's solve this problem. These three charges Q1 plus Q minus Q and plus Q are placed at the corner of the equilateral triangle. The total potential energy of the system you will be write like this. This is plus Q. This is minus q, and this is again plus q. Distance between them, it is also a. The distance between them, it is also a. The distance between them, it is also a. You have to find, place the corner. You have to find the total potential energy of the system. So you have to find total potential energy to the system. You will write potential energy due to these charges. That is P1. Potential energy due to these charges. This is P2. And potential energy due to these charges. This is PE3. So you will be write potential energy of the system. You will be written as PE1 plus PE2 plus PE3. Got it? So potential energy of the system, you will write K Q square upon A due to this due to negative to positive, potential energy will get negative because you have to put your charge value with the negative sign. Again, potential energy to this charge will be minus K Q square upon A, and potential energy this 2 1 will be K Q square by A. So net potential energy K Q square by A minus 2 K Q square by A. Net potential energy will be get minus K Q square by A. This is your answer. So what is your answer? Option C is the correct answer. Got it? Potential energy in an external electric field. So due to an external electric field, potential energy can be given as charge to place at the point in external electric field. External potential is V. U can be written as Q multiplied by V. U equals to 0, where V equals to 0. For two charges Q1, Q2 in an external electric field, U can be written as Q1 times of V. Q1 times of voltage. You can say potential across by R1, and Q2 times of potential across R2, plus 1 upon 4 pi epsilon naught Q1 Q2 upon R12. So the first two terms interaction with the external electric field. Third term will be mutual interaction between the Q1 and Q2. So this is your electric field, electric potential energy calculation in external field. So we have another question which I think you have to do by yourself. Let's talk about the potential energy of a dipole in a uniform electrical field. So potential due to dipole, when electrical dipole are placed like this and their distance between them that is smaller and making an angle theta, which you can say electric field, then potential energy can be written as minus P into E multiplied by cos theta, or you can say U will be written as minus P dot E. That is the simplest formula that you can be assumed. Okay, so electric dipole is a vector quantity, electric field also a vector quantity. If you have a if in the inside the question you have a electric field and dipole with the vector form, then just apply your dot product. You can find your potential energy between them. And if you have a magnitude, then consider angle between them theta, and you can just apply P into E cos theta. You will get electrical potential energy due to dipole. Got it? It is a simple formula. And theta equals to 90, potential energy will be 0. Here is again one question. A dipole moment 2 centimeter is placed in uniform electric field. Angle is 60 degrees. Find the potential energy. Potential energy will be right minus P into E multiplied by cos theta because magnitude is given. So P into E. So P will be already given minus 2 coulomb, and electric field intensity is 5. Cos theta, cos 60 degree, you will be right 60. So minus 5 is your answer of potential energy. Electrostatic conductors. What is conductor? Conductor are such type of material in which have number of free electron. Huge number of free electron containing substance are called electrical conductor. Electricity and heat energy can easily pass through them. So electric conductor is what? Electric conductor is a such type of material which can allow heat and electricity from them. And second thing, it have number of free electron, huge number of. Okay. So electrostatic conductor can be defined as electric conductor in the electrostatic equilibrium, because every charged particle lies on the surface on the electrical conductor, so that we can see that electric field inside the conductor will be 0 and potential will be constant. Got it? Because electric field mainly depends upon KQ upon R square. So if net charge inside the, you can say inside the conductor is 0, then electric field will be 0. A conductor has free electron charge carries okay, and electrostatic equilibrium, no current flows from the inside the conductor. Charges redistribute until electric field is 0. Any excess charges reside only in the outer of the surface. The conductor an equipotential volume in which at every point inside the conductor potential is always constant. If potential is constant, then we can say that conductor has equipotential volume. Okay. So properties of conductor in equilibrium: inside the conductor E is 0. just outside the surface, the electrical field is normal to the surface, E equals to sigma upon epsilon. Potential of the conductor, the entire conductor including its surface, it's the same potential constant. Excess charge distribution, excess charge reside only the outer surface of the conductor. Okay, field inside an empty cavity, the electric field inside a cavity with no longer is zero. This is called electrostatic shielding. Got it? And surface charge density is greater at sharp point, and at this is higher where the radius of the curvature is small. Again, dielectric and polarization. What is that? What is dielectric and what is polarization? Dielectrics, insulators, no free charges. Okay, dielectrics are insulator which does not have no free charges. In external electric field, molecules, dipoles align or get induced, which means whenever you are applying external electric field, they will be induced. Okay. Net result, surface charges appears. Polarization P. Induced electric field oppose the applied electric field inside the slab. Net electric field can be written as E equals to E naught by K. In the dielectric, K is a dielectric constant. K is greater than always, and for vacuum, K equals to 1. Okay, so whenever you are applied, you can say dielectric material in between a particular, in between the electrical field direction, then you can say that if initially electric field is K, if initially electric field is E naught, then new electric field, when you are applying a dielectric constant, then new electric field becomes E naught by K. This kind of thing we will apply in the capacitance and capacitance calculation. So what is capacitor? Capacitor, two conductors separated by an insulator carrying equal and opposite charges, that is called capacitor, which I have already explained you. Two plates which have metallic plate and in which have distance very small d, and this combination is called capacitor. And electric field inside this, you can say capacitor, will be positive to negative. Potential difference between V plates is proportional to the Q, which means the potential difference, let Vp and Vq. So Vp minus Vq is always proportional to charge on this plate. If I remove this proportionality constant, then I can say that potential difference across plates will be equal to C times of Q. C is what? C is the capacitance. Okay. C is the capacitance. Got it? So this same kind of thing which I have already explained you. C larger than store more charge at the same voltage. So main thing is that C is what? C is the capacitance, that this capacitor can hold or you can say store the charge of any electrical through any electrical devices. Okay. So at the same potential, if any capacitor having higher capacitance, that means at the same potential it can hold higher value of charges. So these 4 to 5 kinds of important words you have to consider. So capacitance you can be considered as a charge store on the plates divided by potential difference across the conductor. So you can be write capacitance like this. So capacitance you can say unit one you can say assume as a farad. One capacitance that will equals to 1 farad. Let's solve a particular problem regarding to this. Two identical capacitors, each of capacitance C, are connected in the series to a battery of a voltage V. The charge on each capacitor will be. So capacitance can be written as Q by V equals to Q by C in the capacitor. Okay, the two identical capacitors, each of capacitance C, are connected in the series to the battery of voltage V. The charge on each capacitor. The question is looking like this. Two capacitors are arranged in the you can series or parallel. Okay, sorry, both are arranged in parallel. Sorry, series like this, and they are connecting you can say they are connected by the battery whose voltage is V and charge Q is moving from this. I have to find charge store in the first capacitor. Let us assume that is Q1 and that is Q2. So we can apply, you can say simple Kirchhoff law formula in the you can say capacitor case. So you will be write positive V. And if charge Q is flowing from this, you can say capacitor, then its potential you will write Q by C, and that will be equals to again minus Q by C. That will be equals to 0. So if same amount of charge is passing through the you can say C, let's say Q charge is passing through the battery, and same amount of charge is passing through the C. So we have to consider the potential difference across them. So potential difference, if charge flow passing through this C and capacitance is also C, then voltage across will be E. C will equals to Q by C. Again, voltage across this one is also Q by C. Got it? So what we have to find? Two identical capacitor series and battery of the charge on each capacitor will be Q equals to. So net charge passing through the will be Q. So charge passing through this capacitance will be C multiplied by V. So each capacitor will get, if each capacitor having capacitance C, voltage is V, then charge passing through the capacitor will be CV. So option A is the correct answer. Then let's talk about the parallel plate capacitor. Parallel plate capacitor, I have already described you. These are two electrodes of metallic. One of them is positive, second one is negative. Okay, this one is positive, this one is negative. So electric field direction will be positive to negative. So inside this, you can say conductor, electric field intensity will be sigma upon epsilon naught. Okay, so can I write potential difference across this electrode will be E dot dl will equal to dv. So dl is what? Dl is the d. So sigma upon epsilon naught multiplied by d will equal to voltage potential difference across AB. Can I write like this? Okay. Now what we can do? So let's consider electric field multiplied by d will equal to voltage across AB. Okay. So let's consider two charges having plates area A and separation SD, capital Q charge Q. Surface charge density is sigma equals to Q by A. So can I write surface charge density is what? Capital Q by A, charge per unit area. So sigma can be written as charge per unit area multiply by upon epsilon naught and multiply by D. So that will equals to AB. Okay. So after that, you will get Q will equals to VAB multiplied by epsilon naught A by D. So what is this? I have already told you that during the capacitors, the voltage, the charge stored on the capacitor will always directly proportional to the voltage across their capacitor's plate. So this is the voltage across capacitor's plate, this is charge, and this is the proportionality constant, which I have already told you, this is the capacitance. So capacitance can be written as epsilon naught A by D. So here is the capacitance of the parallel plate capacitor, in which capacitance mainly depends upon the area of the you can say electrode and also inversely proportional to the distance between them. So this is the capacitance you can say formula. So this is the question related to the similar kinds of formula I have. You can solve by yourself. So now effect of dielectric in the capacitance. So if I filled a dielectric constant, if I filled a dielectric in between the you can say capacitor's plate, so electric field nu will becomes E naught by K, which means old let's say without dielectric material, electric field is E naught, and after filling the dielectric material, new electric field becomes E old by K. So if electric field becomes E naught by K, so can I write E naught is also sigma upon epsilon naught upon okay, sigma upon epsilon naught upon K. Sigma can I write is the surface charge density, so I can write K Q upon A upon epsilon naught upon K. Sigma is what? Surface charge per unit area. So I have write Q upon A epsilon naught upon K. So that is equal to, you can say, E nu. That is E nu. So can I write E nu multiply separation between the plate, that will equal to VAB. You can also write. So can I write E nu will equal to Q upon A epsilon naught K multiply by D, that will be equal to VAB. So you will be get answer VAB multiply by A epsilon naught multiply by K upon D. So can I see that this is the older capacity and this is the charge, then charge will be directly proportional to you can say voltage. So we can say that when we fill the dielectric material inside the you can say in between the electrode, then we can see that C nu will becomes K times of epsilon naught A by D. So if this is C old, so can I write C nu will becomes K times of C nu. So when I fill the dielectric material between two electrode, or you can say between capacitor, then we can see that the new capacitance will becomes K times of C old. Got it? So this is your formula. Now let's talk about the combination of the capacitor. If two capacitors are arranged in the series wise combination, then it will be written as 1 upon C net will equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Got it? This is the formula regarding to finding C net. C net is what? Equivalent capacitance. Got it? So this is the formula. And if two capacitors are arranged in the parallel wise combination with the battery, then C net can be written as a C1 plus C2 plus C3 and so on. So this is the two formula on which you can find equivalent capacitance in the series and parallel wise combination. We can also see that the voltage across every capacitance in the parallel wise combination will be constant, and voltage across every capacitance, every capacitor in the series wise combination will be different. So total voltage can be written as mu plus V2 plus V3, and with the help of this equation we have find their, you can say, expression. Let's talk about the energy stored in the capacitor. So energy mainly stored in the capacitor in the form of charge. Okay, so energy can be stored in the capacitor as a firstly Q square by 2C, and second, energy stored in the capacitor will be 1 by 2 half C V naught square. So if you have a potential across the, you can say, if providing energy, and due to flowing of charge, if capacitor having some energy, and due to this energy capacitor changes its potential, then on the time energy stored by the capacitor with the changing the potential will equals to E equals to 1 by 2 C V naught square. 1 by 2 C V naught square. And if capacitor getting some charge, then during the charging of the capacitor, energy stored by the capacitor will be Q square by 2C. So that is also very similar. So mainly overall, that is the potential, that is the charge. So the charge, the energy is totally, you can say, constant. Potential versus charge, you can say potential versus charge diagram is always constant whenever capacitor getting some energy. Okay, so that is the few things which you have to understand. So this is the formula summary regarding to potential, which I have already explained you. Formula is very important. So these are very important formula which I have already explained you in the following PDF. You have to understand regarding to this. So let's solve the particular problem regarding this chapter. This three capacitor of capacitance C, 2C, and 3C are connected in the parallel to the battery voltage V. The total energy stored in the capacitance will be. So total in the parallel combination, voltage will be constant. So you will write energy stored by the capacitor will be half C V naught square. Okay. So you will write 1 by 2. C is what? C is C net. And if these three capacitors are arranged in the parallel wise combination, that means you will be apply C plus 2C plus 3C. That will become 6C. So 6C multiplied by V square. So 2 ones are 2, 2 6 are 3, and there you will get 3C V square is the energy stored by the capacitor. So this is also same expression, 2 ones are 2, 2 6. Answer you will get option B. I hope you are getting my point. Let's talk about the current electricity. So current electricity is what? Current electricity is the particular section of a wire, amount of charge flow from the particular wire at a particular time interval. That is called electric current. Okay. So it is also called charge in motion constitute electric field. Neutral example, lighting, discharge, never signal. Okay. Everyday example, torches, clocks, appliance powered by the steady current. This kinds of example of electrical energy, you can say, we can feel that yes, electric current is passing through the torch, and then torch is working as a photo, by forming a light. Okay, this chapter develops the basic law of electric current. Okay, that's something we have understood. So let's understand about the electric current. I have already told you, in the given time interval delta Q charge passing through the particular wire in the given time interval delta T, then I can say that electric current passing through this wire will equals to delta Q by delta Q, delta Q by delta T. And if you want to find the charge flow at a particular instant, then you can be write I equals to dq by dt. Okay, so dq is what? Smaller charge amount which has flow at the dt time interval. That is called I instantaneous. That is equal to I equals to dq by dt. So I can be measured as the unit as ampere, and this is the brief understanding regarding to electric current. Okay. Here is the question which you have to solve, which is the definition wise question you have to solve by yourself. So mainly a current passing through the conductor, 2 ampere current passing through the conductor with a 5 minutes discharge flow from the conductor will be. So time duration you have already given 5 minutes, and current passing through the cross section is 2 ampere. So delta Q you will write I multiply by delta T. So delta Q you have to find. I already given 2 ampere, delta T will be 5 minutes. So in the 5 minutes, you have to convert into the second, that will be multiplied by 60. So you will be write 10 multiplied by 6, that is 600, and 600 coulomb is the charge flow in the given time interval. Here is the second question which is given in front of you. A conductor carries a current I if charge density if and drift velocity are double, then new current becomes. So then again, it is the simple formula regarding to drift velocity. Relation between drift velocity and current will be N. I equals to N E A V D. N is the number of electron, is the charge of electron, A is the, you can say, area of cross sectional, and V is the drift velocity. And relation between current density and current will be J equals to I by A. So what you have to find, if charge density and drift velocity are doubled, then the new current becomes. So I think we should multiply these terms with the other also. So you will get I square multiplied by A will equal to N E A V D multiplied by J. I have multiplied J multiplied by I. Okay, so this multiplied by this and this multiplied by this, you have got like this. So I square you will got N E A square V D multiplied by J. If this two quantity are double, you will get square root value. So if these two quantity are doubles, that means 2 multiplied by 2 VD and J. So 2 will come 2 out, then and I new will become 2 times of I old. So you will get option B is the correct answer. Got it? So you have to understand this two result of current density. Current density mainly refers to it as amount of electric current per unit area is called current density, and drift velocity is the after applying the external electric field, the drift, the motion of the free electron after applying the external electric field. So that motion of the electric field when covered by the distance of the electrical charges after applying the electrical field, this motion is called drift motion. And during the drift motion, distance covered by the particle during the driftness upon time taken by the electrical charge, that is called drift velocity. Got it? So electric current in the conductor, that is also I have already explained you that this is the electrical current. Electron moving to negative to positive, but positive electric current passing through the negative to positive. Okay, so electron moving to positive to negative, current is passing through the positive to negative. So this is the brief example regarding to how current is passing through the metals. These are the few things. Let's talk about the Ohm's law. Ohm's law is the basic phenomena of the, you can say, current electricity, in which we are showcasing to you that how potential depends upon the current. Okay, so mainly it's Ohm's law mainly showcasing to you that when any wire in which we constant their physical parameters like length, area, or you can say wire also, and temperature. If these three kinds of things are we are applying on the wire is the constant, then we can say that the current passing through this wire will directly proportional to the voltage. So that's why we can say that voltage passing through this voltage across the wire will directly proportional to the current, and we can say that voltage can be written as, after removing the proportionality constant, I can write V equals to I into R. Got it? So this is the voltage relation with the, you can say, current. So R is what? I is the current, V is the voltage across the wire, and R is the resistance of the wire, which is mainly depends upon the material of the resistance, length of the material of the wire, and you can say physical quantities of the wire, like length, area, cross-sectional, and you can say temperature. So this Ohm's law mainly states that if we constant their physical parameters of the wire very constant, then we can say that the voltage across the wire will directly proportional to the current passing through the wire. Okay, and the relation, the graph is mainly showing to you that slope of this graph is showing to you the VI graph, which is showing to you V is directly proportional to R when R is the constant, and slope is given as R. So that is V equals to IR, R equals to V upon I. Resistance and factor affecting on this. So I can give you a direct formula. Resistance directly depending upon this formula, R equal to rho L by A. Rho is the resistivity, L is the length, A is the area. So rho is the resistivity. Resistivity mainly depends upon the material. Every material having a different resistivity. That's why we can say that resistance of every different material will be different. Okay. So rho is called resistivity, and it is really helpful to find out conductivity of any material. So 1 by rho ratio can be say that as a conductivity, that is called as sigma. So we can say that reciprocal of resistivity, we can say it is the conductivity. So overall, whenever we are increasing the length of the wire and constant the cross-sectional area, then we can say the resistance of the wire will be increased according to their length. So if I increase area of the cross-sectional of the wire by constant the length, then we can say that resistance of the wire will be decreases. So that kind of we can deal with the simple formula is that if I increase the length, how resistor is depend upon the material, length, and area. So that kind of thing we have discussed according to resistance and factor affecting it. Let's talk about the current density, resistivity, and conductivity. Resistivity I have already told you. Resistivity is the simple property of the wire, which is directly showcased to you that how wire at a particular unit cross-sectional and unit cross-sectional area, what is the resistance of the particular material. That unit cross-sectional area and unit cross-sectional length material resistance will showcase to you the resistivity of the material. Okay, and reciprocal of the resistivity, that is called conductivity. Conductivity mainly showcase to you that how easily electricity can be passing through the particular wire. Okay, that is called by the conductivity. Conductivity can be represented as a sigma represented as a 1 by rho, and rho resistivity as a represented as a rho. That is mainly depend upon the material. And what is current density? Current density I have already explained to you. Current density is the amount of electric current passing through a single unit area from the particular wire. That is called current electricity. So J can be represented as I by A. Current passing through this wire at a per unit area, that is called current density, that is equal to J by A. So that is completion of current density. Let's talking about the drift electron. What is drift electron? Whenever in a particular wire, whenever you are applying external electric field on the wire, then you can see that electrostatic force always acting opposite direction to the electrical field. So that is called Fe. So due to this Fe, number of electrons are present in the, you can say, wire. So every electron are always colliding to each other. So that's why sometimes electron can be drift to their path. So total distance covered by the particle during the drift motion of this inside the wire upon time duration of this particle, that is called drift velocity. And drift motion is what? Whenever you are applying external electric field, then motion of the electrical charge opposite direction of the electric field, that is called drift motion of the electron. Okay, so drift motion Vd can be defined as a E charge of electron divided by electric field, tau divided by m. Tau is the what? The tau is the time duration between the collision between the two electrons. Okay, and m is the mass of the electron. So drift velocity can be written as minus E, capital E, tau by m. That is the first formula of electric field, drift velocity in terms of electrical field, electrical charge, tau, and mass of the, you can say, electron. That is the, you can say, drift motion of the, you can say, electron. Okay, and relation between drift velocity and current electricity, that is what? I equal to NEAVD. Okay, that kind of relation I have already explained to you in the previous question, which directly showcased to you that N is the number of electron, E is the charge of electron, A is the area of cross section, and VD is the, you can say, drift velocity of the, you can say, every electron after applying external electric field. So this kind of thing I have already explained to you in previous question, so that you have to consider like this. Let's talk about the origin of the resistivity, microscopic view. So this is also again explained about the resistivity. Resistivity is also constant, which is totally depends upon the material. Okay, so sigma, it is the, you can say, conductivity, And resistivity can be defined as a rho equals to m upon, it is also reciprocal of sigma. So that is also can be explained. So J equals to can be explained. J is the new formula which you can be explained in terms of electrical charge, and tau you can be right, and E square tau by m multiplied by external electrical field. So that is the current density formula which you have to understand whenever you are studying about the J. So that is a microscopic view in which you can, which is directly showcasing to you that how mainly resistivity depends upon only material. So with the help of this formula, you can consider like this: yes, resistivity mainly depends upon the material only. Okay, so this is the origin of the resistivity. So mobility of the charge. What is mobility? Mobility, magnitude of drift velocity per unit electrical field. That is also simple. You can also say that I equals to NEAVD. So what is drift velocity? What is mobility? Mobility mainly refers to that drift velocity per unit electric field, that is called mobility. So VD by E, that is called mobility. You have to know. Okay. So according to this formula, I VD you will get I upon NEA. Okay. And divided by electrical field, you will get mobility, and you will get I upon NEA multiplied by capital E. So that is your mobility of the charge carriers. Okay. So mainly mobility is very simple to understand. Mobility is the drift velocity per unit electrical field. Okay. That is the mobility. So here are simple basic formula regarding to this. You can answer. Okay, limitations of Ohm's law. What is the limitation of Ohm's law? Where Ohm's law will get fails? So Ohm's law is not an universal law. Deviation occurs in many materials devices. V decreases to the proportional to the I curve band non-linear. Relation depends on the sign of the V in semiconductor diode. VI relation is not unique. More than I one I for V same gases thyristors. Okay. Okay, non-ohmic devices are the backbone of modern electronics. So mainly Ohm's law will not follow always, because in our surrounding there are all huge type of material which does not obey Ohm's law perfectly. Okay, for example, some semiconductors, some electronics, modern electronics devices does not obey Ohm's law easily. Their graph will look like this. In this scenario, you can see that voltage is not directly proportional to the current. Okay, so this is the limitations of Ohm's law. Ohm's law will be valid till when any single wire which who have you can say constant physical parameters, then it will follow Ohm's law, in which current will be directly passing through this, will directly proportional to the voltage. VI characteristics Ohm versus non-ohmic. So ohmic current metallic wire at constant I, straight line through the origin. So any metallic wire which have physical quantities are same, then we can say that Ohm's law will be followed. Diode, almost zero current in reverse bias, rises sharply after knees in the forward bias. That kind of thing you will understand in the, you can say, electronics chapter, which I will cover in the next time. Okay, so main thing you just understand is like that diode, like electronic devices, they does not follow Ohm's law very easily. Got it? So mainly a single wire which has single physical quantities are same and temperature is constant, it will follow Ohm's law very easily. Got it? So that is the new thing which I have already explained to you. Resistivity of various material. I have already told you that resistivity is mainly depend upon the material to material. So it is the normal informative way of understanding that how resistivity are having value with different material. So here are the order of the some materials resistivity which you have to understood. That is the informative thing which you have to know. Okay, this is the first question which is given in front of you. A wire of resistance capitalized twice 3 times to its original length without changing its volume, then the new resistance will be. So R can be written as rho L by A. So in this question, volume of this wire will not be changed. So that's why we can be write L multiplied by L from numerator to denominators, and resistor we can be write as rho L square by B. Now in this case, volume is constant, but resistance is depending upon the length with the square value. So if initially resistor is R will equal to rho L square by V, and after 3 times of its original length, resistor will become rho multiplied by 3L. 3L square, that means 9L square by V. So new resistance will becomes 9 times of R old. Okay, so which option is correct? If initial resistance is R, final resistance will becomes 9R. So option C will be the correct. So with the help of this formula, you can solve this type of problem. So I think this problem you have to solve by yourself. And this problem, 3 resistors, 4 ohm, 2 ohm, 6 ohm are connected in the parallel cross combination. The current equivalent resistance of the combination will be. For parallel wise combination, I have already explained you that for parallel wise combination, net resistance will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. That's why you will write 1 by 4 plus 1 by 2 plus 1 by 6. And after getting LCM will be, you will get 12. So 3 plus 6 plus 2, that will be 8 plus 3. 8 plus 3, 8 plus 3, 8 plus 3, 11. I think I got some mistake. 3 plus 6 plus 2. I think question having some mistake. 1 by 2 plus 1 by 4 plus 1 by 6. LCM we will get 12. Okay. So 2 plus 6 plus 3. Okay. Question having some mistake. Resistance could become nearest to the 1. Okay. So we are taking first option is the correct. I think data's value are slightly different. That's why option are not matching to you. Okay. So it is a question mistake. A wire of length L and resistance capital R cut out into 2 equal parts. These 3 parts are then connected in the parallel. Then the equivalent resistance, that is homework for yourself. Do yourself, and if you have any problem, you can ask me. In a circuit, 2 resistors R1 and R2 are connected in the parallel. If R1 is greater than R2, then equivalent resistance approximately you have to do by yourself. That is also formula based question. Okay. If a battery of EMF 10 volt, internal resistance is 2 ohm, is connected to the resistor of 8 ohm, the current passing through the circuit will be. So internal resistance of the battery we can arrange in the series wise combination with the others. The net resistance will be, you will get 10 ohm, and voltage across the battery will be as a 10 volt. So I will be get V by 10. You will be get V by 10, and V is what? V is 10 volt, and net resistance will be 10. So you will get 1 ampere current passing through this. I think someone is calling to me. Just wait a minute. So we have solved some practice problem regarding to this. Let's solve some more problem regarding to this. These are again same problem which I am giving to you. If R resistor is band in the circle, the effective resistance between 2 diameter you have to do by yourself. This is also formula based question. Just apply rho L by A formula and solve this question according to your brain. Okay. And this is again second thing which I telling to you, how resistivity and resistance are depending upon the temperature. So this is the simplest formula. Resistivity is totally depend upon the temperature like this. Rho at a particular temperature will depend upon rho naught 1 plus alpha delta T. Okay, this is the dependency of resistivity. So I can already told you that resistance is totally proportional to resistivity. So can I say that resistance at a particular temperature T will equal to R naught 1 plus alpha delta T. So this is the resistivity. This is the dependency of resistor at a particular temperature. So for example, for a metal, resistivity increase almost linearly with time T. So resistivity can be increased at rho naught 1 plus alpha T minus T naught. Okay, delta T is the T minus T naught is the change in temperature, where alpha is the temperature coefficient of the resistivity. Alpha is greater than 0 for the metal, and reason at higher temperature, lattice, more collision, smaller, larger rho. That means alpha is greater than 0 for metal. You have to understand like this. Okay. And alloy for nichrome, very small alpha, so use standard resistor. Okay, so resistor is mainly resistivity mainly depends upon like this, and resistor is also depends upon like this, rho R naught 1 plus alpha delta T. Alpha is what? Temperature coefficient. Temperature dependency of alloys and semiconductor. Alloys, nichrome, magnesium constant, alpha nearest to the 0, B barely changes with time. Used to manufacture present standard resistor and heating coils. Semiconductor, germanium, silicons, rho decreases rapidly with the temperature. Okay, because alpha is negative. Reason at higher temperature, more electrons are thermally excited to the conduction band and increases. Electrolytes and insulators are also shown in the resistivity with this rising in temperature. So these kinds of informative things you have to understand whenever you are thinking about the temperature dependency according to register. Okay, so in case of, you can say, semiconductors, mainly the energy gap, mainly by providing increasing the temperature, the electron getting energy from the heat so that it can directly move to the valence band, conduction band. And due to conduction band, number of free electron increases. That's why after increasing the temperature of the semiconductor, they provide superconductivity to the electricity. So for the semiconductor case, alpha is negative for the semiconductor. And you can say for alloys, nichrome and manganese, some particular metals, alpha is 0 properly. That means resistor will not be changes according to temperature. So that kind of thing you have to understood. Let's talk about the electrical energy, electrical power. So electrical power is what? Electric power mainly defined as P equals to VI, and its unit is watt. And you can say that if a battery having voltage, you can say V, like voltage. If a battery who have a voltage like V, then if current passing through this I inside throughout this battery, then we can see that power across the battery will equal to V into I. Okay. So can I write like V equals to IR? So power across the resistor will also given as I square R. Okay. Now we can see that power equals to W upon T. Okay. And can I write W upon T equals to VI? So can I write the work done by the battery to provide electricity will equals to VI multiplied by T. Okay. So this is the energy provided by the battery at a particular time. Okay. So can I write V equals to IR? So work done by the battery can be written as I square R into T. So that means main thing is that this energy, whenever battery doing some work done towards the particular resistor, then resistor stored the energy of the battery as a terms of I square R into T, and battery provides energy in terms of VI into T. Got it? So main thing is that when a charge Q moves through a potential difference V, work done is defined as Q upon Q into V. If steady current flow throughout the delta T time I delta T energy transfer, the overall power formula will be derived as a power will equal to W upon T. It is the derivation of the power. Okay. And power formula, it has also given as P into VI according to this. So here are some basic, you can say, parameter of the power. Work done by the battery can be written as VI into T. Power can be written as P into VI. P equals to VI. And 1 kilowatt watt hour is written as a 3.6 into 10 to the power 6 joule. This is your question. Let's talk about the power dissipated by the resistor. I have already told you that power dissipated by the resistor can be written as I square into R. That means resistor will lost the power as a terms as a I square into R. Okay. And when you know about the voltage across the, you can say, particular instrument, then it will reduce the power V square by R. Okay. So when you know resistor, when you know current, then you can use I square R to finding the power. And when you know potential across the resistor, then you will be right V square by R. And P is the general, you can use P equals to VI. So power loss by the, you can say, resistor. In case of I current is passing through the, you can say, resistor, it can be written as I square R, and that is also written as V square by R whenever voltage is given. Here are this formula which you have to apply. Cell EMF and terminal voltage. What is cell EMF and terminal? Terminal voltage mainly defines to you that whenever you have a particular single straight wire and batteries has connected in front of you, so whenever I current is passing through this wire and it is dropping due to electrical due to internal resistance of the battery, then voltage across the wire on that case will be equal to terminal voltage of the battery. It could be represented as E will equal to V equals to E minus IR. So V is what? V is the terminal voltage across the battery, and E is the EMF of the battery, and I is the current passing through this, and R is the resistance of the battery. Got it? So here is the basic diagram regarding to this. A cell maintains a potential difference between two terminals using a chemical energy EMF work done by the source per unit charge moved to positive to negative terminal open circuit. Okay, when circuit I flow from some energy is used against the internal resistors are of the cell. Okay, due to this internal resistance some energy has lost, and due to some potential has to be dropped. So due to current passing through the battery will also drop. So during this dropness of the current, and then whenever we are finding the voltage across the two terminal of the wire, that is called terminal voltage. Terminal voltage is the potential difference between the terminals less than E when discharging. Okay, and V equals to E minus IR. That is the terminal voltage formula. Let's talk about the internal resistance. Internal resistance is the own resistance of the battery, so that it can reduce some. It can also hold some potential of the battery, so that net energy transfer to the circuit will be decreased. It can also assume that internal resistance R is the offered by the electrolytes plus electrode to the of the cell, which I have already told you. Connecting an external electric as a series of the battery. Current when the passing through the battery will be E equals to E upon capital R plus small r. Terminal voltage will be E minus IR. Maximum current passing through the current will be when R equals to 0. I max equals to E by small r. R increases with the user's age of cell dead. Okay, so when cell having you can say period, when cell having age, you can say when cell becomes older after using, then internal resistance of the you can say cell will be increases. Okay, R can be measured using a potentiometer by IV experimental at different. Okay, so here are some practice problems which you have to solve by yourself. This is your homework. Cells in the series, which I have already defined to you, that whenever cells are having in the series and whenever you are moving like a single path, then whenever you are moving according to direction on which you are moving opposite polarity with the same cells, then you will be right E net will be according to your direction minus times of E1 minus E2 minus E3 and minus E4. And whenever you are moving from negative to positive terminal of the battery, then E net you will be right E1 plus E2 plus E3 like this. Okay, that is the simplest formula of cells in series and cells in combination. Cells in, you can say, parallel wise arrangement. So for parallel wise arrangement, you can be right 1 upon E net, you can be right as the E1 by R1, E1 by R1 plus E2 by R2 plus E3 by R3 and so on, divided by 1 upon R equivalent. That is your E net of the you can say particular cell whenever cells are arranged in the parallel wise combination. Got it? Let's talk about the Kirchhoff law. Kirchhoff law mainly refers to you that whenever you are finding a current in a particular branch, then you have to choose a particular loop. So according to loop, whenever you are traversing complete a loop and come back to the initial point, then according to Kirchhoff law, the voltage across every element inside the particular loop, that will be total sum will equals to 0. That is the Kirchhoff law statement. So according to this diagram, whenever I choosing this particular loop, then voltage across R1, voltage across this junction, voltage across E, voltage across this junction point A and point B, and voltage across this wire and voltage across this point D. So voltage across every point R1, A plus E plus VB plus R3 and voltage across D and come back to the R1. The net voltage due to all parameter will equal to 0. That is called the Kirchhoff law. Okay, so that is the Kirchhoff circuit law, which I have already explained you. And what about Kirchhoff current law? Kirchhoff current law mainly refers to you that this is also called Kirchhoff junction law. So Kirchhoff junction law mainly refers to the total incoming current. Total sum of incoming current will directly equal to total sum of outgoing current. That is the Kirchhoff law of junction rule, which is very simple thing. Let's say this I current I1 and I2 and I3 current are passing through incoming current, then outgoing current will again equal to I1 plus I2 plus I3. That will be equal to outgoing current I4 plus I5 plus I6. That means mainly Kirchhoff junction law mainly states to you that the total incoming current inside the circuit that will be equal to total outgoing current throughout the circuit. That is the Kirchhoff junction law. And Kirchhoff loop law, I have already explained you the total sum of every voltage across every element inside the complete loop will equals to always 0. So whenever you are moving along the direction of current, and if you feel a voltage comes in front of you, then you can be right voltage across the resistor will be minus times of IR. And whenever you are moving opposite direction of the current is passing to the left to right, and you are moving from right to left, and if you feel a resistor has come in front of you, then you will write positive value of resistor. So it totally depends upon your path on which direction you can consider to find in the voltage across every parameter. Same case in case if you are moving from the battery, Then negative to positive terminal, whenever you are moving, then you will write positive value of the battery's potential. But in case of opposite case, whenever you are moving from positive terminal to negative terminal inside the battery, then you will be write negative value of battery's potential. So after doing this kinds of thing for a particular inside complete loop, then you will see that the voltage across every parameter inside the complete loop will be equal to 0. That is the application of, that is the rule of Kirchhoff loop law, which you have to understand. And always remember, you have to understand behind the sign convention while you are solving the numerical. Okay. So these are steps which I have already explained to you. Whenever you are solving the numerical, you just apply this and you can solve every problem. Let's talk about the Wheatstone bridge. Wheatstone bridge mainly refers to the relation between this one two resistor ratio. If this two left hand side resistor ratio will becomes equal to right hand side resistor ratio, then middle branch will not getting any current. That is the concept of Wheatstone bridge. So if this resistor having resistance R1, this resistor having resistance R2, if this resistor having resistance R3, this resistor having R4. So R1 by R2 if equal to R3 by R4, then we can see that at the middle branch of the galvanometer so will not show any deflection. That's why no current will be passing through this middle wire. So this is called Wheatstone bridge condition, and this is called Wheatstone bridge phenomena of a particular circuit. Understood by everyone? Okay. Now condition by the balance, I have already told you that is a Wheatstone bridge phenomena, which is you can find, which will be helpful to you can find easily unknown resistance in the given condition of the Wheatstone bridge. Okay. So here are some basic questions regarding to this upcoming theory. I think it could be homework for yours, so that you can find your answer. So here is a perfect summary regarding to entire chapter. You just consider it like this before going to the exam, and after that you can solve questions regarding to current electricity. Got it? So here's the completion of the current electricity chapter. If you have any doubt, here you can ask me. After that, we can continue with our next topic, which is magnetic effect of current, and as well as you can say optics we can discuss. So any doubt? Any doubt? Okay. So if nobody have any doubt, he and she kindly revise this PDF, and also remember thing which I have already explained in front of you. And we are continuing with our next chapter, which is magnetic effect of current, which is I think I should open a PDF. Which PDF is showing to me? Okay, this is also electromagnetic induction. Okay, so this is a moving charge and magnetism. Okay. I think someone asked me a question. Sir, there will be a what? Sir, there will be no deflection in the galvanometer at all. Yeah, in the Wheatstone bridge condition, when left hand side resistor ratio R1 by R2, if it is equal to R3 by R4, then galvanometer will not show any deflection in the Wheatstone bridge. Okay. So this is the Wheatstone bridge formula. Because why? Because voltage across the galvanometer will directly equals to the voltage across the galvanometer will become same. If voltage across the terminal becomes same, then we can say that no current will be passing through the galvanometer. Okay, sir, it is shows deflection. It is not equal, right? Huh? What are you saying? Okay, sir, it shows deflection. Why it shows deflection? Deflection will be show on that case when ratio will not be equal at left hand side to right hand side. Okay. If R1 by R2 will not equal to R3 by R4, then we can say that it will show deflection. Okay. Okay, let's talk about our next topic, which is, wait a minute. Okay. So let's discuss about our next topic, which is optics. And firstly, we will discuss about the ray optics. So mainly, light have two nature. First one is ray nature. Second one is wave nature. With the help of ray nature, we can understand about the reflection, diffraction, or you can say reflection. This concept we can understand with the help of ray nature of the light. But if I talk about the wave nature of the light, then we can understand about the, you can say, interference of the light and slit intensity of the light. That concept we can understand with the help of wave nature of light. So mainly, our physicist mainly says to you that light is not a ray form, light is not a wave form. Light is the electromagnetic wave, in which electric field and magnetic field both are propagating with the you can say perpendicular to each other. And the speed of this light, which means it is 3 into 10⁻⁸ 3 into 10⁸ meter per second. That means 3 lakh kilometer per second. the light speed, and this is the speed is equivalent to the electromagnetic wave speed. Okay, so this kind of thing I have already explained you. The wavelength of the light is given as 400 nanometer to 750 nanometer in the visible band. Okay, speed of the light I have already given nearest to the 3 to 10 to the power 8 meter per second. Okay, and ray I have already told you. So wave nature of the light. Firstly, we will discuss about the ray nature of the light. So firstly, what is the reflection? Reflection of the light is, you can assume that whenever any light passing through one particular medium and strikes to the another interface of the second medium and again come back to the initial medium, that phenomena is called reflection of the light. Okay, so this kinds of reflection can be done with any kinds of object. For example, if we have a spherical mirror, then reflection of the light can be shown as, let's say, if a light is passing through the infinite source, then this is the concave mirror. So every light will be passing through the single fixed point, that is called the focus point. Okay, so this is the pole of the, you can say, mirror. This is the focal point. The distance between the this is the focal point, and this is the for example, this is the center of curvature. This is the focus point. So when any parallel light passing strike to the, you can say, spherical mirror, it will comes out to the, you can say, focal point. So this focal point, the distance between focal point to, you can say, pole of the, you can say, concave mirror, that is called focal distance, and the distance between the radius of curvature to the pole, that is called radius of curvature. Okay, that is its value is capital R. And we always know that for a, you can say, larger concave mirror, R will directly equals to 2 times of F, but not always. It is for larger mirrors. Okay, so focal length we can be considered as, if R equals to 2F, then F will equal to R by 2. So this is your focal length formula whenever you have a radius of curvature is given. So pole is what? Pole is the geometrical center of the mirror, which I have already explained to you. Center of curvature, that is the center of curvature, center of the sphere of which the mirror is a part. Principal axis, which is the horizontal axis on which pole, radius of curvature, and focus are lying. So focus is what? When any parallel light beam are strikes to the, you can say, concave mirror and concentric with the particular point, that is called focus point. Focal length I have already explained you, and relation between focal length and radius of curvature I have already explained you. Laws of reflection I have already laws of reflection and sign convention. Sign convention, you can just assume that whenever let's say this is the light source. So whenever every distance like from light to from source to from, let's say, every distance from mirror to source, and you can say image distance, always every distance you will measure from the pole. Okay, so first rule is that every distance will be measured from the pole. Second thing, light source emits their lights, so that after, you can say, coinciding of their light, image will be formed. Okay, so every light is passing through the, you can say, source. So whenever you are measuring distance from opposite direction of the light, opposite direction of the light, then you will be measure their distance as a negative. Okay, and whenever you are every distance measure in the direction of the light, let's say light direction is like this, then you can see that you are measuring image distance. Then image distance you will consider as a positive. Got it? So these two kinds of things you have to understand whenever you are writing the distance of the source and image. So these are the sign convention rule which I have already explained it. So for concave mirror, focal length will be negative. Okay, and for convex mirror, focal length will be positive. Got it? So these two kinds of things you have to understand whenever you are doing numerical regarding to reflection from the plane mirror, from the spherical mirror. And another thing which I have already explained you, about the reflection phenomena. So in the reflection phenomena, you can you know that whenever any light passing through the particular medium and strike to the another medium's layer and come back to the initial medium, then the angle made by the normal from the light, that is always equal to angle away from the normal. That means angle of incident will always equal to angle of reflection. So that is called the law of reflection. And second law of reflection mainly states to you, incident ray and reflected ray and you can say normal, all are present in the same plane. So these kinds of things you have to understand. Okay, so this sign convention I have already explained you. Here is the simple formula which you have to know. A ray of light incident on a plane mirror and angle 30 degrees, the angle between incident ray and the reflected ray will be. This is the question like this. So incident angle is 30 degrees. So you have to find firstly reflected angle. Okay. So question is asking about the angle between the incident ray and reflected ray. This is the angle. This is the angle between incident ray and reflected angle. So according to law of reflection, R is again 30 degree. And angle between incident ray and reflected ray will be 30 plus 30, that is 60. So option B is the correct answer. Got it? And here is again formula. If a mirror rotates 10 degrees, then reflected ray will be rotates. This is the again simple thing is that when mirror rotates 10 degrees, reflected ray will again rotates with the 10 degree. That is the simple approach. Let's talk about the mirror formula. Mirror formula can be derived for, you can say, has derived for the, you can say, spherical mirrors. So mirror formula can be written as 1 upon V equals to 1 upon F equals to 1 upon V plus 1 upon U. U is what? U is the distance of source from pole. Oh, okay. And this U distance will be written according to my sign convention rule. Okay. And V is what? V is the distance of image from pole. Okay. And F is the focal length. So these three kinds of things you have to understood whenever you are writing mirror formula. Similar kinds of formula when we are getting for the lens, by which we can write 1 upon F equals to 1 upon B minus 1 upon U. These similar kinds of result you can be applied for the lens also, but just changing the sign only. Okay. So these kinds of things you have to understood. So this mirror formula I have already explained you. Sign convention you have to write according to your my rule. Okay. And magnification. What is magnification? Magnification mainly refers to that how much it is the comparison between height of object and height of image. How much height? What is the height comparison of image with respect to original source? So magnification can be written as h of image upon h of source. Okay, and it can be referred as for a mirror. For a mirror, we can be write magnification formula is minus b by u. So it is the simplest, you can say, it is the simplest magnification can be used as a comparison between image height and you can say source height. Okay. So here are some basic way diagram of convex and concave mirror, which I have already explained you. It is the question which you have to solve by yourself. It is again question by it is your SW. Just apply my rules, which I have already explained you, and follow the formula and solve the question. Let's say one more question. For a mirror, if U equals to minus 30 degree, F equals to minus 15 degree, image distance V is. So U and F already given with the sign. So you have to apply 1 upon F will equals to 1 upon V plus 1 upon U. So you have to find 1 upon V, that will be 1 upon F minus 1 upon U. So 1 upon V you will get minus 1 upon 15. And again minus is already given, and you have given minus 1 upon 30. So you will be right. 30 will be LCM and minus 2, and that is minus plus, that will be plus 1. So you will get F equals to minus 30 degree minus 30 centimeter. It is the V. V is the location of image, that will equal to minus 30 centimeter. That is your answer. Got it? So you have to solve your answer according to this. That is again your HW. Try your by yourself. Let's talk about the reflection. So reflection I have already explained you. Reflection by the plane mirror I have reflection by the spherical mirror I have already explained. Let's talk about the reflection. What is reflection? Reflection is what you can say whenever any light passing through two mediums, and due to you can say changing its speeds, whenever light passing through a particular interspace, and sometimes some parts of the light will passing throughout the second medium. So during the motion of the light to come inside the second medium, medium 1 and medium 2 lights having different velocity. Because of changing of this velocity phenomena in the medium 2, light slightly bent toward the normal, and sometimes you can say outward the normal. This phenomena is called, you can say, refraction. Overall, you just imagine it's like when light passing through the two different medium, okay, and during, because of this different, because of their different you can say refractive indexes, light slightly bends toward the normal and away from the normal. This phenomena is called diffraction. Let's talk about the Snell's law. Snell's law is what? Firstly, before the moving to the Snell's law, let's understand about the refractive index. So refractive index you can consider as a medium 1 is mu1 and medium 2 is a mu2. So refractive index mainly refers to that it is the ratio of the light in the particular ratio of the light in the vacuum divided by ratio of the velocity of the light in a particular medium. So refractive index mainly refers to either mu equals to ratio of light in the ratio of lights in the vacuum upon in a particular medium. In the vacuum, velocity of light, let's say c, and the medium velocity of light, let's say b. C is the 10 to the power 3 into 10 to the power 8 meter per second. That is the velocity of light in the vacuum, and b is the velocity of light in a particular medium. So if the both ratio, you can see that is the refractive index. So this in this medium, light has velocity v1, and in this medium, light has velocity v2. So mu1 can be written as c by v1, and mu2 can be written as c by v2. So these are the two things which we can be understand to whenever you are applying the Snell's law. So Snell's law mainly defines to you that it is the relation between the incident angle and you can say refractive angle. Okay. So these angles are made up from the normal. So you can write as according to Snell's law, mu1 sin I will equals to mu2 sin I. These are the Snell's law. So with the help of this Snell's law, you can easily find out the refractive angle, how much light will be bent whenever it is traveling from one medium to other medium. So these kinds of things you can understand whenever you are applying the Snell's law. That is the refraction formula. Let's talk about the real height and apparent depth. Real depth and apparent depth in the everyday reflection. For example, whenever you have a particular container has filled with a particular water, and if you immerse an object inside the you can say container, then you can see that the height or your depth which are you are seeing in the container in the container of the particular object, that was slightly upper from the actual height. So what is the real difference between it? The upper height which you see by yourself, that was your apparent depth, that was your not actual depth. And this phenomena has to be done by your refraction phenomena of the light. So all of these kinds of things, whenever you are looking to the particular object inside the, you can say, water, so their height and their position may not be to be real. Okay, so that kinds of phenomena has called apparent weight, apparent depth, or the actual depth which object is really present inside the particular liquid, that is called real depth. So what is the relation between the actual depth and real depth? So apparent depth we can define with the help of simplest you can say formula. Real depth upon mu. Mu is what? Refractive index of the medium. Refractive index of the medium where object is present. Got it? So this is a relation between the apparent depth upon real depth. Got it? It can be different as apparent depth is equal to real depth upon n. N is the refractive index. Let's talk about the total internal reflection. Total internal reflection mainly defines to that what is the relation between angle of incident between angle of refraction. For example, whenever light passing through the, you can say, particular medium to the another medium, then it slightly bent to the away from the normal and towards the normal. This away from the normal mainly showcasing to you that when mu2 is when mu2 is greater than mu1, then on that time light will be passing through, or you can say this kinds of condition you can assume as a density form also. When light is passing through the lower density to higher density, then it will be moved towards the normal. When a light travels to the lower density medium to the higher density medium to the lower density medium, then it will be away from the you can say normal. Look at this example. So after changing the incident angles, light refracting angles is also changing. Okay, so that is the incident angle and this is again incident angle 2, and this is again incident angle 3. So after changing the incident angle, light's refractive angle is also changing, and at a particular value of incident angle such that refractive angle is directly coincide to the surface. Also that, and also you can see that the incident the perfect value of incident angle such that refracting angle making a 90-degree angle with the normal. So that kinds of incident, it is called total internal reflection. So this angle is called, this incident angle value is called, you can say, critical angle. So how can you find critical angle? Critical angle you can find with the help of Snell's law. Let's say this medium have a refractive index mu1. This particular medium have a refractive index mu2. So apply Snell's law. So you will write mu1 sin I, and sin I on that case will be critical angle, that is theta c. That will be equals to mu2 sin r. Sin r will becomes 90 degree because refractive angle becomes 90 degree with the normal. So you will be right like 1. So theta c you will be written as mu2 by mu1 as a sine inverse. So that is the critical angle, so that you can easily find. Just apply the simplest Snell's law and identify what is the angle made by the, you can say, refractive ray from the normal, so that you can find theta c easily. So after increasing the angle, incident angle greater than theta c, then you can see that total light passing through, total light will be passing through the, again, to its initial medium. So that is called refractive total internal refraction. Okay. So these are the phenomena which you have to know. This kinds of thing will be really helpful whenever you are transmitting a data over the over by the light. How? Let's talk about the optical fiber. Optical fiber is the basic application of the total internal reflection, because firstly, it is the very useful to transmit the data in the very high speed. How? Because light has a very faster speed inside the universe. So if any data transfer with the speed according to light, then it is very, it can be very easy. So we are making an optical fiber, okay, in which we are producing our data in such type of angle with a particular greater than critical angle. That's why light can be travel with the, you can say, by total internal reflection from the, you can say, throughout the wire. So no light, no data will be moved from outer from the optical fiber. That kinds of phenomena which is very useful in the optical fiber. So this optical fiber, you can say, example mainly used over, you can say, total internal reflection phenomena. Got it? So let's talk about the reflection at a spherical surface. So whenever any spherical surface, and let us say this is point C, and an object is moving in front of you. So reflection through the spherical surface mainly refers to you. It will give you the relation of the distance between images to the you can say source distance from the pole. So it can be found with the help of direct formula, which is mu2 by v minus mu1 by u equals to mu2 minus mu1 upon r. What is this? Mu2 is you can say refractive index of the light ray on which it will be passing through the second medium. So second medium refractive index on which light passing through the second medium, and mu1 is the refractive index of such medium where from light is coming. So that is mu1, and after that again you are writing mu2 minus mu1 upon r. R is what? R is the radius of curvature of this spherical surface. Okay, so I am writing separately. Mu2 is the light refractive index in which light will go. Okay, and mu1 refractive index of the medium from light comes. So these are mu1 and mu2. Put this example, put this formula in it, and you can find the answer. Let's talk about the lens maker formula. Lens maker formula is also very simple. Lens are the such type of you can say transparent devices which are used to you can say which are used to our day-to-day life in spectacles and other kinds of things. Okay, so it have some basic formula regarding to lens, so that it can easily identify you how can you find focal length according to their radius of curvature, and you can say some refractive index. Okay, so 1 upon f we can be written as a lens mu lens upon mu surrounding minus 1 and 1 upon R1 minus 1 upon R2. This is your exact formula, so that in kinds of any medium, any two medium, in between any two medium, you can find focal length of a length. So mu s is what? Mu s is refractive index of the light from its come. Okay, it is the initial point of the initial medium of the light where from the light comes, and mu l is the lens refractive index. Lens refractive index. So mu l is what? Again, you can also assume that refracting index of such medium where light will go. Okay, so these are lens maker formula of this particular diagram. 1 upon f equals to mu l by mu s minus 1 multiplied by 1 upon r1 minus 1 upon r2. Thin lens formula and ray diagram I have already explained to you. This is the similar kinds of mirror formula. Just apply sign convention according to your situation. But one thing which you need to understand, whenever object placed in the, you can say like this, then lens will be, you can say, converts their light at the front of focus. So for the, you can say, convex lens, focal length you can be considered as a positive, and you can say for concave lens focal length you can be considered as a negative. Okay, so these two kinds of things you have to understand whenever you are solving some particular type of numerical. So here is the homework which you have to done. There is a total depth that depends upon your formula. Okay, these are all your homework which you have to done by yourself. Let's talk about the power. What is the power? Power is, you can say, reciprocal of the focal length of the any lens, or you can say any mirror. That is called the power. The power unit is diopter. Okay, power unit is diopter, and this is given as like this. So if we have so many lenses, the net power, let's say if you have a lens like f1, f2 and f3, then what is the power due to all lenses? So you will write p net will equal to 1 upon f1 plus 1 upon f2 plus 1 upon f3. Got it? And f1 upon f1, 1 upon f2, 1 upon f3, that comes to p net will equal to p1 plus p2 plus p3. That will come to p up to n. So this is the p net due to you can say all lenses. Got it? But remember, power mainly depends upon types of lens. If lens is concave, then their focal length will be negative, then power will be negative. If lens is convex, which means their focal length will be positive and power will be positive. So you have to remember while you are solving the numerical, you have to remember about their focal length sign convention of different lenses. Okay, so here is one more numerical regarding to power you have to do by yourself. Let's talk about the refraction through the prism. Prisma is the, you can say, simple triangular devices which is made up from the transparent glass, on which whenever we are passing the light from this, and it will directly, you can say, emit from the other end. These types of phenomena, while we are doing some with the help of prisma, that is called refraction through the prism. And here are some basic things which you have to understand. A is what? A is the prism angle which is given in front of you, and I is the incident angle which is going. I is the incident angle like this. And let's say this I am moving the normal like this. Okay. So this is the angle of emission when light go through the prism. That is angle. This angle is R1, and this angle is also R2, which I have already given you. So these are relations which I gave you in front of you. Okay. So this is also these are angles which I gave you in front of you. This is very smaller diagram. I can't show you separately. So main thing is that at the geometry, prism angle given as R1 plus R2. Theta is what? Theta is the angle deviation. Angle deviation for what? So final reflected ray from initial incident ray, the total angle made up from between them, that is called delta, and whose value is directly written as with the formula, because if I derive this formula in front of yours, it could be not understandable for you within the smaller time. Okay, so just remember this basic, you can say, formula regarding to this. So these are the refraction of the, you can say, refraction through the prism. Got it? Okay, this again, dispersion of a white light. What is dispersion of a white light? You can assume that white having 7 colors like Vibgyor, and whenever you are moving from left to right, then lambda will be increased. and lambda will, if lambda is increased, frequency will be decreases. So that phenomena is the light phenomena which we can assume. So what is the dispersion of light? Diffraction of the light, you can assume that whenever light is passing through the particular prism, then according to their different wavelength of the light, light spread out this O have 7 colors into the sky. So these 7 colors are called Vibgyor. Okay. So according to the statement, red has higher wavelength and violet has minimum wavelength. So refractive index depend on the wavelength. Okay. Refractive index totally depends on the wavelength, because wavelength is depending upon the speed of the light. V equals to speed of the particular color of light. Let's say V of red will equal to F times of lambda of red. Okay. So whenever, if speed is depending upon the wavelength, then refractive index is also depending upon the, you can say, velocity also, C upon V red. So every light color having different refractive index, and due to this differentiation of different refractive index, light will be spread out into their own 7 colors. And these 7 colors as a understandable by Vibgyor: red, blue, green, violet, indigo, orange, and yellow. Okay. So this kind of thing I have already explained you. And what is angular dispersion? Delta V minus delta R. Okay. And rainbow produce dispersion at TR inside. Okay. So this kind of thing you have to understand whenever you are solving prism related problem. Let's talk about the optical instrument. Optical instrument is the such kinds of devices which are you are study whenever particular small particles by the looking someone on which normal eye cannot visible to them. So optical instrument mainly used to see such kinds of objects where normal eyes cannot do same kinds of tasks. So we can have some different example like this. Optical instrument we can consider as microscope, telescope. These kinds of things are useful as an optical instrument. Okay. So optical instrument are uses lens and mirrors to assist human vision. Okay. Example covered here: the human eye, simple microscope, compound microscope, astronomical microscope. These are types of optical instrument which are we will study in the next thing. Okay. Let's talk about the human eye. Human eye, it is the biological process, or you can say it is your natural camera of our body. For example, it have few parts like this. This is pupil, this is iris, this is lens, this is crystalline. So what every part have different. You can say every parts having different work function. What does pupil do? Pupil mainly do, it will ensure that how much light will be passing through from our eye. So if maximum eye come to our eye lenses, then our eye lenses may be damaged. So at a fixed intensity of light can be passing through the pupil, can be from the, you can say, cornea, so that pupil mainly maintain this types of amount of energy, so that eye can be safe. So pupil, whenever you are moving from the higher lighting area, then you can see that suddenly your pupil changes its side to the small, and whenever you are moving in the dark side, then your pupil size will be increases. So this pupil size mainly refers to that it could be increase your size length on the basis of your visibility. If you are moving a such type of area where visibility is required and low light is coming, then it will increase their size so that more light will come from the pupil, and many kinds of things you can be see. And if you are moving for the lighter area in which more light has produced, then on that time unnecessary light will not be passing through the, you can say, pupil. So on that time pupil changes its size to the lower. So this is the own purpose of pupil. Lens has also used to forming images. And what is retina do? Retina is connected with your optical nerve. Optical nerve will sending the message to the brain of the image, and brain will, you can say brain will resize your image so that you can easily identify what is given in front of you. So these are all different functionality of every parts of eye, which is very useful to visible everything in front of your surroundings. Okay. So cornea, it is aqueous humor. Crystalline lens act as a signal covering system. Okay. Image formed by the retina always real, inverted, and the retina. Okay. Retina gets image information. It is always real, inverted, that kinds of information retina got, and this information will be sent to the brain, and brain will give you the right configuration regarding to you, so that you can easily see a particular object. Ciliary muscles changes the lens curvature, focal length. Ciliary muscles are mainly used to whenever you are looking to your, you can say, too far object. Then on that time lens and on that time we need more focal length. And how more focal length we will need? Ciliary muscles just stretch your eye. After stretching the eye, the radius of curvature has increases. If radius of curvature increases, that means focal length will also increase. If focal length increases, that means parallel light ray will directly focus to the retina and image can be formed easily. And this kinds of thing is happening so many times. This kinds of thing happening so much. So every time ciliary muscles stretch, and every time ciliary muscles stretch their focal length, and again regain to its original configuration. This kinds of things happen in many times. So whenever you are always looking your phone, whenever you are always using your eye to visible every kind of thing in darkness, and you can say at in the daytime, that kinds of thing are also affected your, you can say, eye. Why? Because always your ciliary muscles, pupil, iris, crystalline, retina always are working in front of your for your own purpose. So main thing is that due to this misbehave with the eye, and you can say after more using of ciliary muscles, you are getting some dishes, which we will study in the next slide, which is firstly is myopia. Whenever ciliary muscles lose their tendency to stretchness, and you can say begins to original shape, we are facing 2 to 3 types of problem on which we can't see any object clearly. Okay, and we have some safest distance to see a particular object, that is 25 centimeter. If 25 centimeter, if any object is far from you, that means it is good for your eye safety. Got it? And far point of the normal eye, it will be infinity, which means our eye can see object up to infinity distance. It totally depends upon how object size matter. Okay, so if object has so bigger size, then our eye can be see this bigger size object up to infinity distance. Okay, let's talk about the myopia. It is also called as nearsightedness. What is nearsightedness? Nearsightedness, the distance object appear blurred, near object are seen clearly. That means if anyone have a myopia, that means at the far distance object, he and she can't see clearly, but a nearest object he and she can see visibly. Why? Because due to this ciliary muscles more working of ciliary muscle, it will lose their tendency to stretchness and normal configuration tendency. So because of this reason, our focal length will not be transferred according to their distance. For an example, look at this statement. So if a particular object is too far from this, then their image is from just in front of lens, but our retina present at like this, so no light is passing through that point, so that's why the image will not made clear. Okay, so that is the because of myopia issue. And after resolving this, we are using a simply concave lens, so that it can directly convert parallel axis line into the particular distance, so that we can easily our retina will get easily information about the image, and our image will become clear. Got it? So that is the, you can say, myopia, which I have explained in front of you. So measure, we are using concave mirror, which have a concave lens, which I have already explained you, and the power formula of the, you can say, concave lens, I have already explained you that concave lens power can be write as a negative, because focal length is negative. Power you will be write 1 upon x. X is the x in meter, and x is the power, you can say, focal length of the, you can say, your concave lens. Okay, let's talk about the hypermetropia, ear sightedness. Hypermetropia, it is the opposite result of, you can say, myopia, in which near object can be seen clearly. Okay, appear object blurred, distant object are seen clearly. Okay, it was opposite nature of the, you can say, myopia. Distance object can see clearly, but nearest object we can't see clearly. So this kinds of problem it can be happen whenever you are always looking closest nearest distance to your eye, and after that your eye facing some, you can say, issue to clearing this image, and on that time eye you're facing some struggle to making a clear image inside your mind. So these types of struggling thing whenever you are doing in your day-to-day life, then you will face a hypermetropia problem, and in which problem you can see nearest object clearly, but far object you can't see blurry. Okay. Okay. Appeared distant object are you can see clearly, but nearest object you can't see blurred. You can't see clearly. So this disease name is, you can say, hypermetropia. Okay. Image of nearer object would be formed behind the retina, which means retina is present like this. Retina is present like this, but image has formed behind the retina. Okay, so because of this reason, our image we can't see very easily. Okay, cause eyeball too short, over focal length of the eye lens too large. Correction, using convex lens for suitable power lens, so that you can be remove this hypermetropia situation. Okay, here are some basic formula, basic question regarding to this. Kindly solve by yourself. It is your HW. Kindly solve by yourself. This is again your HW. This is also simple numerical. Okay. Let's talk about the different types of optical instrument. First, simple microscope, magnifying glass. Magnifying, everyone understood about the magnifying glass? Magnifying glass mainly used to see a magnificent object. Whenever you are looking a particular ant is too small according to your eye, but if you see by your magnifying glass, its size becomes larger. How is that possible? It is possible with the help of magnifying glass instrument. So what is magnifying glass? A single convex lens or small focal length. Object is placed between F and the lens. Virtual erect and magnified image. Magnifying power will be defined as a 1 plus D by F. That is the formula of the magnifying power. Magnifying power image at infinity relaxed eye will be given as m equals to D by F. Near point gives slightly higher magnification but is more thin for the eye. Okay. So this is the simplest formula regarding to magnification during the magnifying glass. So whenever you have a nearest point, then you can write magnification as a 1 plus D by F. And for infinity for magnification, you can write D by F. Let's talk about the compound microscope. Microscope mainly used to see microscopic images by your devices. Okay. Let's say if you want to look your cells, your bacteria inside on your body, that kinds of thing our normal eye cannot be see. So these kinds of thing we can be visible with the help of microscope. So how microscope will be help? Two convex lens objects, small close to object eyepiece, slightly near to the eye. Here's the diagram of microscope. Okay. So two convex lenses are separated with a separated distance. Objective form a real inverted magnified inverted image. Eyepiece act as a simple magnifier on this image, on this intermediate image. Tube length will equal to L. Distance between two second focus and the first focus as the eyepiece. Total magnification image M equals to L by. Here's the formula. Okay. M is nearly equals to L upon F naught multiplied by D upon F E. Okay, so this is the, you can say, microscope, which is also optical instrument. Here are some questions regarding to this, and after that, what chapter will we continue? After that, we can continue with real optics. Okay, let's talk about the third optical instrument. That is astronomical telescope. So, what is the main function of astronomical telescope? To view every distance object. Stars, planets, and moon. Objective large aperture plus large focal length, gather lots of light. Astronomical telescope mainly used to see an object from the space, from the earth. So these objects are very too far from the, you can say, earth. Okay. So how can we see these types of images? So firstly, we are using you can say convex lens, which will be centralized there. You can say light intensity at a particular point. Okay. And after that, we are using one more. After that, we are using one more. You can say one more convex lens, so that after centralizing, it will again spread out to the their light. So overall, our eye is visible in front of this. So these lights firstly convert into the second single point, and then after spreading with the second, you can say convex lens. After that, our light can be see this infinity coming light very easily. So this is what? This is your image light of your, you can say, any astronomical entity inside the space. And after that, after reaching the light inside your eye, then eye will make your image of this astronomical entity on your space and in the retina, and your brain will be helpful to identify what is this. Okay, so this kinds of thing will be used with the help of astronomical telescope. Okay, to vary distance, I have an eyepiece, very small focal length, act as a simple magnifier. In a normal adjustment, final image at infinity and relaxed eye. Magnifying power, it can be written as m equals to FO upon FE, and L equals to L equals to FO plus FE. Okay, and this is the homework question which you have to do by yourself. Okay, let's talk about the wave nature of light, and it have some points also. Okay, what is wave nature? Wave nature of light mainly refers to that some light phenomena which are surrounding occurring in front of yours. These types of phenomena mainly like interference, diffraction, and young double slit experiment. That type of experiment cannot be explained with the help of ray nature of the light, because ray nature of the light we can understand the, you can say, reflection, refraction, spherical reflection, that kind of thing we can understand. But wave particle phenomena we can't be understand with the help of ray nature of the light. So these kinds of things we are considering that we have to consider our light as a form of wave. Okay, so firstly let's talk about the few things. First is Huygens principle. What is Huygens principle? Huygens principle is talking about the wavefront energy travel perpendicular to the wavefront at the wave speed. So firstly let's talk about the wavefront. Wavefront is a such type of, you can say, interfaces on which light can be transferred just perpendicular to them. For example, if light is passing through the parallel, then wavefront will be perpendicular to each other. If light is passing through like this, then wavefront will be looks like this. So main thing is the wavefront is a such type of interface on which light passing through the wavefront will always perpendicular to them. Got it? And every particle which are oscillating inside the light, they are always oscillating perpendicular to the wavefront. Okay, energy travels perpendicular to the wavefront at the wave speed. Spherical wavefront from the point source, I have already explained you. If a point source I have, then wavefront will be spherical. Okay, so Huygens principle. Every point on wavefront is source of a secondary wavelets, and the new wavefront is a later time of envelope. Okay, here are this type of wavefront. Whenever these are the spherical wavefront on which we can say that this is the point source. That's why all lights ray are perpendicular to the wavefront. Okay, that is cylindrical wavefront, because when light is emitting like this, okay, like this, so all of these light particles are always perpendicular to the you can say this cylindrical wavefront. Plane wavefront, when light is passing through the plane direction, like this horizontal direction. That's why all light is always perpendicular to the plane wavefront. Got it? Now, refraction of the plane waves. Again, same thing. Snell's formula has derived with the help of, you can say, reflection of a plane wave by the Huygens principle. Okay, that is the important result which you have to understand. Result is very important. Derivation is not much more important. We can do derivation also in the A to E. If light travels the distance, given velocity, then we can see that time taken by the light is same. Then we can say that T will equals to D by V1. Again, same light passing through to B to C. Time is very A to B. Time is same. Okay. So time, again velocity will be D by V2. After finding D value with the help of this reflection and refraction index by applying some trigonometry, you will get sine mu1 sine n1 will equals to mu2 by sine r. Okay. Let's talk about the reflection of the plane waves. Again, this can be explained with the wave nature of the light. That is also the same thing. Angle I equals to angle R, and normal, your reflected ray, incident ray, all are arranged in the, you can say, same plane. Coherent and incoherent addition, that is a very important thing which you have to understand. So what is coherent and incoherent addition of waves? So superposition, resultant displacement wave is equal to sum of individual displacement coherent source, constant phase difference, sustained interference pattern. Coherent source, that was the, that such type of force which producing their light waves, and their light waves phase difference between them will be zero. And incoherent source, that sources in which phase difference between every sources are totally, you can say, different, not a constant. These are different. So these sources are called incoherent source. Coherent source means which have constant phase difference. Got it? Let's talk about if two coherent source reducing their waves like this, and these wave lights are meeting at a particular point P. And let's say first at a point P and point Q, I1 is the, you can say, intensity of first light, and I2 is the intensity of second light which was producing by Q. So net incident intensity at point Q you can be written as I1 plus I2 plus 2 under root I1 I2 cos phi. And phi is what? Phi is the phase difference between them. Okay. And second thing which I explained to you, what is the relation between phase difference between part difference? So part difference can be explained like that, delta x, which is part difference, which is written as 2 pi. Phi phase difference between two waves which have relation with the, you can say, part difference as delta phi will equal to 2 pi delta x upon lambda. So this is your relation between phase difference between path difference. Got it? And second thing which I giving you, intensity of the light is directly proportional to amplitude square. So if you want to find amplitude at point P, so you will be directly write amplitude at point P written as under root A1 square plus A2 square plus 2A1 A2 cos phi. So this is your amplitude of the resultant wave at point P. So which you have to understand while you are solving a particular question. Okay. Let's talk about the Young's double slit experiment. Young's double slit experiment directly explain the wave nature of the light. For example, you have two slits which have, you can say, which is separation between the slit are D, and the separation in the slit separation between them, it is very small, close to the, you can say, wavelength. Okay, so this is the you can say YDS experiment in which we are applying a screen, and it is the light source and light is producing from them. So if a light is producing from them in the different path like this, then this from this smaller thin slits, single light is made at the point P. Okay, and they could have different intensity light I1 and I2. So according to this phenomena, we have seen that whenever light meets at a particular point, light meets so many points like this. So we have seen this at a particular points, some light where light emits, some parts are, you can say, visible and some parts are darker. So this type of things which we have seen inside the screen, where some parts are darker and some parts are visible, these things are called, you can say, fringe. Okay, these fringes are called these things are called fringes. So visible fringes, we are telling like them, these are bright fringes. These are bright fringe. And the darker side where light is not visible to everyone, that is called dark fringes. And every fringes are arranged in a particular with a fixed separation. Every fringes are arranged with a fixed separation. And how dark fringe has made, how bright fringe has made, these kinds of things is totally depend upon their path difference between two lights. Okay, if path difference between two lights, it is integral multiple of the lambda, that means bright fringe will be occur. Bright fringe will occur. And if we are facing that, if delta x part difference is the odd multiple of 2n minus 1 lambda by 2, then we can see that we are facing, you can say, darker fringe. So at a point where dark fringe, we are seeing the part difference between two lights are odd multiple of lambda by 2. And the part where we are facing the, you can say, bright fringe, then on that time part difference will equal to n lambda. Got it? So that kinds of thing we have discussed. So that is a part difference phenomena. So via the simplest calculation, there is a very small diagram so that I can explain the simplest calculation. You just imagine that delta x we can define d sin theta, that will be equal to nearest to the y will equal to small d upon capital D. That is the part difference. When we have a, you can say, whenever we have a bright fringe, then location of bright fringe we can write as yn, and if the part difference is equals to n lambda, then we can find location of white fringe equals to yn equals to n lambda capital D by small d. That is your location of bright fringe. And if I talk about the location of darker fringe, then you will be right y darker will equals to 2n minus 1 lambda capital D by small d. So this is your location of bright fringe and dark fringe in the YDSE experiment. Got it? So these things which I have already give you, fringe where part difference having n lambda, then that we are getting bright fringe, and bright fringe we can face maximum intensity of the light. Okay, so this thing I have already explained you that delta x equals n lambda for bright fringe, because we have phase maxima, so we are getting delta x equals n lambda for minima. We are facing, you can say, dark fringe. So you can also reuse 2n plus 1 lambda by 2, but on this case we are using n equals to 0, 1, 2, 3 for this case. But if I talk about my case which I have written in front of you, you can also use n equals to 0, 1, 2, 3. Okay, so 2n minus 1 lambda by 2. Okay, that is the part difference whenever you are finding the fringe location. For the darker one different, for brighter one is also different. Fringe width is also represented as lambda capital D by small d. And if I talk about angular width which is written as omega, that can be written as beta by capital D. That is also called you can say angular width, that is called lambda upon small d. Okay, that is also very important for your examination purpose. So this is also again your question. You have to do fringe width is given by lambda capital D by small d. That is your answer. Okay, if the distance between the slits is double, fringe width become distance between fringe width. It is represented as a capital small d, and capital D is the distance of the screen from the fringes. Okay, so fringe width as a represent as beta equals to lambda capital D by small d. If fringe width becomes double, that means if slit distance becomes double, then fringe width becomes half. So which one option is correct? Half means decreases. So option B is the correct answer. Okay. Consecutive interference occurs when the part difference is, I have already explained you, part difference is n lambda. Okay. Concentric interference means maximum whenever you are finding. Okay. And destructive interference means whenever you are getting minima. Okay. Okay, let's talk about the diffraction of the light. Diffraction of the light, you can just assume that whenever light passing through the smaller particle, then at the smaller corner, this smaller corner, it slightly bends to the original path. This type of phenomena is called diffraction. Okay, so it is also given bending of waves around the edges of the spreading into the geometrical shadow, visible only when the obstacles is nearly close to the wavelength of the light. Okay, and single slit with monochromatic lambda, a broad bright central maxima, and alternate minima and much weaker secondary maxima on both sides. Minima occur sin theta when equals to n lambda, and angular width can be given as a 2 lambda by a. Okay, so these kinds of thing of you can apply for a diffraction. For the diffraction case, minima you will find then delta x equals to n lambda. Okay. So a sin theta you will apply n lambda for minimum. For YDSE, n lambda refers for the maximum, but at diffraction, n lambda refers for the minimum. Got it? So here are some questions which I explained in front of you. What is the difference between diffraction and you can say interference? Both are wave phenomena involving superposition interface between wavefront from two coherent source equally spaced, equally bright fringe. These are the difference between the you can say diffraction and interface. Superposition secondary wavelets from one wavefront central maxima at widest and brightest side minima is quickly. That has the opposite result, which I already explained to you. At the central side, you will feel maximum, but in the diffraction case, you will feel central minimum. Okay. In YDSE finite width slit, both effects are present interference fringe under the deflection of envelope. Feynman, there is no quantitative difference principle, only indifference in the usage. These are the few things regarding to interface and difference and you can say differences. Okay, you just apply. Okay, let's talk about the Maynard's law. Maynard's law is what? Maynard's law is the such type of law on which you can find the intensity of a light when it is passing through a particular plane of symmetry. For example, light is a form of electromagnetic wave, such that we can see that whenever light electromagnetic wave, that means magnetic field is always perpendicular to the electric field. So magnetic field, let's like this example. It is the you can say 3D diagram. So magnetic field, it's look like this along y-axis. Okay. So electric field always perpendicular to the magnetic field. Okay, like this. So this is the light motion as electromagnetic form. Okay. So this is the B vector, this is E vector, and electric field is along z-axis and magnetic field is along y-axis, and x direction axis along the direction of the motion of the light. So whenever you are applying a plane, which is totally horizontal, so we can say that electric field can be passed, but magnetic field will be cancelled. So overall, one component of the light has reduced. If one component of light has reduced, that means intensity of the light has reduced. So this Maynard's law mainly represent to you that resulting intensity from the after passing through the polar plane of symmetry, you will be get resultant relation between the older intensity. So after resulting intensity from the passing through the polarization, you will get I naught cos square theta. This is the relation between older intensity to new intensity. So if I write cos theta is what? It is the you can say angle between your plane of symmetry it is the angle between your plane of propagation and you can say plane of surface on which you can say light will be passed. So if direction of electric field and you can say plane of propagation having same angle like 0 degree, then you can see that I will equals to I naught cos square 0 degree. That means I equals to I naught. No, every light can be passed perfectly. So let's talk about this thing with the help of this formula. If a polarized light intensity I naught passing through the you can say analyzer whose axis angle theta from polarization direction, then I resultant intensity will equal to I naught times of cos square theta. That is called Maynard's law. Brewster angle of incidence at which reflected light is completely polarized, that is called Brewster angle. So at incident light, the reflected and reflected rays are perpendicular to each other. Brewster relation tan I beta will equals to n, and polarization proves the traversal light of light uses polarized sunglasses, LCD display in camera. So that is a relation which you have to know whenever you are studying about the Maynard's law. Okay. So let us say an example which is shown to a polarized beam passing through analyzer transmit intensity I naught by 4, possible angle theta will be. So transmission light is already given I naught by 4, and initial intensity I have already given I naught, multiply by cos square theta. Got it? I naught to I naught will be cancelled out. Cos square theta will equal to 1 by 4. Cos theta will be 1 by 2. So angle will be 60 degree. This is your answer. Got it? So this is your first chapter which we have covered, optics, which is wave optics and ray optics. Let's talk about the moving charges and magnetism. So that is again is a part of current electricity, which I have already told you that when charge is on rest, then it will produce electric field. When charge is on motion, then it will produce magnetic field. When charge in accelerated motion, then it will produce electromagnetic waves. So moving charge in magnetism mainly refers to that how charge will behave whenever it is moving inside the current conducting can. How much electric field it will produce. How much you can say how much what is the behaving of the magnetic charge whenever it is producing in the particular magnetic field. That kind of something we will discuss in the moving charge and magnetism. So F factor we can be write as F factor whenever any charge particle move in a particular magnetic field, then it will feel some force. This force is called magnetic force, and this force can be assumed as a Q times of B vector plus B vector, and B vector plus B vector can be written as F equals to Q V B multiplied by sine theta. And theta is what? Theta is angle between B and B. Got it? B and B. So can I say in the according to this situation, if angle between B and B is 0 or 180, force on the charged particle will be 0. That means it directly refers to that this force can be 0 whenever charged particle having a parallel direction with the magnetic field. So on that time, charged particle will not lose its velocity, but due to direction, it will also feel 0 force. But when a charged particle having some angle theta with the magnetic field of the motion, then you can see that it will feel some force, so that particle changes its trajectory, and this trajectory will be changed depending upon the angle, how much angle it made its velocity from the, you can say, magnetic field. So on the basis of this thing, we can say that charge particle trajectory will be changed. Got it? So that is the force applied on the charged particle whenever it is moving velocity v in the particular magnetic field. So we can say that F we can be write Q VB sine theta. And what is the direction of this force? You can be find direction of the force with the help of right hand thumb rule. So curl your finger, apply firstly, move your finger according to velocity of the charged particle and curl your finger towards the direction of magnetic field. Then thumb will point out to the direction of the force. So that kinds of thing we can discuss whenever any charged particle move in a particular magnetic field. So electric current creates magnetic field around the current. I have already told you. Magnetic field exert force on the charged particle and current carrying wire, and also on the charged particle also. Those forces explain circular and helical motion of the cyclotron and velocity of selector. The same ideas lead to solenoid, toroid, and magnetic dipoles and galvanometer. That kind of thing we will discuss in the earlier next chapter. So Oersted experiment to field direction. So mainly Oersted mainly seen that any current conducting wire having magnetic property. Having magnetic property means it creates this magnetic field surrounded to wire. If it is created magnetic field to the surrounding, that means it will create magnetic field. And if it is create magnetic field, that means its magnetic field direction we should be considered. So their magnetic field direction we can be considered as a right hand thumb rule, and this magnetic field magnitude we can be find with the help of Biot-Savart law. So magnetic field at a point B due to current conducting wire we can be considered as a mu naught I dl sine theta upon 4 pi r square. R is the distance between the point P from the wire. I is the current passing through this wire. DL is the smaller element on which, on the basis of, you can say, magnetic field has produced. Okay. So with the help of Biot-Savart law, we can find the magnetic field intensity at a point P due to current conducting wire. And second thing, how can we find direction? Direction you can find with the help of right hand thumb rule. Just you can say, just apply your thumb in the direction of current and curl your finger on that point where you want to find direction of the magnetic field. Okay. For an example, look at this example which I am showing in front of you. What is happen? Okay, look at this diagram. Current is passing through this wire in the, you can say, left to right. So move your thumb according to left to right and curl your finger where you want to find a direction. So if I want to find a direction upward the wire, then I can see that my finger comes to the outward the plane. That means magnetic field at this point will be outward. Sorry, outward. That means I will use like this. And if I curl my finger at the downward side, then I can say that magnetic field direction will be in the downward direction. So that kind of thing we can discuss upon when magnetic field produced by the electric current. Okay. So force on the magnetic charge, I have already explained you how can we find and how can we calculate. So if in the current case, force due to magnetic current, force due to current on the, you can say, due to wire will be IBL sin theta, and force due to magnetic charge, in this case, we will write Q will be sin theta. Got it? Let's talk about circular and helical motion of a uniform charge particle. So whenever magnetic field and velocity having perpendicular to each other, then on that time the particle's motion is along the circular path. Okay, and if magnetic field and particles motion is in are perpendicular to each other, then due to this issue, force is always acting to the centripetal, always towards the center. So according to this, QVB will be act as a centripetal force that will be equal to mv square by circular path radius. So by the using of this expression, you will get R will be mv by QV. This is your radius of the circular path. Similar kinds of time period you can also be find during the complete time period of motion. Whenever particle reach to its original position, total distance covered by the particle is 2 pi r, and total velocity will be v. That is the time period. So R you can be again write mv by qb. So 2 pi you will write mv by qb upon v. V to v will cancel out. Time period you will get 2 pi m by qb. So this is the simplest explanation whenever motion of the charged particle in which velocity and magnetic field both are perpendicular to each other, then time period required to reach to its original position in the circular path will be 2 pi m by qb. Okay, and why helical path will be performed? Helical path will be performed when theta, which means angle between velocity and magnetic field, it having certain value, which is not exact value of 90 degree and 180. Then on that case, we can guess that particle motion will be helical. Helical means it's look like this. Okay, so in this scenario, particle having one horizontal velocity, that is v cos theta, and one of them with velocity v sin theta. So due to v sin theta, it will cover vertical circular motion. Due to force, magnetic force, and due to v cos theta, it comes to the horizontal distance. And the distance measured by the, you can say, at a horizontal velocity, that is called pitch of the helical path. So pitch you can be find with the help of direct formula mv cos theta by qb. And time period you will again find 2 pi r upon v sin theta. And r you will get qv sin theta multiplied by b, that will be equal to centripetal force which are acting towards the center, which is m v square sin square theta upon qb. So v to v will be cancelled out, sin theta to sin theta will be cancelled out. So overall q, what is mv square by r, sorry, that is r radius. Okay, so v to v will cancel out, sin theta v will sin theta cancel out. So r of the radius we will get mv sin theta upon qb. And let's put the value of this mv sin theta in this term, then you will get 2 pi m by qb, which is your time period, which is also similar to the first result. That means time period of the, you can say, circular or helical path will not depend upon the, you can say, theta between the angle theta between the magnetic field and velocity. Okay, and also it is not it is independent from the velocity also. Let's talk about the cyclotron. What is cyclotron? Cyclotron, it is the device on which we can accelerate of any charged particle. Okay, because how acceleration can be possible? Acceleration can be possible because magnetic force can change only direction, but acceleration can be get with the help of, you can say, electrical field. So we have this cyclotron diagram in which there are two half circle which I'm showing to you. In this half circle, these are called Ds. Okay, so in this Ds, any charge particle can be travel. In this charge particle will be travel with accelerating motion. How accelerating motion will be happen? Because this D is this diagram is not clearly. Let's look at this. This is the diagram of cyclotron. Initially, particle is look like this, and it will motion like this, and again come back to the with a higher velocity. So these T's are connected with the AC voltage, and this AC voltage are changing continuously its direction. Let's say this one is positive direction, this is negative direction. So electric field sometimes moving from to negative to positive, positive to negative, and after changing the polarity, electric field direction again will be changing to the minus comes to the positive side and positive comes to the negative side. Then again electric field direction again change. So due to simultaneously changing the direction of electric field, force on the charged particle will always apply like QE by QE, where that is force, and acceleration due to particle will be QE by M. And this acceleration, if is it possible, is it you can say, if is this acceleration is, you can say, positive value, that means according to electric field direction, particle always changing, always increasing its velocity. So these kinds of thing will be happen whenever particle reaches moving like this. So also we have applied also, you can say, magnetic field, so that particle can move in the circular path, and during the circular path, presence of the electric field time duration has increased. If time duration of the presence in the electric field has increases, that means acceleration will be at a more time. If acceleration will be acting at a more time, that means velocity will be increased very higher time value. If velocity having more time to increment, that means velocity becomes more higher inside the cyclotron. So that means the frequency of the external voltage to changing its polarity, that will always equal to frequency of the time period of the, you can say, charge particle. So time period, not time period, frequency of the charge particle. So frequency, that is inversely proportional to 1 upon time period, and time period we have already get 2 pi m by qb. Then frequency of charge particle will be qb upon 2 pi m. That will always equal to voltage frequency. If this situation has occurred in very well, that means cyclotron can be worked to very well, so that any charge particle can be accelerated with higher accelerated, and after that it will gain higher velocity. So mainly cyclotron mainly work for a smaller charge entity on which we need to move their faster velocity. Then on the time we are using cyclotron. Okay, let's talk about the Biot-Savart law. Biot-Savart law I already explained you that it mainly refers to that how to find magnetic field due to current carrying wire at a particular distance. This formula I have already discussed, and direction I have already discussed, and this kind of thing I have already discussed to you that magnetic field at a point B always inversely proportional to 1 upon r square. It is also proportional to current passing through this wire. It is also proportional to dl sin theta. After using this phenomena, we can consider that magnetic field at a particular distance p considered as mu naught I dl sin theta upon 4 pi r square. Let's talk about if you have a circular coil whose radius is capital R and current is moving like current is moving has a magnitude I, then how can you find magnetic field at the center of the coil? The center of the coil, you can find magnetic field as a mu naught I upon 2r. Okay, and you can say, if I talk about the direction, then curl your finger according to the direction of the current, and your thumb will be pointed to the direction of the magnetic field. So if a current passing through the anti-clockwise, then my finger curls to the anti-clockwise and my thumb to the outward the plate. So in this case, magnetic field will be outward. Got it? So these are the basic phenomena so that you can find the magnetic field due to circular wire. And same thing, if I have a particular circular coil on which I want to find magnetic field at point P at a particular distance x as the axial distance, and let's say is circular coil having radius r, then magnetic field at point B, we know about the direction. Direction is always along the x-axis, and the magnitude you will be right mu naught I r square upon 2 r square plus x square to power 3 by 2. This is the magnetic field due to circular coil at axial distance x. So these three kinds of things you have to understand whenever you are applying the Biot-Savart law in the different cases. These are the basic phenomena and you can say formulas, so that you can understand with the help of this formula you can solve every problem in your examination purpose as a Biot-Savart related problem. Okay, we have a question which you have to solve by yourself. A charged particle Q has mass small and enters the magnetic field B with a velocity V perpendicular to the field. The particle moves in the circular path. If the magnetic field is doubled and velocity remains same, the new radius will be. So radius we have already can be find 2 pi. Radius, how we have find? Radius we have find mv by qb. Okay, radius we have got mv by qb. So mainly radius mainly depends upon the magnetic field and velocity. Okay, so if question is saying magnetic field is doubled and velocity remains, if magnetic field is double to B, then radius becomes half. That is your option B is the correct answer. Let's talk about the solenoid and toroid. What is the toroid? Is the, you can say solenoid is just like a spring. Just like a spring, if a wire is along like a spring, then if I put a particular conducting to stabilize this spring, and after moving, after passing a current to this you can say solenoid, that means it will produce a magnetic field. Okay, so if I have an infinite length solenoid, that means their magnetic field will be written as mu naught Ni. And if I have a toroid, then toroid magnetic field mainly depending upon the Ni. Got it? So if I have a finite length toroid solenoid, then magnetic field at any point P in the solenoid given as mu naught Ni by 2 cos theta 1 minus cos theta 2. That is the magnetic field inside the solenoid when it has some finite length like this. Solenoid will look like this, and let's say current I passing through this, and let's say I want to find magnetic field at point P. Let's say this end having angle, and this is horizontal line, and this line and also having angle. So this angle is, you can consider as a theta 2, and this angle is theta 1. So after putting this theta 1 and theta 2 value, you can find magnetic field due to solenoid of a finite length also. So these are the solenoid. And what is toroid? Toroid is the same kind of solenoid, but if I connect this toroid as a circular form, that is called toroid. Okay, and due to toroid, magnetic field is depending upon the toroid like N into I. Okay, and this is again force per unit length due to current conducting wire, that is F by L will equal to mu naught I1 I2 upon 2 pi d. If exact derivation I can show you, but the main thing is that it will not understandable for yours with a small duration. So you just imagine, you just understand their formula. F by L equals to mu naught I1 I2 upon 2 pi d. So this is the, you can say, force between two parallel currents carrying wire. Okay. So, but let's understand few things. When current having same direction, that means both will repel. And if current having opposite direction, then both wire will attract. Okay, both wire will attract. Okay, so these are the few things which you have to know. Let's talk about the torque. Torque is what? Whenever you have a ABCD rectangular coil inside the between the magnetic field, and if you slightly disturb slightly angle theta, then on the time due to magnetic field, torque will be applied. So torque will be applied on that ABCD coil, that will be equal to torque equals to IB NS sin theta. Okay, and M is the constant that will be considered as I into A, so that torque mainly depends upon M into B into sin theta. Got it? So that kind of thing is the torque calculation which I am giving you in front of yours. And galvanometer is also depending upon this kinds of thing. Whenever during this calculation, if I add a needle, so this needle will rotate according to value of torque. Okay, so torque I have given IB NS sin theta. So can I write N is the number of time which is constant, I is the constant which is current passing through the you can see this ABCD coil, and A is the area and B is the magnetic field by the magnet. So all of these are constant. So can I say torque is directly proportional to Sine theta, if theta is very small, then can I say tau is directly proportional to theta. So more torque, more theta. If I apply this constant, if I remove this constant, then can I say, then I case tau equals to C into theta. So that means torque is constant, it's totally upon the theta. So now moving coil of galvanometer and voltmeter. So I equals to K upon NBA theta. Again, same thing. Again, same thing according to this. Okay. Let's derive the direct formula. So I will equals to K upon NBA multiplied by theta. That is the galvanometer deflection. Okay. When high current is passing, theta will be high. When current is low, theta will be low. That is the differentiation of the theta with the current with the help of this expression. The moving coil in galvanometer, you can assume that galvanometer can be used to measure a current on the basis of coil deflection. Okay. And coil deflection can be occur whenever torque is applied. Got it? So chapter recap, I have already explained you like this. And this is also question. This is homework for yours. Do your by self. Okay, let's solve this question. A straight conductor of length L carries a current I and is placed perpendicular to the uniform magnetic field B. If the current is tripled and magnetic field is B is half, then force on the conductor will be. So F by L will be mu naught I1 I2 upon 4 pi D. Apply this formula and solve this problem. Okay. A circular loop of radius capital R carries I current and magnetic field at B center. The radius of this double, the current is half, then new magnetic field. Magnetic field due to circular coil will be mu naught I upon 2R. That is the magnetic field due on the circle. Okay. If radius of the circle, if the magnetic field be, okay, if the radius of the circle is doubled, that means mu naught I upon 2 multiplied by 2R. Okay. If radius is doubled and current is half, that is 1 by 2. So overall, what is the changing of magnetic field? So mu naught I upon 2R and divided by 1 by 4. So magnetic field becomes 1/4. So B by 4, that is your answer. Same question, which is two long parallel wires carrying current I1 and I2 in the same direction and separated by a distance small d. If the current in one wire is double and the force between the wire becomes if a current are same direction, that means both wires will repel to each other. If current is then force, we can calculate mu naught I1 I2 upon 4 pi d. But it so infinite wire, so we are writing 2 pi d. So if one wire having current doubles, that means force will become double. So option B will be correct. Okay, let's solve remaining question by yourself. These are all your homework. Okay. Next question: a wire of length L current carries I placed in the magnetic field B, angle theta, then find the angle. That is all your SW. Okay. Solve by yourself. And this is also your SW. All question comes from your theory. So your overall chapter has ended, which is magnetic effect of current, and all of these kinds of things we have completed. So anyone who have any doubt, who and she can ask me. After that, we can end this session, and next time we will continue with our next chapter. Any doubt? Abhinav? Any doubt? If anyone have any doubt, he and she can reply on my chat. So last question, फिर से दिखा दीजिए. लास्ट क्वेश्चन कौन सा? यही था लास्ट क्वेश्चन. ये मैंने SW दिया है. Screenshot nahi liya. Okay, wait. Let's take a screenshot. So have you taken the screenshot? Okay. So today we have covered at least class 12 physics as well as 2 physics chapter in the class 11th also. So if you have any doubt, he and she can ask me in the next classes. After that, we can. So we have to end this lecture. You have to take rest, and after a few times you can solve some more problem regarding the physics, and you can ask me. Sorry to say, but we have one more chapter left, which is electromagnetic induction, AC, and one more chapter that we can be study. So still class 12 syllabus is not completed. So I think we need one more hours to complete this syllabus. So firstly, you can take rest only for 10 to 10 minutes, and after that we can continue with our next chapters. Okay, so we will continue alternating current, AC, which is very useful for your examination purpose. So are you ready for your next class? So we have covered current, electricity, electrostatics, optics, and also we have covered magnetic effect of current. But main thing is that in according to current, electricity, and according to capacitance, we are generating electricity and using electricity with the using of battery. So can we generate electricity without using of any battery? Is it possible? So this thing is it possible with the help of electromagnetic induction, which is our next chapter. So in the next chapter, we will deal with that. How can we generate electricity without using of any battery and you can say any conductor? And how can we calculate electricity on that time and how much electricity will produce? Okay, that kinds of calculation we will do in the next chapter, which is electromagnetic induction. So mainly electromagnetic induction refers to you that whenever you are feeling some kinds of that, whenever they are changing the flux inside a particular coil, then the induced EMF has generated in the particular coil with the particular ends. Then this with the due to this induced EMF, current is producing in the complete conductor, and this phenomena is called electromagnetic induction. Okay, so only 3 to 4 student has added. Where is the other? Okay. So let's discuss this chapter, which is electromagnetic induction. So electric current is the very beautiful thing on which our every surrounding things majorly work based upon the electric current. So generation of electric current before 19th century, we are using just batteries. With the using of battery, we are generating electric current. But after, you can say, Michael Faraday's experiment, we can generate electricity by changing the electric flux changing. Okay, how is it possible? So we will consider this kinds of thing after looking the Faraday's law. So Faraday Henry overview the experiment, performed a series. Wait, example. Okay, so Faraday Henry overview experiment performed a series of simple but profound experiment using coils, magnet, and galvanometer. Three key demonstrations. Experiment: bar magnet move near a coil. Experiment number 2, one coil carrying current neared another coil. Experiment number 3, two stationary coils linked an iron core with a trapping key. Common conclusion: a changing magnetic flux linked with a circuit induced an EMF on it. That is the simple understanding behind is that. Let's discuss about the magnetic flux initially. What is magnetic flux? So everyone knows about that from the previous chapter. Any current conducting wire produces magnetic field. Got it? And if any conducting wire produces magnetic field, that means magnetic field lines are generating from the conductor. For example, if I have a magnet like this, this is North Pole, this is South Pole. Magnetic field lines always travels from north to south, like this. Okay. So according to just electric flux, we have just understand that electric flux is what? Number of field lines passing through a particular cross-sectional area, that is called electric flux. Similar kinds of when number of field lines passing through a particular cross-sectional area. Okay, that is called magnetic flux. For example, I am writing it's just you can say conducting coil whose area is A, whose area is A. And now you can see that what is flux value. If 3 lines is passing through this particular area A, then I can say flux is 3. If 4 lines is passing through this flux, then we can passing through this area, we can say flux is 4. But what if I tell you if flux is changing with respect to time? For example, field lines producing magnetic field with a huge number of lines, and if I move this, you can say if I move this magnet from the coil, then you can see that sometimes magnetic field lines are passing through the conductor is more and sometimes less. When when magnet comes nearest to the, you can say, area vector, then you can see that huge number of lines are passing through this plane. And after away from the magnet, number of field lines are getting less. That means number of field lines passing through the particular area is changing. If number of field lines passing through the area is changing, that means the induced EMF will be generated with the cross-sectional area of the you can say with the, you can say, conducting wire, and on that time induced current will be flow throughout the circuit. Let's look at like this example. When I move magnet inside this coil, coil is the conducting coil whose can be pass current, and this is the galvanometer. Okay, and you can see that field lines are having direction north pole to south pole like this, and this has also moved so many values, so many field lines are passing through this. So when I move my magnet nearest to this coil, then field lines passing through the coils are increases, and when I move away from the coil, this magnet, then I can see that number of field lines are you can say decreases. So sometimes flux increases, sometimes flux decreases, sometimes flux increases, sometimes flux decreases. Due to this changing of flux, an induced current is passing through this coil, and after passing through this coil, it will pass through the galvanometer, and the galvanometer shows some deflection. So the, you can see that with the help of just magnet, we are producing electricity. So this kinds of phenomena is called electromagnetic induction. So main thing is that Faraday's statement mainly saying is that the, you can say, the induced EMF which was generated, it is directly proportional to rate of change of flux. If flux is changing, with respect to time is very more, then induced EMF will be generated as more. And you can say that if I have a number of turns n, then you can see that induced EMF will directly equal to n d phi by dt. And d phi by dt is what? D phi by dt is the rate of change of flux with respect to time. Got it? So this is the Faraday's law of statement, in which that whenever we are conducting coil on which we are moving a bar magnet with velocity v, then due to changing of flux, induced EMF is generated, and due to this induced EMF generation, galvanometer will show some deflection because induced current is passing through this galvanometer. If induced current is passing through this galvanometer, that means current can be passed from this galvanometer, and this phenomena is called electromagnetic induction. Got it? So here are few understanding which I have told you, bar, magnet and coil. Experiment number 2, which is again same thing, 2 coils induction experiment. For example, if I replace this bar magnet into the, you can say, coil, and if I passing a current with the help of battery from the coil, then you can see that conducting coil also produces magnetic field, and this is also looks like solenoid. And I have already told you in the previous lecture, solenoid magnetic field lines are looks like this. Solenoid having magnetic field like this. Okay, so if I move current conducting coil nearest to the second one coil, then you can see that again flux is changing. Why? Because magnetic field lines are changing in this particular area. So if flux is changing inside this secondary coil, then you can see that again induced EMF has generated inside this coil, and if induced EMF has generated inside the second coil, then you can see that induced current has flow from the galvanometer. If galvanometer shows some deflection, that means that is process is called electromagnetic induction. So with the help of changing the magnetic field value, magnetic field lines value, you can see that flux is changing. If flux is changing, then you can say induced EMF have generated. So 2 coils induction induction thing is also very same. When this coil is also looks like solenoid, and due to solenoid, magnetic field lines like this. And whenever we are moving this magnetic field nearest to the coil, then you can see that induced EMF has generated. Charge changing current in induced EMF. Trapping key experiment, stationary coils. Both coils are stationary. C2N has battery. Trapping press key momentary deflection. Okay, one of another thing which we can feel is that you can also know that magnetic field inside the, you can say, solenoid can be changed as mu naught Ni by 2 cos theta 1 minus cos theta 2. So flux can be changed how many ways? Flux can be changed number of field. When I increase the strength of the magnetic field, that means number of field lines has increases. And if number of field lines has increases, that means number of field lines per unit area is also changing. That means flux is changing. So number of field lines in the per unit area passing through the unit per unit area is can be changed whenever I moving the coil nearest to the secondary coil. But it could be also possible when I increase the strength of the magnetic field. If I increase the strength of the magnetic field, initially let's say two lines are passing through this because of lower strength. If I increase the strength of the magnetic field, that means number of field lines increases. If number of field lines increases, that means number of field lines passing through this area also increases, which means without moving of coil, when I increase the strength of the magnetic fields, then it can also generate electricity. That is also called the, you can say, electromagnetic induction. And how magnetic field will be increased? When I increase the electric current with the help of this battery. So with the help of increasing electric current, B due to solenoid is also increases. B increases, the number of field lines will also increases. That's why current can be passed. Got it? So here are some basic examples so that we can identify. So firstly, let's solve this question. A coil of 100 turns, area 0.02 meters square, magnetic field changes uniformly from 0.5 to 1.5 into second, then find induced current. So firstly, phi we can be represent as N B into A. N is the number of turns, B is the magnetic field, A is the, you can say, area. So phi can be changed with the help of these things. So if I change the area, let's say magnetic field lines are looking like this, and if I place the area like this, then only two lines are passing through this. And if I increase the area, then you can see then more field lines are passing through this. So if I change the area with respect to time, then you can see that flux is also changing with respect to time. Got it? And if flux is changing with respect to time, that means induced current can be generated, induced EMF has generated with respect to time. Okay, so that is our first thing which you have to know. Second thing which we can be now, if I change the strength of the magnetic field, that means more field lines are passing through this particular area. That means also flux can be changed. So flux, how to change, it totally depends upon our choice. How can we increase our flux? Okay. So according to this, magnetic field is changing. That's why flux is changing. So you will be right delta phi by delta t. That will be equals to induced EMF which is generated and delta phi by delta t. So delta phi by delta t can be written as area is constant and magnetic field is changing delta p by delta t with respect to time. So what is the flux changing? You will be right. Area cross sectional is 0.02, which is already given, and delta b will be 0.2 to 1.5. What is the change? Change is 1, and in which time interval? 2. So that is the d phi by dt. So d phi by dt for single turn is the like this. For 100 turns, you will multiply by 0.002 multiply by 1 by 2. That is the induced EMF which has generated. So 10 to 10 cancel it, 2 to 2 1 we can cancel it, and EMF generated will be 1 volt. This is your answer. Got it? So magnetic flux, I have already explained you. Magnetic flux can be defined as B dot A. That will again explain you B into A multiplied by cos theta. Okay, it's just like an example is, so for example, look at my writing pad. It have a particular area. So if I pass magnetic field lines passing through this, let's say 2 field lines are passing through this, then flux will be 2. And if I change this area, if I change the, you can say, angle between magnetic field lines and area vector, then you can see that few magnetic field lines are passing through this area has changed. That means flux mainly depends also theta. That means angle between flux can be changed with the help of, you can say, flux can also be changed by the you can say angle between area vector and magnetic field. Flux can also be changed. So flux can be written as B dot dA. B dot dA can be written as BA cos theta. And if I write d phi by dt, so flux can be changed with the respect of first thing with the help, if area and theta is constant, then flux can be changed with the by changing of magnetic field. And if I write d phi by dt, If magnetic field is constant, then flux can be changing by the area changing. So you can write cos theta B dA by dt. And if area is changed, if area is constant, magnetic field is constant, and if I rotate the coil inside the magnetic field, then due to angle changing of theta, flux can also be changed. So d phi by dt on that cat can be written as B multiplied by A minus sine theta d theta by dt. So this is your explanation about how flux can be changed. So that is the electrical flux and magnetic flux which I told you. Let's the question. If flat surface of area 0.2 centimeter square placed in a uniform magnetic field at 5 Tesla, the angle between field and the normal is 60 degrees and find magnetic flux. So magnetic flux given as B dot A. So phi can be written as B multiplied by A multiplied by cos 60 degree. So phi you can be written as B is 5 Tesla and area is 0.2 and cos 60 is 1 by 2. So answer you will get 0.5. Okay, and unit of flux will be Weber. Okay, unit of flux is Weber. Got it? So here is the basic direct formula which I have already explained to you. Magnetic flux formula and cases. Flux in non-uniform magnetic field, I have already give you few things. D phi equals to B dot dA. So non-uniform magnetic field means B dot dA. I have already explained you. Let's consider a question. An electrical field varies positive. It's given as 5x. Okay, along x direction. A square surface of side 2 meter is placed perpendicular to the field at x equals to 1 meter. Electric flux passing through the surface will be. So electric field is varying with respect to time. So phi can be written as E dot dA. So square of side A. A is given as 2 meter square. So electric field can be changing E dot 2 multiplied by dx. Okay. So electric field can be written as 5 into x. 5 can be 5x and multiplied by 2 multiplied by dx. And you have to find electrical flux. Electric flux through the surface will be. Okay. I want to find not d phi by dt. I want to find only flux. Okay. Flux can be written as E dot A. So electric field is given at 5x and area is 2 meter. 2 multiplied by 2, that is 4. And you want to find electric flux at x equals to 1. So put the value at x equals to 1. 5 multiplied by 4, that will be 20 Newton per meter square per coulomb. Okay. Faraday's laws of electromagnetic induction, I have already explained you that the induced EMF generated by the changing of rate of change of flux. Okay. So I have already explained you E is directly equal to n times of d phi by dt, and d phi by dt is what? Rate of change of flux. Okay. Meaning of the negative sign in the Faraday's law. The meaning of the Faraday's law is that induced EMF will be generated in such type of way so that it will be oppose the rate of change of flux. Okay. Induced EMF will be generated in the such type of way so that it will always oppose the rate of change of flux. Okay. Meaning of the negative signs I have already explained you, which will be really helpful whenever you are finding the current direction. If a number of turns is double and flux is changing the same, induced EMF becomes double. I have already told you induced EMF will equal to n times of d phi by dt. Got it? Now let's talk about the Lenz law. Lenz law mainly helps you to find the recognized direction of the current whenever induced current has flow. So you just apply opposite result of how flux can be opposes, how flux can be reduced. So induced EMF, induced current will be generated in such a way so that rate of change of flux can be reduced. For an example, let's say this is a coil and this is a magnet. This is a north pole, this is south pole, this is like magnetic field. When you comes this magnet nearest to the coil, current passing through the coil is like this. Okay. So current passing through the coil is looking like this, but it can be current also having direction like this also. Okay. So which one direction will be correct? Which one direction will be correct? So main thing is that current direction will be correct on such a way where rate of change of flux can be decreases. So if rate of change of flux can be decreases when magnetic field strength can be decreased. If magnetic field strength can be decreased, that means current produce their own magnetic field in such a way so that it will be opposite to the magnetic field of the magnet. And if both are opposite nature, then both will be cancelled out this nature, and after that we can say that rate of change of magnetic field will be decreases. So in which case both magnet and coil's magnetic field will be decreases. So if this is the current conducting coil, and if I induce current is passing through this, then the direction of the current will be like this. So if the direction of magnetic field of the due to conducting coil is like this, that means this is the opposite direction of opposite direction of magnet's magnetic field. If it is the opposite direction of magnetic field, let's say that is B1, that is B2, then net magnetic field again reduced, that is B1 minus B2, and the B net by dt, that is net magnetic field is changing with respect to time, which is very increasing, which is always opposing the rate of change of magnetic field. That's why magnetic field will be current will be produced in such a way that so that it will reduce the rate of change of flux. Okay, so that is the Lenz's law. So Lenz's law mainly follows the laws of energy conservation. Pushing a magnet towards a coil, induced current opposes the motion, that is repulsive force. Pulling away, induced current attracts the magnet. Hence, external work done to be needed to move the magnet. This mechanical work appears as electrical energy in the circuit. If induced current added in the motion, free energy violates conservation of energy. Lenz's law is simply conservation of energy applied to the electromagnetic induction. So mainly due to this opposite nature of magnetic field, mainly this conducting coil will repel to this magnet. So repel to this magnet means that's why it will always oppose the rate of change of flux. So we need to apply an external work done so that it can be moved towards the coil. So it can be moved towards the coil, that means flux is again increasing due to external work done. So this external work done is directly converted into the electrical energy. Okay, so main thing is that energy can be converted into the one form to another form, that is energy conservation. So meaning is that energy is not freely get inside this coil by induced current by changing the flux. Changing the flux is also appear by the help of external work done. So that's why energy is conserved and it is not violate of energy conservation. Let's talk about the direction of induced current. So induced current, I have already told you that induced current will be flow in such a way so that it will oppose the magnetic flux. Got it? So look at this example, loop entering when loop is entering in the magnetic field, then you can see that initially field lines are 1, and after entering the field lines are getting increases. That means flux is increasing. If flux is changing, that means induced current can be flow. It could be move like this, and it could be also move like this also. So which one will be correct? So firstly, if current is passing through this, that means it will create its own magnetic field. If it is create its own magnetic field, that means it will always violate to the external magnetic field, so that net magnetic field lines decreases. So if I consider the magnetic field direction like this, which I am drawing, the induced current direction is like this, which I am drawing, then if I consider my finger to find the current to find the direction of magnetic field, then it is always showing outward direction. If it is showing outward direction, that means magnetic field lines are increasing. If magnetic field lines increasing, that means it is always promoting to the increasing of the flux. But induced current will be moved in such a way so that magnetic flux should be reduced. So it is according to Lenz's law. So our direction, which I assumed like this, that was wrong. So correct direction is like this. So now let's consider this direction. You can see that current magnetic field due to current will be invert the plane. So it is invert the plane and extend the electric field to the outward the plane. Both will be cancelled out to each other. That means both magnetic flux will be reduced. So according to this phenomena, according to you can say this understanding, you can assume as the induced current direction according to your understanding in which direction current loses the rate of change of flux. Okay. So direction of current you can be find. Which of the following is true? Lenz's law gives the magnitude of current? No. Lenz's law gives the direction of current? Obviously. Lenz's law gives the resistance? No. Lenz's law gives the flux directly? No. So correct explanation is Lenz's law gives the direction of the current. Let's talk about the motional EMF. Motional EMF mainly refers to that whenever any conducting wire placed in the magnetic field and moving with certain velocity, then it will act like a, you can say, cell. Okay, so current will be passing through this wire P to Q due to changing of flux. And this motional EMF, this EMF has generated in the, you can say, in between the wire, it is value is BVL. B is the magnetic field, B is the velocity, and L is the perpendicular distance from the magnetic field. Got it? That is the motional EMF concept. And here is the basic derivation regarding to this. So you need to understand how this EMF has generated. E equals to BBL. So motional EMF formula you can written E equals to DLB, direction induced current given by the Lenz's law and right hand thumb rule. So direction of the current you can find with the help of right hand thumb rule. How? So firstly, direction of the, you can say, that is the direction of the, you can say, velocity, and it is the direction of the current. So whenever you are moving your finger towards the direction of the magnetic field, then your thumb will point out to the, you can say, induced EMF generates. Induced EMF direction, that is the plus and that is the minus, because my thumb is pointed to the upward. So direction will get again along the direction of this, like this. Okay, so this is the direction of current. I think sorry, this is minus and this is becomes plus, and direction of the current will be to the downward. Okay, like this. So this is the direction you can find with the help of right hand thumb rule. If the R is a resistance, current induced by the current will be induced EMF will be generated like BVL, and I current will be passing through this, you can say, wire. Then current you will get BVL by R according to Ohm's law. V equals to IR. Okay, and voltage across the, you can say, wire will be E, and E has already written as BVL. Then I have find current with the help of Ohm's law. I equals to BVL by R. Okay, so these are the simple calculation which I told you. And how can you find power? Power can be find P equals to VI. So we can be write BVL is the potential, and current is already written BVL by R. So you have got B square L square by R. That is the value of power. Got it? So here is the explanation about it. So let's consider a question. A rod of length with 0.5 meter moves with speed 4 meter per perpendicular magnetic field to Tesla. Motional EMF will be, you will get BVL. A you will get BVL. So B is the, you can say, 2 Tesla. Velocity is 4 and length is 0.5. You will get E will be thus 10 upon 10. E you will get 4 volt. Okay. So this is your answer. Okay, what is inductance? Inductance, you can say, flux linkage through a coil is proportional to the current producing. So it is look like this is inductance. Okay, this is L. Okay, so L. Okay. So the EMF producing by the changing of the flux inside this inductance E can be written as minus, directly proportional to minus di by dt, rate of change of current. Okay, so EMF due to this inductance can be written as E will equals to L di by dt. Okay, and L is what? L is the constant that is called which that is called inductance. The proportionality constant is called inductance. Two kinds of inductance: mutual inductance and self-inductance. This is called self-inductance of a single coil due to its own current, and mutual inductance between two coils. Okay, SI unit of inductance Henry, Weber per ampere, and volt per second per ampere. Okay, Inductance depends only on geometry and the medium. Okay, so these few kinds of things you have to know whenever you are deal with inductance. Let's solve this problem. Like inductance of 600 carries a current changing uniformly 3 ampere, 3 ampere to 9 ampere at 3 seconds. Find induced EMF. So I have already told you that induced EMF can be written as L di by dt. So induced EMF can be written as 6 Henry multiplied by di is 9 minus 3. 9 minus 3 upon time is 3 seconds. So E will be get 3 minus 3, 3 is 6, and 9 minus 3, that is also 6, and 6 to the 12 volt, that is your induced EMF by the inductance. Let's talk about the mutual inductance. Consider two couple coils, flux through coil. Okay, that is the simple phenomena which I explained to you. Everyone knows about that. Any conducting coil produces, any current conducting coil produces magnetic field. Okay, what if I tell you I have another coil like this whose no current is passing through this, but can I increase I current is passing through this coil? Okay, so if I current is passing through this coil, it can also produce magnetic field. Is it right? Like this. And if I increase the magnetic field strength and in front of this coil, then can I say number of field lines has increases and number of field lines passing through this coil has increases. So if number of field lines passing through this coil has increases, that means flux inside this coil has increases. If flux inside this coil has increases, that means induced EMF has generated in the second coil. If induced EMF has generated in the second coil, that means induced current passing through this secondary coil. That is called I2. Got it? So main thing is that if any coil, by changing its flux, due to changing its flux of first coil, if secondary coil produces induced EMF, that is called mutual inductance. Okay, so mutual inductance M21, mutual inductance of coil 2 with respect to coil 1, and this is called as a capital M, changing current in the coil, induced EMF in the other basis of transformer. Okay, that is called mutual inductance. Here is the formula. N2 phi2 will equal to M21 into I1. The meaning of this line is that N2 is the number of turns in the second coil, and phi2 is the flux on the second coil. M21, it is the mutual inductance due to 1 of second, and I1 is the current passing through this, and even you will write minus I minus M d I2 upon dt. So this is your EMF. Mutual inductance of two long coaxial solenoid. So mutual inductance due to two axial solenoid can be written as inner solenoid length L, radius R1, N1 number of turns per unit length. So outer solenoid same length, radius R2 is greater than R1, N2 is the number of turns per unit length. Field inside the inner solenoid mu N1 I1, and flux through that flux each of the turns that is written in V1 multiplied by pi R1 square. Total linkage outside N2 into phi2, that is written as like this. Okay, so it is totally mutual inductance of the solenoid can be written as mu naught N1 N2 pi R1 square multiplied by I. It is totally depends upon the geometry. Okay, here is the question. Two coils having mutual inductance 2 Henry. Current in the primary coil is 1 ampere to 5 ampere in 2 seconds. Then find induced EMF in the secondary coil. So induced EMF can be written as mutual inductance divided by di by dt. So current changing will be 5 to 1, that is 4 in the 2 seconds, that is 2. So 2 multiplied by it has already given mutual inductance is 2 Henry. So we will be had 2 Henry. So E can be written as 4 volt. So that is your answer. Let's talk about the self-inductance. Self-inductance, a coil carrying current carrying I produces a magnetic field through itself. Flux linkage N phi is directly proportional to I. N phi equals to Li. L is called a self-inductance. Depends on the geometry of the medium on the current. For long solenoid, L can be written as minus L mu R mu naught N square A L. So that is the self-inductance which you have to understood. So here's the direct formula: n phi equals to Li and L equals to mu naught n square A L air core solenoid. Okay, self-induced EMF and back EMF. When current through a coil changes its own flux, EMF is induced in it. By Faraday law, E will equal to minus n d phi by dt, L equals to minus L di by dt. So self-inductance you can be written as EMF from the self-inductance can be written as L di by dt, which I have already explained to you. Okay. Okay, here is the question. A coil inductance 3 Henry carries current which is variable 5 plus 40. Okay, 5 plus 40 induced EMF is written as. So induced EMF can be written as L di by dt. So you have to differentiate this current equation with respect to time. So E you will be get 3 multiplied by differentiation of this equation will be 4. So E will be you will get 12 volt. Got it? So energy stored in the inductor can be written as 1 by 2 L I square. That is the energy stored in the inductor. You can be written. To build current I to 0, external source must be do against the back EMF. Power delivered at instant when current is I will equals to P equals to E external multiplied by I. Work done will be 1 by 2 Li square. This energy stored in the magnetic field as a of the inductor. So released back to the circuit when the current decreases. So I you can be energy stored in the current you can be written as 1 by 2 Li square. Here is the formula. A coil of inductance 6 Henry carries current increasing 2 ampere to 4 ampere. Change in the energy. So energy can be written as 1 by 2 Li square. So changing energy can be delta E by E. Delta E will equal to 1 by 2 L 2I delta I. Okay. So changing energy can be written as L I. Okay, sorry. I have to written like this. Changing energy can be written as 1 by 2 L I square. Okay. So initial energy will be for 2 ampere current. Apply 2 value at the side. So E you will be get 1 by 2. L is what? L is 6 and I is what? 2 square, that is 4. So 2 1 are 2, 2 2 are 4. Initial energy is 12. Let's talk about the final energy. Final energy will be 1 by 2 L I final square. That will be equal to E final will equal to 1 by 2. L is what? L is 6 and I final will equal to 4. 4 square, that is this 16. 2 1 are 2, 2 3 are 6 and final energy will be 48. And total change in energy, if final minus A initial, that means 48 minus 12, that will equal to 36. Option C will be correct answer. Let's talk about the AC generator. How AC generator works. So mainly AC generator, it is the, you can say, example of a changing of flux by angle changing of theta. Got it? Got it? So at every rotation, current changing its direction. That is called AC generator, because at every rotation, EMF is EMF is also changing its direction. So main parts armature, it is a rectangular coil which have n turns. Area is A that rotates. Field magnets, these are field magnets which are having direction north to south. Okay, provide a uniform magnetic field B. Slip rings rotate with the coil, maintain electrical contact. Carbon brushes take the induced EMF, the external circuit. Train or movable turbine engine rotates the coil with angular velocity omega. Convert mechanical energy into the electrical energy. Okay, how it is working. So mainly it can work that you can say that the flux changing throughout the, you can say, area. We can write as B equals to B into A into cos theta. Okay, now this flux is changing due to changing of, you can say, due to changing of theta. So you can be write d phi by dt. If B and A is constant, differentiation of this minus of sine theta, and you can write d theta by dt. So d theta by dt is what? D theta by dt is the omega, and theta is the you can say angular displacement at a particular time. So angular displacement can I write omega into t. So d phi by dt will equal to minus b a omega sine omega T. Okay, and now this is directly proportional to EMF. So EMF can be written as, let's write n number of turns having. So EF can be written as n B A omega sine omega t. Okay, that is your EMF. So that is the value which I have drawn in front of you. EMF alternate in sign as coils rotates, alternating current. So on the basis of timing P value and on the basis of sine value of theta value, EMF is changing its direction with a particular time interval. Okay, let's solve this question. An AC generator has 100 turns, area of coil is 0.0 meter, rotating and magnetic field at a value of 0.5 Tesla with angular velocity 20 radian. Maximum EMF will be. So we have written N A B omega sine omega t. That is the value of EMF which we have already discussed. Okay, like this. So we can written like this. Something has opened. Okay, so we can written like this. E is the number of turns are 100, area is 0.02, and magnetic field is 0.5. Omega is what? Omega is already given 20 radian. And I want maximum EMF. That means sine value having must be 1. We have discussed about AC through pure resistor. Okay. Let's take about the phasor representation about it. So in AC through pure resistor, we can see that current from the voltage are having same phase. So a phasor is a vector that rotates anti-clockwise about the origin with angular velocity, angular speed omega. That kind of thing I have explained in the last lecture, in the last class from yesterday, in which phase diagram I have explained why we are using. Okay, Handley tool to represent amplitude and phase of the AC quantities on diagram. Phase difference between two quantities is equal to angle between their phasor. Okay, resistor V and I phasor aligned. Inductor lags V by 90 degree. Capacitor leads V by pi by 2. So these kinds of things you have to know. Okay, these are important things which you have to know. AC through a pure inductor. AC through a pure inductor. How can you deal with that? So self-induced EMF across the inductor V equals to L di by dt for V equals to V naught, that is maximum voltage sine omega t. Integration gives I will equal to Vm by omega L sine omega t. That means V is the function of tan t, we can written as V naught sine omega t. And if we have inductor, then we can write inductor potential across inductor, we can write L di by dt. Okay, now dt moves to the in front of Vt. So L di you will be get Vt and multiply by dt. So let's integrate this Vt with respect to time t. You will be get minus V naught sine omega t upon omega, that is equal to L times of di, L times of I. So I is the function of time t, you will be written as I is the function of time t. You will be get minus V naught by omega L cos omega t. Got it? So this is your current equation. Okay, and it can also be written as I is the function of tan t, can be written as V naught by omega L sine omega t minus pi by 2. Got it? Because I got firstly cos omega t, so I have to convert cos omega t into sine omega t. So we can see that inductor is according to my first statement, inductor is lag pi by 2 by 90 degree according to this statement. Okay, let's talk about the XL and XC. So current lags pi by 2 voltage from the quarter cycle, peak value is Vm by omega L, defines inductive reactance. Okay, this is what Im equals to Vm by omega L. Vm by omega L means me V naught by omega L is what? It is the inductive reactance XL, that is called XL. Got it? And XL we can write as omega L also. So that is what rises linearly with frequency. So XL is the inductive reactance, inductive reactance that is defined as XL equals to omega L, which can be increased with the increasing of frequency. Average power through a full cycle will be zero, dissipated no energy. So we have read these kinds of things like this. V naught by omega L, it is also look like that's V by R, that is equals to I. So R is what? R is the inductive reactance, which is R not which we are not using R for this, we are using XL. Okay, this is also you can assume as a resistor due to inductor. So XL you can consider XL you can consider as omega L, and I max you can consider as Vm by XL, and I lags V by pi by 2. Let's see this question. An AC circuit contains a resistor R and inductor L in the series. If frequency of a source is increased in the current in the circuit. So it is again example of, you can say, series wise combination of resistor and you can say resistor and you can say inductor. So it is the variable voltage. So voltage equation is given as V naught sine omega t. Okay, that is equals to voltage across time t. So in series wise combination, can I write Kirchhoff law for this? So I can also write I1 voltage across this point, you can be written as Vt will equals to Vt, I can be write I multiplied by I is the function of time t multiplied by R, and again I can write L di by dt. Okay, I think we should consider this question after you can say solving this equation. Okay, this is also upon our next topic which we will learn. In AC, voltage of frequency F is applied to a circuit if the frequency is double the independence of the purely inductive circuit will be. XL can be written as omega multiplied by L. If we increase the frequency is doubled, then independence will be. If I double this frequency, omega comes to be 2 times of omega N, then independence becomes double. That is option B will be the correct answer. AC through a pure capacitor. A charged capacitor, again, Vt is the function of time t, can be written as Q by C. So it can be also written as Q can be written as I multiplied by dt. Okay, so Vt is the function of time t. Vt can be written as V naught sine omega t. That could be equal to C multiplied by Q, and Q equals to I into dt, di into dt. So mainly this di can be written as dv by dt. That can be written as Cv naught omega cos omega t. That is look like this. Charge can be written as like this, and I equals to dq by dt. So Cv omega V naught cos omega t, and this can be written as it is also written as I naught, and this also written as sine omega t plus pi by 2. Okay, so that is what this is saying to you, that inductive, you can say, current leads voltage by pi by 2. Okay, this equation mainly shows to you. So peak current will be I max equals to omega c multiplied by peak voltage, define capacitive, and reactance can be written as xc equals to 1 upon omega c. Got it? And falls with the frequency. If I increase the frequency, XL can be decreases. So average power at a full cycle will be 0. Dissipated energy will be 0. So XC can be written as 1 upon omega c, and maximum current can be written as IM will equal to Vm upon XC, and current leads V by pi by 2. Next question is, in an AC source is connected to a capacitor. If the dielectric is inserted between the omega plate, the current in the flow will be. So current can be written as Im equals to Vm upon Xc, and Xc can be written as 1 upon omega C. If I fill the dielectric constant, then means C nu becomes K times of C volt. So if D becomes K times of C volt, Xc becomes 1 upon K times of omega C. If it has becomes 1 upon K times omega C, that means Xc dash will equal to Xc upon K. So overall current will becomes Im will equal to Im dash Vm upon Xc dash, and Xc dash is what? Xc upon K. K will comes to the numerator. That is what? That is I dash. I initial. So Im dash will equal to I initial multiplied by K. And what is the K? If a dielectric element plate is in a distance, then current will be. Current is also increases up to K times. So option A will be correct. Let's solve this question by yourself. Is it your homework? Let's consider about series wise combination. Okay, so L RC circuit in the series in the combination as source Vm equals to Vm sin omega t, same current passing through the all elements at phasor. VR along V leads pi by 2 and 90 degree. That means main thing is that we are getting phase like this. Okay, this is current, and this is also Vm, this is also XL, and this is also XC, which are pi by 2. This is also XL, and this is XC. So net vertical distance will be XL minus XC. So I can write XL minus XC like this. So current, it is also, you can say, that is R, that is XL minus SC. The net reactance you will get under XL minus XC whole square plus R square. So that is called independence triangle, which I told you. Okay, at phasor, result voltage amplitude Vm equals to with the independence Z below. Current we will get Im sin omega t minus phi, and that is called independence reactance. So Z can be written as under R square plus XL minus XC whole square, and tan phi can be written as XL minus XC upon R. Here is the angle phi, and it is written as perpendicular upon base. So tan phi can be written as XL minus XC upon R. Got it? Resonance in the series circuit. Resonance is what, man? XL will equals to XC. That is called resonance. So XL can be written as omega L will equals to 1 upon omega C. So omega square will equals to 1 upon LC, and omega resonance frequency you will get 1 upon under root LC. Got it? So that is the key statement which you have to know. So at a particular frequency, XL equals to XC reactant cancel, independence becomes minimum, Z equals to R becomes maximum, I equals to Vm by R. Circuit is purely reactive at a resonance, so that phi equals to 0. Resonant angular frequency can be written as 1 upon under root omega C. That is the resonance angular frequency. Sharpness of the resonance measured by the quality factor. R is the sharp peak, and application turning of a radio, TV receiver, and to desired stationary. I can also say that what is the frequency of the, you can say, in the AC circuit. So you will write 1 upon 2 pi under root LC. That is your resonance pure frequency. Got it? Let's talk about this. Is also again solved by yourself. That is your home HW. This is also HW for yourself, and this is also HW. Do yourself at your home, and if you have any doubt, kindly ask me in the next time. Okay. So these are questions which we have to discuss. Let's discuss about the power in AC circuit. Power can be defined as a function of time t, can be Via voltage across time t multiplied by current across time t. So that can be written as, let Vm equals to Vm sin omega t, I equals to Vm sin omega t minus phi. Average power can be written as P equals to V I cos phi. Okay, that is the I is the RMS value. Okay, and cos phi is called the power factor, or you can say quality factor. Purely resistive, phi equals to 0, cos phi equals to 1, maximum power dissipated. Powerly inductive, capacitive, phi equals to plus minus pi by 2, cos phi equals to 0, no average power, but less current. And series LCR circuit, cos phi equals to R by Z at resonance, cos phi equals to 1. So that kind of thing you have to know. So cos phi equals to R by Z, that is power factor, and P equals to VI cos phi. Got it? So these are your thing which you have to know. Let's talk about the transformer. Transformer mainly used to decrease the voltage between two AC supplies. Okay. How it can be converted? It can be converted as a number of turns in a particular coil is directly proportional to, you can say, EMF generated inside the coils. So N1 by N2 in the transformers will equals to E1 by E2. That is the relation of the number of turns with the EMF which is converting. Principle is mutual inductance. Is changing current in the primary sets of changing flux that links the secondary coil and induced an EMF in it. Construction: two isolated coils, primary, secondary NS, would be wound and limited soft iron core. AC is primarily alternating flux core through induced EMF in secondary. For an ideal transformer, no losses of current. Vs by Vp will equal to Ns by Np, which I have already told you, and E1 by E2 equals to N2 by N1. Okay, that is called also current relation. So Vs by Vp, Vs means voltage across secondary coil upon voltage across primary coil, that will equal to voltage across secondary coil upon number of turns upon secondary coil upon one number of turns in the primary coil. And the current ratio is also same according to, you can say, turns ratio. Step up versus step down plus energy losses. Step up transformers, that is NS secondary coils number of coil are greater than number of coils in the primary coil, transformer. Okay, and that is the voltage relation. That is the few kinds of statement which you have to understand on the basis of number of turns and voltage. Okay, formula summary about AC, that is your formula which you have to know, and that is a recap of. Let's talk about the electromagnetic waves. Electromagnetic waves, I have already told you whenever I was sharing discussion about the optics. So in the optics, we have discussed is that light is the electromagnetic waves in which it have it have two fields. First one is electric field, that second one is magnetic field. Both are propagating to each other. Both are propagating to each other in you can say mutually perpendicular. Okay, so we can say that these kinds of wave are called electromagnetic wave. Introduction to Maxwell insight. So Maxwell shows some deflection regarding to an experiment. Let's say it have a capacitor like this. Two capacitors are connected with this, and it shows that whenever you are applying a voltage, then this positively charged capacitor and this negatively charged capacitor, and voltage across, you can say, whenever you are applying voltage, current I passing through this current, and then you can see that it also feels that and another current is inside the capacitor's place, that is called induced current. Okay, and that is called conduction current. Not induced current, that is displacement current. So according to Maxwell, why this displacement current has come? Consider a capacitor being charged by the current IC. Apply Ampere's law. Ampere's law mainly states the closed integration of B dot dl, that directly equals to mu naught times of I inside. So according to this Ampere's law, closed loop around the wire, surface a flat disk cutting the wire, I enclosed IC, B not equal to 0. Surface to belonged surface freezing between the plates, I enclosed equals to 0, but predicts I not equals to 0, B not equals to 0. Two valid surfaces give two different answers. Ampere's law is incompleted. Between the plates, there is no charge flow between the electric field, then it is changing with time. Maxwell is changing electric flux must be also produced by magnetic field. That means there is no charge is passing through this between plates. It means no current will be passing through this between plates, but practically we have seen that one current is passing through this, you can say, plate, that is called induced displacement current. So according to Ampere's law, that statement was got wrong. Got it? So displacement current on Maxwell's statement between the plates and the changing electric flux, phi will be equal to E dot dA behaves like a current. Maxwell name in this current, it's a displacement current. So ID can be applied as epsilon naught d phi by dt. It carries no charge, arises solely from a time varying electric field. In the engaging capacitor, ID between plates will equal to IC in the wire, so the total current in the continuous. No, Ampere's law is modified to indicate both conduction and displacement current. Both will be take part. Both will take part of it. So according to old Ampere's law, V dot dl, we are considered as mu naught I inside. But according to modification of in this Ampere's law, we can consider B dot dl will equal to mu naught current due to conduction current and current due to induced current, which is produces by due to changing the electrical flux. So that is the modification of Ampere's law, which we have written B dot dl. And ID can be written as displacement current. It is a displacement current whose value is E naught epsilon naught d phi by E by dt. Got it? So displacement current is given by, it's a direct formula based question. So ID can be described as epsilon naught d phi by dt. So option B is the correct answer. So here are some more questions regarding to this. It's your homework. So here are 4 important Maxwell equations you have to know for a vacuum. So Gauss law, it can be defined by, it can also written by the, you can say Maxwell equation. Closed integration of E dot dA will equal to Q upon epsilon naught. Gauss law for magnetism, closed integration of B dot dA will equal to 0. Faraday law, closed integration of A vector dot dl vector equals to minus d phi by dt. And Ampere's law, which is again modification by the Maxwell, closed integration of B dot dl vector will equal to mu naught IC plus mu naught epsilon naught d phi by dt. So inside the loop, 2 current will be take participate for producing magnetic field. First conduction current, and second one is displacement current. Got it? So here are the questions which you have to solve. So phi we have already given. You have to find displacement current. Displacement can be written as epsilon naught d phi by dt of due to electrical field. So you will be write tan t and multiply by epsilon naught. You have to find displacement current t equals to 2 seconds. So you will write t equals to value 2. So phi you will be get displacement current, you will be get epsilon naught 10 multiplied by 2, that will be 20 epsilon naught. So option A will be correct. Got it? How electromagnetic waves are produced? So mainly electromagnetic waves mainly produced when accelerated charged particle we have. So any accelerated charged particle can emit an electromagnetic wave. So at a stationary charge on electrostatics, electric field can be produced for a moving charge. Magnetic field can produce an accelerating charge or oscillating charge. It can produce magnetic field and electric field both. Oscillating charge at frequency V radiates electromagnetic wave with same frequency. This is how basic mechanism it intends. Radio, TV, mobile internet, tower. Once long the wave sustains itself, changing electric field which creates changing B creates itself. So mainly E by B ratio mainly refers to you C. C is what? C is the velocity of light in a vacuum. Nature of electromagnetic wave. So electromagnetic waves are transverse wave. E and B oscillate perpendicular to each other. I have already described to you. So this kind of thing I have already described. So Ex is the E naught sine kz minus omega t. So By equals to B naught sine kz minus omega t. Here is the equation of electric field and magnetic field, and here is the diagram of electromagnetic wave which I have showed in front of you. So key wave relation which I have told you. Wave number can be represented as k equals to 2 pi by lambda. Angular frequency, which is omega, equals to 2 pi f. Speed of EMF in the vacuum derived by the Maxwell equation can be written as C equals to 1 upon mu naught epsilon naught, and whose value will become 3 into 10 to the power 8, which is same as the speed of the light. Standard wave relation holds C equals to f lambda, that is the velocity, simply like V equals to f lambda. Frequency multiplied by wavelength, that will equals to velocity of the light, velocity of the wave. So electromagnetic have velocity C, which is equivalent to the light speed. So you can write C equal to V lambda. amplitude E and B linked at E naught by B naught is, that is equals to C. This is also saying to you that ratio of electric field and magnetic field in the electromagnetic wave will always equals to speed of light. In a medium of permittivity, epsilon naught and permittivity, in a medium of permittivity, frequency can be written, velocity can be written as 1 upon mu naught epsilon naught. Okay, that is the velocity. Okay, this kinds of thing we have discussed. So overall speed of the, you can say, in an electromagnetic wave can be written as 1 upon mu naught epsilon naught, and that is the relation between frequency with the velocity of electromagnetic wave, and it is the again ratio of the E naught upon B naught, that is maximum amplitude of electric field upon maximum amplitude of magnetic field, that will be equals to speed of light. So here are some questions which you can solve with the help of this theory which I have explained. You can easily answer about it. Okay, this is the electromagnetic wave related problem you have to solve by yourself. Okay, this is your HW. Let's talk about the energy, momentum, and properties of electromagnetic waves. EM waves carries energy, and energy is what? Energy density. So U can be written as UE plus energy carried by the electrical field and energy carried by the magnetic field. That will be equals to half epsilon naught E square plus B square by T2 mu naught. That is the energy carried by the electric field. That is the energy carried by the magnetic field. In a wave, UE will equals to UB. Okay. They also carry momentum, that is also written as P equals to energy upon speed of the electromagnetic wave. Exert radiation pressure on absorbing surface. Key properties: travel through a vacuum, no material medium needed. All EM waves travel at speed in vacuum independent of frequency. Transverse in nature, can be polarized. Obey reflection, interface, diffraction, all kinds of the phenomena it can be done. The electromagnetic spectrum, it is the spectrum on which so many waves are having some according to their range, and they have according to the range of frequency, they have their own different property. And the range, which is 4 into 4 to 7 10 to the power minus 10 to the power 14, this is the range of visible frequency. If any wave who have a range inside the visible range, then we can see this range. These are having in the visible spectrum, so we can easily watch of them. So EM waves different only wavelength, frequency, and speed in the speed in vacuum. Arranged from low frequency long lambda to high frequency. Radio waves, microwave plus infrared plus visible waves, all of these kinds of waves are including as the electromagnetic waves. So it is the spectrum. So radio waves and microwave, infrared is the key information regarding to these waves. You just read about it and getting information regarding to this. Okay, and visible and ultraviolet rays, these are also talking about the rays. So with these are all theoretical, so that you can understand about it. Electric and magnetic field in the EM waves are related as E by B. I have already told you that C, and E equals to B times of C. So correct answer is B. Okay. So here are some practice problems regarding to this. You can be solved. Let's talk about the EM spectrum, source, and main users at glance. So these are the some waves name which are producing by some particular types of sources, and here are their use cases. So these are really important for a theoretical type of question. It's just informative, so that you have to know. So these are all about the electromagnetic waves. Let's talk about the dual nature of matter. Dual nature is matter for what? When any matter who close to the light speed velocity, it will also radius some wave. It will also radius some wavelength. Also, it will, or you can say it will also radius some wave. This wave is called de Broglie wavelength. Okay. So it is talking about the modern physics. So electron emission and work function. So main thing, what is a work function? The minimum energy required to an electron to escape from the metallic surface. So this thing you can consider as a, you can say, photoelectric effect related relation. So in the photoelectric effect, we can see that whenever outermost, when incident light having certain type of frequency of energy so that electron can be ejected from the metallic surface easily. That type of frequency is called threshold frequency. So work function mainly refers to that it's the minimum amount of energy so that we can eject the electron from a metallic surface. Got it? So this is called, for cesium metallic work function is 2.14. So it is the required energy so that we can eject electron from the metallic surface. Let's talk about the photoelectric effect. Photoelectric effect mainly shows to that when any incident light incident on a particular metallic body, then due to cancel out their some work function and remaining energy will get to the electron, and with the moving of electron, current can be transferred, current can be moved in the particular circuit. So photoelectric effect mainly refers to that we can easily eject the electron from the metallic body with the help of just incident of light. That is the called of photoelectric effect. Ejection of electron by light by suitable frequency. Definition: emission of electron from a metal surface by light of sufficient frequency falls on it. So here are some setup by which we can say that electron can be ejected by the light. Executed glass tube, emitter, collector, monochromatic light, variable DC source, and microammeter measures the photo current. Effect of intensity on photocurrent. So how intensity is related to the photocurrent? So current is directly proportional to intensity. Got it? So if higher intensity light emit on the particular, you can say, metallic body, then higher current will be produced because more electron will be free during the you can say photoelectric emission. Okay. So experimental observation, keep frequency V and collector we fixed and vary intensity of incident. So if we fix the frequency and potential across the, you can say, light metallic body potential is constant, then we can see that due to intensity increasing, current is directly proportional to intensity. Okay, so these kinds of things we have discussed, and this is the graph when intensity is directly proportional to current. Let's solve this problem. A light of wavelength is 400 nanometer incident on a metallic surface whose work function is given as 2 electrons, the maximum kinetic energy emitted by the electron. So mainly according to photoelectric effect, incident light wave energy, photo energy HV, will directly divided into the work function plus kinetic energy of the electron, that is K max. Got it? So it can also written as SC by lambda. So that is equal to phi naught plus K max. After using this equation, you can solve this question. Okay. So let's solve this question by yourself. Now, effect of potential on photocurrent. So accelerating potential V plus as V on collector is increases, current rises and reaches saturation. So that is the graph which I told you. Initially, potential is negative. When you increase the potential, current has also increased. But after such a value, let V naught, potential at a certain potential limit, current becomes constant. Okay. So all emitted photoelectron are now collected. Retarding potential reverts the polarity, current drops and becomes zero at the stopping potential. Stopping potential denotes the minimum retarded potential at which photo current becomes zero, where it depends on the current electricity intensity. Okay, so Kmax can be written as EV naught for this case. So if stopping potential for a certain metal is 2 volt, frequency of incident light is double, then the stopping potential will be. So in the stopping potential case, Kmax will become 0. So totally you can say what? Okay, frequency of incident light is double than stopping potential. So on that time, stopping potential will totally depend upon the light of incident. That is stopping potential. Okay, so for certain potential that is 2V, if frequency of incident light is double, frequency it means HV will equal to directly potential, stopping potential. So if I increase the frequency, that means 2 times, then potential will also increase by 2. So correct answer is B. Let's talk about the effect of frequency and threshold frequency. Stopping potential V naught versus frequency V. Key observation: for each metal there is a minimum frequency V naught, that is called threshold frequency. Below V naught, no emission, however intense the light. Above V naught, stopping potential V naught grows linearly with V. Slope V naught, H by E, same for all metals, intersect on V axis. That means that is the graph which is showing this all kinds of statement, which is understandable for yours. So key experimental of photoelectric effect mainly told you threshold frequency, instantaneous emission intensity, and dependency to the current, frequency of a K max, material dependent of V naught, and saturation of current. Failure of wave theory, hierarchy, you can say prediction on which wave theory will actually fail. So mainly wave theory of the, you can say, uh, light cannot be describe the photoelectric effect of the, you can say, current. Okay, so it could be actually understand with the help of particle nature of light, in which light is the combination of particles, and these particles are called photon. Okay, so these kinds of reasons you can be understand by yourself, you can understood. Okay, so Einstein photoelectric equation is written like that, which I have already explained you. Incident light on the photo on the particular metallic surface. So energy of the incident light can be written as phi naught plus k max. Phi naught is the work function, and k max is the maximum kinetic energy attained by the electron. Got it? This is the Einstein photoelectric equation. So a metallic metal has work function 2 electrovolt of energy, 5 electrovolt falls in the, what is the maximum kinetic energy. So incident light energy will equals to pi plus k max. So if you want to find k max, so k max you can be write as incident light energy minus phi naught. Okay, so incident light energy is 5 electrovolt and work function is 2 electrovolt, then kinetic energy will be 3 electrovolt. That is your answer. What is, here are a few questions which you have to solve by yourself. Let's talk about the nuclei. Nuclei is, let's talk about the photon and particle nature of the light. So photons energy can be assumed as a energy is quantized of the photon. So we can energy of photon can be written as Sc by lambda, or you can say Hv, and V is the frequency. Okay, so momentum of photon can be also, we can write as H by lambda. That is the, you can say, momentum of the photon. That is also see that Hv by C in terms of frequency. Rest mass of the photon is 0. Speed of the photon will be 3 into 10 to the power 8. Charges electrically neutral, and number intensity. Intensity means number of photons per second are increasing. Increasing, what is showing? Increasing mainly showing that number of photon per second emitting on the metallic body. Okay. Dual nature of radiation, I have already told you. Light behave a wave as well as particle also. So that is wave nature, that is particle nature. Particle nature, like you can say photon, and wave nature, which we have already studied about interface, diffraction, polarization, and diffraction and reflection. Let's talk about de Broglie wavelength. So de Broglie wavelength mainly defined as any particle which have particular momentum, then it will emit some waves, and this wave is called de Broglie wave. That is called also matter waves, and their wavelength can be defined as de Broglie wavelength. Lambda d can be h upon p. This is the de Broglie wavelength. So here is the formula to find the equation of the de Broglie wavelength. So an electron accelerated through a potential difference 150 volt, lambda is directly proportional 1 upon frequency. Then compared lambda 600 volt, the ratio of lambda 1 and lambda 4. I think you have to solve this question by homework. So with the help of direct formula, you can solve this question easily. Let's talk about an electron has kinetic energy K becomes 4 times of K. De Broglie wavelength becomes, so momentum, relation between momentum and kinetic energy can be written as P equals to under 2m K. So de Broglie wavelength K, we are writing P upon H upon P. Okay, so lambda can be written as H upon under root 2m K. So de Broglie wavelength mainly inversely proportional to square root value of K. So if kinetic energy increase, kinetic energy scale lambda 1 is already given. If kinetic energy increases, then it is decreases. So new wavelength becomes lambda by 2 because it has a square root value. So 4K convert to the 2K. So de Broglie wavelength, significance and scale. Electron, it has de Broglie wavelength like this. Proton, it has de Broglie wavelength in the picometer. 1 picometer equals to 10 to the power minus 12 meter. And dust grain, it has also cricket ball. It has wavelength like this. And this is very smaller wavelength. Okay. Formula recap. These are all formula which you have to understand. Let's talk about the atoms. What is the nature of atoms inside the particular matter? So Thomson plum pooling model, mainly atoms we can't be classified in the late 19th century. We don't know what are the atoms. So in the plum pudding model of the Thomson mainly state this atoms is just like a plum pudding in which plum it is it can assume like a watermelon example in which the seeds of watermelon is like an electron and rest of the mass of the watermelon that is called as a proton. So this theory was the Thomson theory which was developed on the 1898 and it was totally wrong because electron cannot be total mass cannot be act like this. Total mass can be concentrated as a center and electron can be moved in the particular circular direction. So this model has failed because it does not explain few things regarding to a actual definition of, you can say, atoms. So atom is the sphere of uniform distributed positive charge electrons embedded in the positive spheres in like seeds of watermelon. Total positive charge equals to total negative charge. Atoms are neutral. That is the true thing which he told. And it was the first attempt to explain the internal structure of the atom. It was the first attempt to showcase the internal structure of the atom, account for the neutrality, but could not explain spectral line or large angle scattering. That was the Thomson's plum pudding model. Okay, let's discuss about the question. In a Thomson plum pudding model, atoms is assumed as a dense and nuclei with the electron outside, a positively charged sphere with embedded electron. That is your answer. Correct answer is B. And this is again according to plum pudding model, alpha particle passing through the atoms would be reflects at large angles, passing under unaffected, shows small deflection, reverse direction always. So option D will be correct because according to plum pudding model, total positive charge as like a sphere. So if any alpha particle collide with their alpha particles also having +4 charge. So +4 both repel to each other, then it will again reverse direction to the always. So option D is the correct answer. Let's talk about the Rutherford's alpha particle scattering experiment. This experiment mainly showcases to you that the structure of the atom, how it's look like. So this alpha particle scattering model showcasing to you that whenever you are whenever a particular zinc slit you are applying in the particular area, and if you are throwing a helium +2 alpha particle to him, then some particles are deviate with a certain angle and some particles can be passed throughout the coil, and one of particle having producing 180-degree angle from the initial point. So that means it's telling to you that 180-degree rotation can be occur when same repulsion force are acting in the opposite direction. That means this is a proton and this is alpha particle, both are collide. Then on the time it come back to this initial position. That means only one alpha particle comes to the initial position. Rest of them are moving to the different angle. That means atom's mass is totally centralized with a particular center, and the remaining things to be happen is to empty. That kind of thing we have it was described by the Rutherford. Okay, so here are the key statements regarding the Rutherford which he has told. Observation told of almost 99% alpha particle passed straight throughout the unaffected. A small fraction were deflected by more than 1 degree. A very few in 8,000 to 1 were deflected by 90 degree. Some even bounded straight back. Rutherford remarked, if you fired a 15-inch shell, a piece of tissue paper, and come back to it, Thomson uniform positive charge model could not be explained about this. Obviously, because according to Thomson model, if it has totally positively charged atoms structure present, then it should be also providing 180-degree deflection from the Rutherford observation. So most of the alpha particle will not deflected by, you can say, some 180 degree. Only one particle deflected to the 180 degree. That means all total positive charge can be concentrated at the center, and rest of the mass is empty of the proton. Got it? So Rutherford nuclear models of the atom, its state atom has very small, dense, positively charged core called as a nucleus. He told first time nucleus is present inside the proton. Almost all the mass of the atom is concentrated in the nucleus. Electrons revolve around the nucleus in the orbit like planets around the sun. Okay, most of the atoms are empty space. That is also told you. It has also showcased the radius of the atom, that is 10 raised to minus 10 meter. Coulomb force between the alpha particle nucleus. Due to Coulomb force, this alpha particle comes to the its initial position. Drawback of Rutherford model: classification electromagnetism, see an accelerating part must radiate energy. That kind of thing will not explained by the Rutherford. And these are fall 2 to 3 types of, you can say, theoretical concept, theoretical, you can say, statement regarding to drawback of Rutherford's model. So it is the sum of questions. Kindly solve by yourself. It is your homework. This is again your homework. It is also formula based question. Let's talk about the atomic spectrum. Hot, rarefied gas emits only certain wavelength emission line spectrum. When a white light passes through a cool gas, the same wavelength are absorbed. Absorption spectrum. Dark lines are on a rainbow. Every element has a unique set of lines. Its atomic fingerprint. Balmer found empirical formula of hydrogen visible lines. Line spectra indicate that atom emits absorb only discrete energy. So that kinds of thing we can understand in the atomic spectrum. So atomic spectrum, during the atomic spectrum, when it is mainly told to you that when electron comes to the higher energy cell to lower energy cell, it radiates some energy. And when electron comes to the lower energy cell to higher energy cell, then it gets some energy. And this energy can be transferred as a form of photon energy. So that can be called Sc by lambda will equals to 13.6 Z square by N square, like this. Okay. So for hydrogen like atom, electron radiates energy like this, 13.6 upon N square to reaching a particular excited state. Okay, so it can be given as a 1 upon lambda for lambda emission when electron moves to the excited state to lower higher excited state. Then it will be given as 1 lambda equals to R 1 upon NF square minus 1 upon N initial square. Got it? And R is the Rydberg constant, whose value is 1.0197 multiplied by 10 to the power 7. So that is the lambda emission when electron goes to the higher lower excited state to higher excited state. Needs for new model. So Rutherford model did not correct classify the understandable things of the, you can say, exact value of spectrum. It cannot explain why atoms are stable. It cannot explain why atoms emits only discrete wavelength. A new model has allowed certain orbits stable without radiating. Quantize the allowed energy. Link the discrete line spectra to the energy transition. Bohr 1993 combined classical mechanics and Planck's quantum idea. So Bohr mainly states that hydrogen-like atoms, we can consider 3 things: proton, neutron, and electron. So proton is the positively charged particle considered as a centralized, and electron are revolving around the, around the atoms. Okay. And the angular momentum of electron can be quantized as a form of nh upon 2 pi. Okay, this kinds of thing has described by the Bohr's model. So angular momentum can be described as nh upon 2 pi, and energy can be shared by the, you can say, Bohr model. HV will equal to E initial minus E final. It's also share you something. The energy difference to move from lower energy cell to higher energy cell, that will be equal to as a photon's energy. Okay, Radius of the nth orbit, which is described as 0.529 z square by n, that is your energy. That is the radius of the, you can say, shell. Okay, z is the atomic number, n is the number of shell, and energy can be described as the 13.6 z square by n square. That is the energy of an electron of a particular shell. And velocity of a particular in a particular shell, we can be written as 2.2 multiplied by 10 to the power 8 n square by z. That is the velocity of the, you can say, velocity of, you can say, it is the velocity of electron at a particular cell. Okay, so these kinds of things we have discussed. So radius is the square root value, radius can be written as n square by z, sorry. Okay, and z square by n, it is the velocity. Okay, so here is the velocity, and here is the, so radius is directly proportional to n square, and a naught is the radius of the first cell. Energy of the stationary states I have already given to you. That is also minus 13.6 z square by n square, and z for 1 for hydrogen. So for hydrogen like atom, energy will be very like this. Ground state, excited state, and ionization state. Ionization state, I have already explained to you that ground state means energy at a per initial state, that is called ground state. First excited state, that means n equals to 2 of a second orbital energy. And second excited state, that is equal to n equals to 3 of a third valence cell energy. And this energy is decreasing. This energy is increasing by increasing the number of cells. Ionization energy is what? Energy is such type of energy whenever we are ejecting the electron from outermost cell to the infinity. That energy is called ionization energy, and ionization energy of the electron will be 13.6, that is hydrogen. Okay, so these kinds of things we have discussed. Here are the energy level diagram. You can identify that for n equals to 0 to 1, energy gap is more. N equals to 2 to 3, energy gap becomes less, again less, again less, again less, again less. That means whenever number of cells increases, energy gap between the, you can say, cells are decreases. That means an electron can easily passing through the outermost cell to the lower outermost cell easily, because due to lesser value of energy cell. So H, again this energy cells, you can say electron transfer to the first cell to other cell. This energy transfer, or you can say energy difference, can be classified as you can say form of energy of photon. Okay, successes and limitation of Bohr model is explain stability of the hydrogen atom. It also explains the stability of hydrogen atom. Correctly predicted the wavelength of the all hydrogen spectral series. Correctly gives the value of ionization energy. It has also correctly gives the ionization energy, which is 13.6 electrovolt. Work well for hydrogen like atom, like helium plus, lithium plus 2, by replacing E square equals to Z square. Okay. So here are some few questions regarding to this Bohr's model. You can solve by yourself. That is all formula based question. Let's talk about the de Broglie wavelength with the help of Bohr's quantization. So again, same thing, de Broglie wavelength can be explained as h upon p, and this kinds of statement we can assume that de Broglie, every particle momentum p has matter waves, which has already explained by the de Broglie. For the orbital stable, the electron must have standing wave around the nuclei. Condition circumference equals to whole number of wavelength. So 2 pi Rn equals to n times of n lambda. So n is the number of cell that is called as the orbital. Rearranging MVR, you will be get NH upon 2 pi. That is exactly Bohr's second postulate. So this quantization energy neutrally from the wave nature of the electron. So 2 pi Rn can be written as n times of lambda, or lambda equals to h upon mv. That is your wavelength. So these are again your one more statement which you have to solve. So this is the ending of the atomic physics, okay, of your chapter. Let's talk about the semiconductor. These are also very important chapter for your examination purpose. Semiconductor, I have already explained to you. Semiconductor mainly does not follow the Ohm's law. Okay, so classification of conductivity. So classification of conductive solids are classified as resistivity, okay, conductivity is sigma equals to 1 upon rho. That is, I have already explained in the current electricity. Different material having different value of resistivity. Higher resistivity means conductor substance showing conductance. Okay. So if resistivity high, that means it is going to the insulating property. Energy band theory. Energy band theory, I have already explained to you. Every particle having some particular type of energy bands: valence band and conduction band. Conduction band, it is the energy, it is the such type of energy band in which electron can easily freely move inside the throughout the material. So it have some difference between them. Valence cell to conduction valence band is such type of energy band in which electron can be directly bounded with the nucleus. So if we provide a such type of energy, so the electron can be transferred to the valence conduction band, then any particle can be show conductance of electricity. Okay, energy band theory mainly refers to you this kinds of thing which I have already explained you. Okay, so here is the energy gap that was I told you. So if energy gap, if you are providing energy is more than one electron volt, then electron can easily transfer to the conduction band. After that, it can show. You can say after that it can show your. After that, you can show your conductance conductivity of electricity. Or in the, you can say, in the metallic conductor, no energy gap has required. So electron can easily transfer to the conduction band. In semiconductor, they have certain value of energy gap, but in insulator, energy gap is too high, up to you can say 3 electrovolt. So intrinsic semiconductor. What is intrinsic semiconductor? So intrinsic semiconductor says silicon and germanium crystalline in the diamond structure. Each atom has 4 valency electron. Each atom 4 covalent bonds sharing electron with neighbors. At T equals to 0 Kelvin, all electrons are locked in bond. No free carriage behaves as an insulator. At temperature carries to T equals to Kelvin, thermal energy breaks bond, creates electron holes pair, and extraneous semiconductor is pure upward. That is the theoretical kinds of thing which you have to understand. Electron hole and extrinsic carriers concentric. When a bond break, free electron moves into the conduction band. The empty sides behaves as a hole with the effective plus E charge. Both contribute to conductivity. I can be contribute as I electron due to moving of electron due to moving of hole. In statistics material, n equals to number of holes, which means number of electron equals to number of holes. Interesting carrier concentration. Mass of action law always true. Number of number of holes plus number of electrons, that will equal to n into I square. So that is a few things which you have to understand. Number of holes regarding to current. Okay. Extrinsic semiconductor, that is called conductivity of a pure silicon at 300 Kelvin is too small for useful devices. Doping is what? Adding a teeny amount of specific amount impurity, 1 part in 10 to the power 6 to 10 to the power 8. Two kinds of dopant, pentavalent and trivalent. These are the kinds of doping which you have to understand. Okay. Let's talk about the N-type semiconductor. Pure silicon and germanium, tetravalent dopant, pentavalent phosphorus, arsenic, and you can say SB is some kinds of other material. I don't know regarding to this, but it has also some kinds of semiconductor dopant which is used to increasing semi-conductivity of a semiconductor. Okay, 4 to 5 valence electron from the covalent bonds. The fifth is loosely bound, easily freed. Donor level E and D lies just. These are all theoretical points which you have to know. These are all theoretical. Okay, no numerical will become inside your examination. Just theoretical inside will become inside your examination. Let's talk about the P-type semiconductor. Dopant, trivalent, boron, aluminum, indium are acceptor. It forms only 3 covalent bonds. One bond position is vacant, that is called hold. Acceptor level E has lies E and B accepted electron from the BB, creating mobile holes. Majority carries holes, number of holes. Minority carries electrons, and number of holes is greater than equals to number of electron in this and P types semiconductors. Okay, let's talk about the band diagram. So it is the band diagram in intrinsic, N type and P type. So band diagram is written in front of you, that it's like this. So in this scenario, valence band electron can be transferred to the conduction band. But in this scenario, conduction band electron transferred to the valence band. Okay, it is the donor. And again, this is the energy gap between them of intrinsic semiconductors. Formation of p-n junction. A p-n junction is formed when the p-type and n-type of materials share common obstrict crystal boundary during fabrication. Two processes happen at the junction. First, diffusion. Second, drift. Majority carries diffuse across holes P to N and electrons transfer N to P. Okay. Immobile ionized donors positive and acceptor negative are left behind depolation region. In equilibrium, one diffusion equals to one drift equals to no net current happened. Okay. So these are the formation of NP junction diodes. NP junction diode. Okay. Depletion region and barrier potential. Width of the depletion region is 0 to 1 and 1 micrometer. Across this region, the built in the field creates a barrier potential V0. Typical value V0 equals to 0.3 volt as germanium and V0 equals to 0.7 volt as a silicon. V0 opposes further diffusion of a majority carriers. Minority carriers can, however, be swept across easily. An external bias shifts the delicate balance, producing the diode action. So here is the key factor V0 for germanium, it is 0.3 volt, and V0 for silicon, that is 0.7 volt. Let's talk about diode, which is forward bias. P side, plus terminal battery of the battery, N side is a minus terminal of the battery. External field opposes the built in the field. Net barrier reduces so to V0 minus B. Majority carriers are pushed towards the junction. Depletion reverts, region narrows. When V is greater than threshold frequency, then 0.2 volt germanium is directly equivalent, and it also is for silicon 0.7 volt for silicon. Large current flows like milliampere to ampere range. Current grows approximately exponentially with the applied V. So the diagram with the applied voltage is current exponential growth like this. Okay, and this exponential diagram for forward bias. Okay. So let's talk about diode, about reverse bias. P side terminal is negative, N side terminal is positive. External fields adds the built-in field. Barrier grows to V0 plus V. Majority carries are pulled away. Depletion region widness. Only the minority carries can across very small reverse saturation current mu ampere, almost independent of V until V reaches the breakdown voltage, that is called BR, sharp rise in I. Unless especially a Zener large reverse current can destroy a normal diode. Got it? And this is the VI character of PN diode. That is the graph which you have understood. Got it? That is half wave rectifier. Uses single diode in a series with step down transformers and load RL. During positive half cycle input AC, diode forward biased current through R to L. During negative half cycle, diode reverse biased almost no current. Output across R, L and is pull setting DC are passed. Output frequency will equal to input frequency, that is average output voltage is low. Is it understandable by yours? So this is the few things regarding to rectify. These are all your theoretical part which you have to understand whenever you are preparing for your example. Okay. So no numerical will become regarding to this chapter. You just understand about their theoretical coverage, just information. All of this part are just information only. So let's talk about the full wave rectifier. Uses a center trapped transformer plus two body D1 and D2, positive half D1 towards biased current through R to L in one direction, negative half D2 forward biased current through R to L in the same direction. Output both halves are rectified. DC pull stage at 2F doubled the input frequency, more efficient than half wave. Both half of AC are used. Alternative bridge rectifier and four bodies, no center tape required. So these are the diagram of your full wave rectifier. Let's talk about the capacitor filter. So capacitor filters to make the ripple. Rectifier output of a pulse setting DC, a capacitor in parallel with air R L smooth it during rising half cycle. When input dips, see discharge slowly through RL, sustaining the output. Choosing R to L C period, very small ripple. Result nearly steady DC suitable for running electronic circuit. So these are the diagram regarding to this. Okay. So here are some basic questions regarding to this. You just solve by your theoretical understanding. Some basic example regarding to this. So these are all your homework. Okay. So I think chapter has ended or not. If one time we can see. These are all your homework. So by ending this chapter, I think your complete class 12th syllabus has completed. So these are your summary of your chapter which you have to understood. Okay. So this chapter is mostly your totally based upon your, you can say, theoretical nature. So I think your 12 class 12 syllabus has totally completed for your 2 days marathon classes. So everything which I have shared in front of you in during the class, whenever I am showcasing to you, you can say this PDF. So with the help of this PDF, if you have any question regarding to this, you can ask me. I will answer to every question, and after that we can end this class. Anyone who have any anyone who have any doubt regarding to this explanation, you can ask me. After that we can end the session. Any doubt? Okay, someone is replying, sir, can you repeat? No, sir, can we get the PPT? Yes, you will get your PPT with your app, and I will talk to operational team so that they will provide your PPT. Okay, so I think nobody has any doubt, and I think time has gone up to 7:30, so you should take also rest, and also you should take some revision regarding to class 12 today's lecture. After that, we in the next class we will continue with some more few topics, and else I will take some your doubts so that you can resolve your query and do your best in the examination. So I think we should end the today's class. See you later in the next class. Okay.